Learn how to build a complete 2D pixel art tower defense game in Unity from scratch. This step-by-step tutorial guides you from a blank project to a fully playable game with a main menu, multiple tower types, enemy waves, and 3 unique levels. You'll learn how to create a modular, data-driven system using scriptable objects to manage towers, enemies, and waves, plus how to design forest, lava, and jungle levels with Unity Tilemaps. You'll also learn how to export and publish builds for Windows, Android, and web. Frank Dvorak developed this course.
Do you want to make your own pixel art games in Unity, but don't know where to start? In this tutorial, I'll show you how to create a complete minigame with a main menu and 3 unique levels. We will have multiple tower types, enemy types, and different environments to keep it interesting. I will show you how to structure everything in a simple, expandable way using a data-driven approach with Unity's Scriptable Objects. We'll go step by step to make sure everyone understands, and I will provide full source code after each step, so no one gets lost along the way. I create a new blank project with universal 2D render pipeline. I'm using Unity 6, but you can use any Unity version you want, it doesn't matter. We will first build the entire game using placeholder art assets, and then we will add pixel art at the end. But you can use the same code base with any graphic style you want. I'll also show you how to create hundreds of different pixel art characters using this powerful tool, and how to animate and use them inside your own games. Let's jump in and make a complete, fully playable minigame with 3 increasingly difficult levels plus an endless mode, and learn how to export the playable Windows, mobile, and web build. In Assets Scenes, I rename my scene to Game. Inside the Assets folder, I create a new folder I call Art. You can download all art assets in the Resources section below. I'll start with this simple spreadsheet, where I have one frame representing an enemy and another frame representing a point along a path. With the image asset selected inside the Inspector tab, if you're using pixel art like this image, you want to make sure it's not blurry. So we set filter mode to point no filter and compression to none. I click Apply, I open the sprite editor and slice, grid by cell size. These frames are 100 × 100 pixels. I click Slice, then Apply. Now I can use this little arrow to expand the sprite sheet and see individual frames. Here in the hierarchy window, I see all the game objects that make up my game scene. I can right-click and create an empty game object. I call it Path. Every game object in Unity has a transform component, which defines the object's position, rotation, and scale. We can use these tools here. For example, I can select the Move tool to move the object around the scene. And when I do that, its position values change. I can also right-click and reset transform to center the object in the middle at coordinates 0, 0. So this is the game scene. This white rectangle represents the visible game area. If I open the Game tab, this is what the game will actually look like when played. In my Art folder, I can expand my sprite sheet. If I drag and drop this frame into the scene, Unity will automatically create a game object for it. Unity will also automatically detect that this game object has an image. So on top of its transform component, it will also give it a sprite renderer component, where we can do many things to handle and adjust the image. I will rename the game object to Waypoint. With the Waypoint game object selected, I can use the Move tool to move it around the scene. Doing that will update its X and Y position. I can also set the object's position manually by changing these values here. On the Game tab, this is what our game looks like so far. I'll change the aspect ratio to Full HD for better rendering, and I'll zoom out using this scale slider. I like to keep my small game preview down here. Now, when I make changes to the scene, I can instantly see how those changes affect the playable version of my game. Now that we understand the basic Unity layout, let's build something more interesting. Inside my Assets folder, I create a new folder I call Prefabs. I can drag and drop my Waypoint game object into this Prefabs folder, turning it into a reusable game asset. Prefabs are pre-configured, prefabricated game objects. Let's say I have a game object like this Waypoint, and I configured it in a specific way. Now I want multiple of these game objects, all configured the same way. Instead of repeating the process over and over, configuring them one by one, I turn it into a prefab and I can duplicate it as many times as I want. Notice that after turning it into a prefab, it changed color. I can delete it from the scene now, and I can just drag in as many as I need. If I want to make change to all of these copies, I can just change the main prefab in assets, and it will update all of them. I delete these, and I leave just one for now. Game objects in Unity have components that give them special functionalities. Unity has many components we can add, and we can also create completely custom script components to write custom logic. So let's say I want to write a simple script that connects all of our waypoints with a line, and I want enemies to move and follow along that path. Inside Assets, I create a scripts folder. In Unity, we use the C# programming language. Let me show you how much you can achieve with just a few simple lines of code. Inside the scripts folder, I right-click, create, and I choose a MonoBehavior script. I call it Path. Be careful here, you can't just rename this file later, because Unity will use that name to define the class inside the file. So make sure the name of your file and the auto-generated class name inside it match. I select the Path game object, and I attach the Path script as a custom component, like this. I double-click the script file, and Unity opens it in my default code editor. If you've never heard of MonoBehavior before, all you need to know is that it's a special Unity class that allows us to take scripts and attach them to game objects as components, just like we did, and make the code inside that script interact with that game object and with others in the scene. MonoBehavior is a fundamental building block of Unity. You'll see it all the time. MonoBehavior also gives us access to so-called lifecycle methods, useful code blocks where we can put our code depending on when we want that code to run. You can also see that Unity created two most important methods. Inside the start method, we can put code we want to run only once at the beginning, and the update method is where we put code we want to run over and over. There are many more built-in lifecycle methods, and we will use some later on. For now, to keep this clean, I will delete them and I will just declare a variable. We are inside a custom path class we created. I want a variable that will hold an array of waypoints so that we can connect them together and send enemies along that path. In C#, we define variable this way. We start with an access modifier. If the variable is public, then everyone can see it. Or if it's private, it's accessible only from this script. I need my waypoints to be available from other scripts, so I set the access modifier to public. The second word defines the type of value this variable will store. In this case, it will hold an array of prefabs. Each waypoint is a prefab, and prefab is a game object. Square brackets mean it will be an array of game objects. And the last part is whatever I want the variable to be called. So, who can access this variable, what data type it holds, and what name we give it. In C#, we define all variables like this. If I save changes and go back to Unity, on the path game object, inside its custom script component here, I see that waypoints variable. It's an array, so I can click plus to add elements to it. Because of the variable type we defined, you can see these fields expect a value that is of game object type. I go to the prefabs folder, and here we have a waypoint prefab, a pre-configured, prefabricated game object. I will need 5 of them in total, so I drag them one by one into the scene until I have 5 copies. I select the path game object again, and I will drag this first waypoint into the first field in the array, like this. Waypoint 1 game object into this field, and I do the rest. Ideally in the same order, so we have an increasing sequence of numbers that matches the order in the array. This icon is to show and hide gizmos. In Unity, gizmos are visuals that appear in the scene view, but not in the game view. We will use gizmo lines to visualize our path connecting the waypoints, and then we will make enemies move along that path. So let's make sure we have gizmos enabled, and let's open our path script. Unity has a built-in method called OnDrawGizmos that we can use to draw visuals in the scene view to help us design or debug our game. If this waypoint array has some elements in it, if the length is more than 0, I create a for loop that will cycle over all the elements in the array. We set the color to gray, and for each of these waypoints inside the waypoints array, we will draw a line connecting them. Unity has a built-in Gizmos drawLine method that takes the start point and end point, and it will draw a line between these two positions. So I want to start the line at the position of the game object at this index. I access its transform position, and I want to end the line at the position of the next waypoint, so index +1. As we cycle over the array, this index value is increasing by 1, and we are drawing lines between the waypoints. When we reach the last index in the array, there will be no index +1 anymore, so that would give us an error. So I only want to draw these lines until we reach the second to last element. Only draw the lines between this and the next index if the index is the length of the waypoints array -1. Let's save that. You can see a line connecting all our waypoints. Now I can select individual waypoints, and I can use the Move tool to modify my path in any way I want. Maybe I will have some tile map behind, and I will make sure this path matches a road in the artwork that I want the enemies to follow. Notice that because the line is drawn using gizmos, it's visible only in the scene view, but it doesn't render in the game view, which is exactly what we want. I left-click the first waypoint, and I shift-click the last one, selecting all the game objects in between. I will parent all of them under the path game object to keep the hierarchy organized. I can also rename this to path 1, because we can create multiple different ones in our game later if we want to. With path 1 selected, I use the Move tool, and I can also move the entire path now, like this. I can select individual waypoints to modify them in any way I need. This technique is extremely useful for tower defense games, racing games, as well as something like MOBAs, such as League of Legends, where you have NPC minions moving automatically along the lanes. You can use the same exact technique we have here for a 3D game as well. Maybe I also want to give the waypoints some labels, so I can easily see at a glance which waypoint corresponds to which game object. Inside OnDrawGizmos, I can do that here. If we want to define styles for our text in Unity, we can use the built-in GUI style class. GUI stands for Graphical User Interface, and we can use this class to define visual styles, fonts, colors, alignment, and so on. Now I can take that style and I set its normal text color to white. And most importantly, I set alignment to middle center because I want the text to be horizontally centered around each waypoint. I can draw text using handles built in Unity class. We need to include the Unity editor namespace up here to be able to use handles. Handles.label will let us draw a label in the scene view. We pass it 3 parameters. Where we want this label to be drawn, I want it at the position of the waypoint it belongs to, plus 0.7 units above it. The second parameter is what we want the label to say. I will make it display the name of the game object. We can see the names in this field here. And finally, as the third parameter, I apply our custom style we just created. If I save that, you can see we have little labels above each waypoint. In the game view, none of this will be visible. Perfect. Now, let's bring in some enemies and make them walk along this path. Inside Assets Art, I have my sprite sheet, and one of the frames is this simple enemy silhouette. I drag and drop this frame into the scene, and I rename it to Enemy. We can replace it with animated characters later, but first, let's focus on the pathfinding logic. I go to Assets Scripts and create a new folder I call Enemy. Inside, I create a new MonoBehavior script. I will also call it Enemy. With the enemy game object selected here, I drag and drop the enemy script here as a custom component. I open the script, I delete all this code, and I will define a variable here. I start with serialize field in square brackets like this, and private. The type will be float, which is a decimal number, a number with a fraction part. I will call my variable move speed. I will also give it a default value, for example 3f, f for float. We know we have public variables which are accessible from other scripts, and they are also displayed here in the Unity inspector. Private variables are accessible only from the script, and they don't show up here in the inspector. If I want a private variable, but I want it to display in the inspector, I give it the serialize field attribute, like this. So if I save my changes and I go back to Unity, I can see move speed here, like this, and we see the default value of 3 I gave it. I want another private variable. This time I don't need to see it here in the inspector, so I don't use serialize field. The type is vector3, and I call it target position. Vector3 is a data type that has 3 components. We use it for position, for example, because position needs x, y, and z values. In terms of naming conventions, look at the custom names I'm giving these variables. We will follow .NET style naming conventions here. Public variable names are spelled in Pascal case, where the first letter is capitalized. Private variables will be camel case with an underscore prefix. And my personal choice is that serialize field variable names will be spelled like this, so that Unity can turn them into names that are nice to read in the inspector. These are just conventions. If you don't follow these rules, it will not break your code. But people use them because you can see at a glance what is a public and private variable. Inside the update method, which runs over and over, we want the enemy to move towards the target position. We learned about start and update lifecycle methods. There are many more. For example, we have the OnEnable method, which runs every time a game object is activated. Inside, we'll put all the code that I want to run when I reuse this object, because later on, we will learn how to optimize our code for better performance by turning enemies into reusable objects. And every time we reuse the object, every time we activate it, code inside OnEnable method will run. When the enemy gets activated, we will give it some target position. For example, just as a test, let's give it a new vector3 and set the position to 4, 0, 0. X, Y, Z. As the update method runs over and over, I want the enemy to move towards that target position. So I set the enemy's transform position to a built-in move towards method. This method expects 3 parameters: current position, target position, and move speed. So I pass it the enemy's current position, where it is right now, and its target position, where I want the enemy to move, and how fast it will move there, which will depend on the move speed property from line 5. I multiply it by Time.deltaTime. Delta time gives us the time in seconds that passed between each call of update. If I account for the actual time passing by like this, we make sure that the enemy moves at a consistent speed on all devices. It's important because the update method might run faster on a more powerful device, but we don't want the device's ability to serve more frames per second to affect how fast things are happening in our game. Accounting for delta time is a very important technique that ensures the speed at which game events happen depends on actual time and not on the frame rate. This is one of the fundamentals of game development and something we have to always make sure we do. Okay, so we have the enemy, a target position of 4, 0, 0. Let's save that and play to see if it worked. We can enter play mode by pressing this play button up here. As you can see, the enemy is moving from wherever it is to the target position of 4, 0, 0 at the speed of 3 units per second. This is position 0, and these little squares are units. The horizontal x position of +4 is 4 units to the right from the middle. 1, 2, 3, 4. I exit play mode. We know our code works. So now, instead of making the enemy move to a position like that, I want the enemy to move from waypoint to waypoint following a path. I select my path1 game object and I open the path script. To move along the path from waypoint to waypoint, we need a method that will give us the position of a waypoint, depending on an index in the waypoints array. When I call it and I ask what is the position of the element at index 1 in the waypoints array, I want this method to give me x, y, and z position of wherever in the scene we placed this waypoint object. Indexes start from 0, so 0, 1, 2, 3, 4. So this method will expect a parameter of integer type, a number without decimals. I call it index, and it will return the waypoint array at that index we passed to it. It will give us the transform position of that waypoint at that index. So whenever I need to know where to move next, I will call this public getPosition method. To access that getPosition method we just defined from the enemy script, I need a reference to the path1 game object and to its path script component, which contains that method. So serialize field, private, type is path, because I want this variable to hold a reference to this custom path component. And I will call it, for example, current path. Now it's time to learn about another lifecycle method called awake. This method runs once when the script instance is first loaded, same as start, but it runs before OnEnable and before start. Inside awake, I take current path and I need to point it from the enemy game object to this path1 game object. And on it, I need to find this path component. There are multiple ways to do that. For example, I call the built-in find method, and I pass it the name of the game object I'm looking for. I need to make sure the spelling matches the name of the object I'm looking for exactly. From it, I call getComponent, because I'm looking for this path component here. So now, the current path variable holds a reference to this component. We need it because that component has this public getPosition method that we will want to call from the enemy script. Inside OnEnable, I set target position to current path, this component, .getPosition, and I pass it index. And depending on the index value I pass it, it will give me the position of one of these waypoints, 0, 1, 2, 3, 4. For example, if I pass it index 3, it would give me the position of this waypoint game object. The reason I had to use awake here is the order of execution. OnEnable runs before start, so I couldn't put this line inside start. I had to put it inside awake, because awake runs before OnEnable, and I needed this reference to be ready at the point when enable runs. Don't worry about this too much, it will become easy to keep track of the more you work in Unity. You can always have a copy of this chart somewhere and check it when you need it. So if I set this to index 3, I go back to Unity, and I expect enemy will walk from wherever it is right now to the position of this waypoint. I enter play mode and yes, that worked, perfect. Let's try to set index to 0. Save. I expect the enemy to walk to this waypoint. Play mode. Great. We have most of the logic. All I need to do now is to make sure the enemy increases target index by 1 every time it reaches its target position, and that will make it move along the path we defined here. So let's define a private integer I call current waypoint. It will be 0 or 1 or 2, 3 or 4 as the enemy moves along the path and changes targets. Every time we activate or reactivate this enemy, set its target position to be the first waypoint on the path, index 0. As the game runs, we check when the target position was reached and we set a new target position. We need to know the relative distance, how far is the enemy from the target position, the difference between the enemy's current position and its target position. The enemy can be to the right or to the left, so the value can be negative or positive, but we want to disregard that plus or minus. We only want the distance between these two positions. We don't care about the direction. That's why I want the magnitude of the vector. If the enemy is close enough to the waypoint, to its target position, let's say if the distance is less than 0.1 units, we increase the current waypoint value by 1. And we set the enemy's target position to the next waypoint in the path, like this. The enemy will move towards that next target position, and again, when it's close enough to it, it will increase the index again to move towards the next waypoint. I save and play to see if it works. The enemy is moving towards one waypoint after another, following the path we defined. When it reaches the last waypoint, we get an error, so let's fix that. Only increase the current waypoint by 1 if we are at an index at least 1 less than the length of the array. Else, we know the enemy reached the end of the path, so we will deactivate the enemy. We set active to false, like this. I save and play. The enemy follows the path, and when it reaches the end, it gets destroyed, it gets grayed out and deactivated. I create an empty game object and I call it spawner. I want to create a game object that will spawn enemies at a specific interval. In the game later, it can be a cave that orcs are coming from or something like that. I reset transform just to make these numbers nicer. No real reason for this otherwise. Inside the assets scripts folder, I create a new MonoBehavior script I call spawner. Spawner game object selected here, and I attach spawner script as a custom component. I delete all this code, and I define a private float spawn timer and spawn interval. I set it to 1 second by default. Spawn timer will count from 1 second down to 0. It will spawn an enemy and it will count again. So as the update method runs over and over, we are reducing the value of spawn timer by delta time, by real time that is passing by between updates. When spawn timer is less than or equal to 0, we set spawn timer back to spawn interval, which is 1 second right now, and we spawn an enemy. This method doesn't exist yet, so let's write it. Private void spawn enemy. Inside, I create a temporary helper variable. Type will be game object, and I call it spawned object. To create a copy of a game object from a prefab with code, we call the built-in instantiate method. And we pass it the prefab we want to create a copy of. This prefab variable doesn't exist yet, so let's define it. Public game object type, I call prefab, like this. Pascal case, because this is a public variable, so I have to change the spelling here as well. Notice I'm keeping everything generic so that I can set this prefab to be enemy or any other prefab object we will have in the game later, so we can use this spawner class to spawn pretty much anything. It can be very useful. Once we create spawned object from a prefab, we take it and we set its transform position to be the same as transform position of the game object this script is attached to. So the position of spawner game object. Wherever I place this spawner in the scene, that's where game objects will be spawning from. So now I have this prefab field, and whatever prefab I put there, that's what this spawner will start producing copies of. Save that, and in Unity, I see that prefab field here. I go to Assets, Prefabs, and I drag and drop enemy game object in here, turning it into a prefab. I can reset its transform to keep this cleaner. I delete the enemy game object from the scene. Spawner selected, and I drag the enemy prefab into this prefab field. I enter play mode. And enemies start spawning. They start from wherever I placed my spawner game object. They move towards the first waypoint in the path, and they follow the path. When they reach the end of the path, they get deactivated and grayed out here in the hierarchy. As you can see, we keep creating new enemies and deactivating the old enemies. I can also destroy the old enemy game objects completely, but for performance reasons, we want to reuse them instead. So instead of constantly creating and destroying enemy game objects, we want to create a pool of, let's say, 10 enemy game objects. We activate them when we need them, and we deactivate them, returning them back to the object pool instead of destroying them. Object pooling improves performance by reusing inactive objects instead of repeatedly creating and destroying them, which reduces memory allocation and garbage collection overhead. Let me show you a quick and simple object pool logic I like to use for my games. Inside Assets Scripts, I create a new MonoBehavior script I call Object Pooler. Let's open it. Inside, I delete all this code. I define a private variable I call prefab, what kind of game object we want to store in this pool. For example, this would be the enemy prefab. We will also need pool size, how many of these prefabs we want to pre-instantiate. We want to fill this pool with inactive game objects and activate them when we need them. I will give it a default value of 5, but we can change that later. I will also need a data structure to hold them, private list of game objects. I call, for example, pool. To be able to use list, we need system collections generic namespace up here. Inside the start method, I will create the pool. I assign the pool to a new empty list of game objects first. Then I write a for loop that will cycle over the pool, 5 times in this case. And it will create new game object 5 times. Let's define that method here. Private method that will return a game object. I call it createNewObject. Helper variable of game object type we call obj. And we already know that to create a game object, we just call the built-in instantiate method, and we pass it the prefab we want to create a copy of. After we create it, we set active to false. We are just preparing some inactive objects into the pool here. We take pool from line 8, we add this new inactive object inside, and we make this method return that object. Let's save that. In Unity, I create a new empty game object I call enemy pool. I reset its transform. Again, our object pooler class is generic, so we can reuse this script to create different object pools in our game. Enemy pool selected, and I attach object pooler script as a component. Prefab field expects a game object that this pool will consist of. I go to Assets Prefabs, and I drag the enemy prefab into this field. The initial pool size is 5 by default, but I can change it if I want to. If I enter play mode, our script automatically creates 5 inactive enemy game objects, but they are all on the top level in hierarchy. I exit play mode. I would prefer if the pooled objects were parented under the enemy pool. In my script, I can pass instantiate an optional second argument that defines a parent. So I pass it transform, but it refers to the game object this script is attached to, in this case enemy pool. So I'm saying set enemy pool as the parent and nest these game objects under it. Inside spawner, I comment out spawn enemy for a while. Save that. Now if I play, start method runs and it creates 5 inactive enemy game objects and it puts them under enemy pool like this, keeping the hierarchy clean. The idea behind object pooling is that when I need a new enemy, I activate one of these, and when I destroy the enemy in-game, I just deactivate it, putting it back into this pool of available objects. Doing this is good for performance, mainly because of automatic garbage collection and memory allocation processes, which can cause our game to slow down if we are constantly creating and destroying new game objects. Object Pooler will need one more thing, a method that will give us one of these inactive game objects when we need it. I will run a for each loop, which will iterate over all game objects in the object pool. We have that pool here on line 8, and as we just saw, it will hold 5 inactive enemy objects. For each loop, we'll check objects in the pool one by one, and when it finds the first inactive one, if active self is false, exclamation mark means false, it will return it, giving us the game object. We are creating 5 game objects initially. Maybe we are in a situation when all of them are being used, and this method will not find any inactive one. In that case, we just create one more and we return it. If needed, we increase the size of the pool, like this. So now, whenever we need a new game object in the spawner, instead of creating a new one, we will call this public getPooledObject method. Inside spawner script, we will not be creating any new game objects here, so I can delete this line. When we spawn an enemy, we want to take the object pool and take one of those inactive game objects in there. I comment this out for a second. I create a variable. Type is object pooler, and I call it pool. What is the object pool this spawner will be spawning enemies from? Save that. In Unity, we see that pool field here. And I want to be spawning from this enemy pool. So I drag the game object in here. From it, I can call this getPooledObject method to get one of the enemies from the pool. So when I want to spawn a new enemy, I take the object pool, which we know will be enemy pool in this scene, and we call its public getPooledObject method, which will either give us one of the available game objects, and if there are none available, it will create a new one. Then we do what we did before. We position it wherever in the scene the spawner is, and we activate it. If you remember, when the enemy reaches the last waypoint, it will get deactivated, which will return it back to the pool of available objects. I will also uncomment spawn enemy here. Now if I save changes, spawner selected, move tool, and I will move it somewhere around here. I play, and enemies start coming from the spawner to the first waypoint, and then they will follow from waypoint to waypoint along the path. Notice that if I need more, object pooler script will create more, and at some point we have enough, and we will start reusing the old enemy objects. Now we are reusing the same 11 enemy game objects over and over. Throughout the project, I'll be providing source code checkpoints. At each checkpoint, you can download a zip file containing the complete Unity project and source code to open locally. You'll find a link below where you can download all versions of the source code as the project progresses. Right now, we're at the first stage, source code part 1. If you download it, you get access to all the art assets and scripts added to the project so far. To open it in Unity, simply unpack the zip file to a folder on your computer. Then open Unity Hub, click Add Project from Disk, navigate to the folder where you unpacked the project, and select it. Unity may take a few moments to install the required packages. When the project opens, you'll likely see an empty scene. Unity creates an untitled scene by default. To view the actual project, go to the Scenes folder and open the game scene. Now you have the same version of the project I'm working with. You can play it, explore the scripts, and use all the included art assets. Throughout the course, I'll let you know each time we reach a new source code checkpoint. You can then download the next zip file to explore the project at that exact stage of development if you'd like. Now that we've made sure we are all on the same page and everything is working, let's move on to the next part. We will add multiple enemy types and learn how to use a beginner-friendly, data-driven approach to give each one unique properties and behaviors. When I open my project like this, I see just this empty, untitled scene, so I have to go to Assets, Scenes, and open the game scene. In the game window, I go here and change free aspect back to Full HD. I also like to have my game view down here so I can see the scene and the playable version of the game at the same time. Now that you know how to get a Unity project from GitHub and open it locally, let's continue building it out further. I created another sprite sheet. I call it Tower Defense Basic. As always, you can download it in the resources section below. It's pixel art, so after I drag and drop it into my Assets Art folder, with that asset selected, inside the inspector window, I set filter mode to point no filter and compression to none. I click Apply, Up here, I open Sprite Editor. I go to Slice, Grid by Cell Size. I made these frames 100 times 100 pixels. I click Slice and Apply. This is not the final graphics for our game, just placeholder art assets that will represent different enemy types, projectiles, and towers. It will be kind of a grey boxing face. I want to build a complete tower defense game with these placeholders, and then we can choose from many different asset packs to make our game unique. For now, our focus is not on graphics. We'll focus on mechanics, code, and logic, and we'll explain everything in detail to make sure even beginners understand. I want to have different enemy types with different properties. In Assets Prefabs, I rename my enemy prefab to Orc. If I check the enemy pool here, you can see Unity has updated the reference. Orc is shown here, all good. I rename it to Orc Pool. If I check my spawner, it has renamed Orc Pool here, and if I press play, everything still works. I want to create another enemy type by duplicating my Orc prefab, so I go inside Assets Prefabs, and I copy and paste the Orc prefab. I rename the copy to Dragon. I create another copy and rename it to Kaiju. With the Dragon prefab selected, I lock the inspector, go into the art folder, expand the sprite sheet, and drag the little flying dragon frame into the sprite renderer, into its sprite field. I unlock the inspector, back to prefabs, Orc selected, lock the inspector, and I replace the sprite with the same one from the new sprite sheet, just to keep things consistent. I unlock the inspector, select Kaiju, lock the inspector, and drag the knuckle-walking kaiju monster silhouette into the sprite field. Back to prefabs, and I can now drag out dragon, orc, and kaiju enemy prefabs into the scene. Keep in mind, these are just placeholder assets. We will build this codebase in a generic way so that later you can use your own art and themes. It'll be easy to turn these into robots, aliens, cars, whatever you want your final tower defense theme to be. I just picked Orc, Dragon, and Kaiju to make things a bit more interesting, so we're not working with plain grey boxes. I unlock the inspector. Same as we have a pool of reusable orcs, I need to create one for dragons and kaijus. So I create an empty game object, call it Dragon Pool, reset its transform, add Object Pooler component, and drag the Dragon prefab into the prefab field. I create another empty game object, I call it Kaiju Pool, reset transform, add Object Pooler, and drag the Kaiju prefab into the field. I delete them from the hierarchy. Then I nest all my object pools under the spawner game object to keep the hierarchy clean and organized. I enter play mode and I press pause. I should now have a pool of 5 inactive kaijus, 5 dragons, and 5 orcs. I'm getting a strange error, and when I look in the console, I don't think we did anything wrong. Sometimes Unity can get into an incomplete state and report a random glitch like this. To confirm that it's a glitch and not something we did, I close and reopen the project. Now, if I enter play mode and the error is gone, we know it was nothing to worry about. I exit play mode. Under spawner, now we have our 3 enemy object pools. The way the code works right now, whichever pool we put into this field, that's the enemy type our game will be spawning. So now I'm spawning dragons. And now I'm spawning kaijus. Everything works and no console errors. Perfect. So we have a different prefab for each enemy type, but they all share the same enemy script. Let's open it. We don't need to see this current path field, so I remove the serialize field attribute. To keep it consistent, I rename the current path variable to start with an underscore, indicating that it's private. I'm using Visual Studio Code, where I can double-click current path to select it, Then I tap Ctrl-D or Command-D on Mac to multi-select all occurrences for editing. I select all 5 instances and add an underscore in front, like this. Save that, and now this field disappears from the inspector. I hit play just to test it. Our enemies still follow the path. Good. Inside the enemy script, I'm currently keeping the move speed value directly in the script. I'd like to move this and other values into a scriptable object. This makes game data easier to manage and reuse. Storing values like move speed directly in scripts is called component-driven design, and it's common in beginner-friendly tutorials. But let's structure our project better and use data-driven design. In data-driven design, game logic reads from structured data, like scriptable objects, not from hard-coded values. It's very easy to implement it, and we'll use it throughout this codebase. Let's learn how to handle clean project architecture in a beginner-friendly way. To understand clean data-driven design, we need to understand what a scriptable object is. So let's create one. Inside the Assets folder, I create a new folder called Scriptable Objects. Inside, I right-click, Create, Scripting, Scriptable Object Script. And I name it Enemy Data. When I open it, Unity has already generated the basic syntax. We have the Create Assets menu class attribute, which allows us to create new assets from this scriptable object directly in the editor. Let's say each enemy data asset will have a field for lives, which will be a float, damage, which will be an integer, and another float for speed. Save that. Now that we've created the enemy data scriptable object, we can use it to create a data asset for each enemy type. Right-click, Create, Scriptable Objects, Enemy Data. I name it enemy_orc. I give my orc 3 lives, 1 damage, and 3 speed. The same process for enemy dragon. 2 lives, 1 damage, speed of 6. It's going to be faster but weaker enemy. And enemy kaiju will have 10 lives, 2 damage, and speed of 2. Slow but strong. Now I want to associate each data asset with its corresponding prefab. Instead of defining move speed in the script, I want to pull it from the data file. So I define a serialized field, private, enemy data, I call just data for short. Then I delete the old move speed, and in the movement logic, I use data.speed. Each enemy prefab now has a data field. Let's assign the assets. I drag out dragon, kaiju, and orc prefabs into the scene. Select dragon, drag enemy dragon into the data field. Kaiju, assign enemy kaiju. Orc, assign enemy orc. These changes apply only to the instances in the scene, so we go to Overrides, apply all for each one to save the data link to the base prefab. We've now defined a scriptable object class, and using it, we created a separate data asset file for each enemy type. These are project assets. They persist outside play mode and between scenes. Great for storing configuration data and avoiding hard coding. Scriptable objects are a key tool in data-driven game development. They let us manage data cleanly, separately from code, and easily inside the Unity editor. Back on the spawner, I set kaiju pool here. I reduce kaiju speed to 1, very slow. And when I play, they spawn and move very slowly. Change speed to 5, and they move much faster. Exit play mode. So instead of storing config in the script, we store it in a reusable asset. Reference it in the inspector and pull data from it, like data.speed. This approach has many benefits, and we will explore more as we build the game. I delete the prefab instances. On spawner, I drag orc pool into the pool field, The spawner now endlessly produces enemy type defined by the pool here. The orc speed is read from the enemy orc data asset. I can tweak it and see immediate changes. Following this pattern, I want to define enemy waves in the same way with data assets. Each wave defines the enemy type, how many and how often to spawn. In Scriptable Objects, I right-click, Create, Script in, Scriptable Object Script. Call it Wave Data. I open it and define public float spawn interval, public integer enemies per wave, and we will define enemy type a bit later. Now I can create one. Right-click, Create, Scriptable Objects, Wave Data. I call it Wave 1. I set spawn interval to 1 second and enemies per wave to 3. I also want to define which enemy to spawn in this wave, orc, dragon or kaiju. I could store the prefab asset itself in the data, but since we're using object pools and these pools only exist in the scene, Unity won't allow us to reference them in a persistent data asset. So we need to store a value that lets us associate the wave with a specific pool. To do that, I'll use an enum. Inside the scripts folder, I create a new folder called utils for reusable scripts. Right-click, Create, Scripting, empty C# script. Name it enemy type. Open it, and I change it to an enum. I have a public enum called enemy type, and inside I say orc, dragon, and kaiju, no comma there. An enum is a simple list of names you make to represent different options in your game. The goal is to store a reference to an object pool from which we will be spawning enemies for each wave. We can't directly reference the orc pool, dragon pool, and kaiju pool game objects because they exist only in this one scene. They are not project-wide assets. So instead, we will reference this enum, which will then help our code find the correct object pool in the scene. So each of my waves will have a field for enemy type, this enum, and I call it enemy type, for example. It will be either orc, dragon, or kaiju. If I save this and I go back to Unity, inside Assets Scriptable Objects folder, we created this Wave 1 data asset. You can see this new enemy type field here, and in it, Unity presents the enum as a nice clean dropdown. So Wave 1 will be spawning orcs every 1 second, and it will spawn 3 orcs in total. Great. Now I want to use this wave data scriptable object to create a data asset for the second wave. Right-click, Create, Scriptable Objects, Wave Data, and I name it Wave 2. It will spawn dragons every 0.5 seconds, 6 of them in total. Again, I right-click, Create, Scriptable Objects, Wave Data, and I call it Wave 3. It will spawn kaiju every 2 seconds, 2 in total. Okay, so this is how we define our wave data. The first wave is orcs, the second wave is dragons, and the third wave of enemies will be kaiju. Currently, the spawner only spawns whatever object pool we put into this field. Right now, it's the orc pool. Let's open the spawner script and adjust that logic to work with our new wave data assets. I create a serialized field, private variable, and the data type it will contain will be these wave data assets. This variable will not hold just one, it will hold an array of wave data files. I'll call it, for example, waves. Save that. On the spawner game object, I see this waves list now. From Assets Scriptable Objects folder, I drag and drop the Wave 1 data file. Wave 2, I drop it over the head of the array like this, and it will slot them in order, and Wave 3 as well. We know that each data asset has this enemy type field where we can choose an enemy type from the dropdown. Those values in that dropdown are defined by this enemy type enum. I need a way to connect these values inside the enum with the actual object pools we have in our scene. We have org pool, so I create a reference for that here. We also have dragon pool. And finally, a kaiju pool. For now, I put org pool here on line 26. Save that. The spawner has 3 new fields, so I drag the org pool game object into this field, dragon pool game object into this field, and kaiju pool will go in here. I enter play mode and I pause my game. We know that as soon as the game starts, these object pools fill with inactive enemy prefabs. Scripts are activating and deactivating them, reusing the same set of enemies over and over, which helps to improve performance of the codebase. We know that the Wave 1 data asset has the enemy type field set to org, so I want to connect that value to this org pool field. Wave 2 will be connected to the dragon pool, and Wave 3 to this kaiju pool. The reason why I have to do it like this is because I can't directly reference these object pools in my data files, which would make it easy. But because these 3 object pools exist only in this scene, and these data assets exist in the project across all scenes, Unity doesn't allow me to directly reference non-persistent objects in the data. That's why I have that enum that stores the name of the enemy, and we will now use that enemy name to point to the correct object pool and match the data with scene objects, with the object pools. We can do that in many ways. Let's use a dictionary. This is a good use case for it. Let's just write the code and then explain how it works when we see it. Private variable, which will hold a dictionary. We will match enemy type with object pooler. I will call it, for example, pool dictionary, like this. A dictionary is a list of key value pairs. Enemy type will be the key. Object pooler will be the value. The enemy types will be coming from this enum here: org, dragon, kaiju. Object pooler values will be coming from these object pools. The goal is to match a keyword from the enum, the names of enemies, with their associated object pools. That way, if I say in this data file that enemy type is dragon, my spawner will know to take enemy objects from this dragon pool. We defined the dictionary here. Inside the awake method, which runs once as soon as the object is created, we will create a new dictionary. I'm saying make a new empty dictionary where I can store enemy poolers, and each one is linked to an enemy type. Inside, I define which enemy type is associated with which object pooler. EnemyType.org is associated with org pool, key value pair. If our wave data has the enemy type field with a value of org, we know that we want this org pool game object. If enemy type is dragon, we want the dragon pool. If enemy type is kaiju, we want the kaiju pool game object. So now we connected values in our enum with specific object pools, and the link from our data to the pools has been established. We used a dictionary to link each enemy type to its corresponding object pool, so we can quickly access the right pool based on the enemy. Now that we have wave data that tells us what enemy to spawn, how often, and how many of them per wave, I want to be able to cycle over this array of wave data and spawn enemies based on that. We'll need a private integer I call current wave index. Are we currently on wave 0, 1, or 2? Indexes in arrays start from 0, not from 1. We need a way to get data from these wave data assets based on the current wave index. I'll use this syntax. I'll have a property called currentWave that, whenever I use it, it will look at this waves list from line 6 and give me the wave data asset at that index, 0 or 1 or 2. This line is a simple getter. It's a read-only property written in shorthand called an expression-bodied property. All we need to know here is that whenever I use current wave in my code, it will give me the data contained in one of these data assets. Which one depends on the current value of this index variable. I save that, and I'll open the wave1 data file just so we can see it. Now I can access these values through the current wave property. For example, this spawn interval will be currentWave.spawnInterval. So let's actually use it down here. Whenever we spawn an enemy, we reset the timer back to the spawn interval value so that it can count again towards the next spawn. This orc will spawn every 1 second. We replaced this hard-coded value and I can delete it. We are now using data-driven design in the spawner. We are not storing values here in the script. We are pulling data from these asset files. I save and play to test if it works. We are spawning an orc every 1 second. I can change the spawn interval here, and I can see my game reacts to it. So we know this data is connected to our logic. We have a data-driven enemy spawner. I exit play mode and go back to my code. Down here inside spawner, let's select the spawner game object in Unity so I can see it side by side with my code. Currently, I'm spawning only from the orc pool. Let's spawn from these 3 object pools, depending on what enemy type I set in the data for that particular wave. I say, if pool dictionary, try get value. I put all this code inside. I have to be careful with brackets when I do this. On line 42, I need a reference to one of these 3 object pools. In our enemy data, we have just that enum that says orc, dragon, or kaiju. So I take pool dictionary and I call try get value. This built-in method is a safe way to check if a key has a value. As the key, I pass it the current wave.enemyType, the enemy type held in the currently active wave data file. If that enemy type key has an associated value in the dictionary, we output that and give it a variable name pool. Now I take this pool variable and I use it here. Let's say the current wave is this one, wave 1. I'm saying, do you have a key value pair for orc? If so, give me that orc pool. We matched the orc key with the orc pool value up on line 12. So if current wave changes from this wave to that wave, we'll automatically stop pulling orcs and start using dragons. Current wave index is set to 0 by default, so current wave references this data. I save and play, and we are spawning orcs. I exit play mode. If I change this index to 1, save and play, we will start pulling wave data from this asset file, so the enemies change to dragons. If I change current wave index to 2, current wave is now connected to this data asset. It's also spawning dragons, so I go to Assets, Scriptable Objects, and I open my wave 3 data. I can change the enemy type to kaiju. I play, and we are spawning kaijus. I exit play mode and set the index to 0 as a default. We know that by increasing this index value, we are moving from wave to wave. We connected the enemy type from our data to our code. It defines which object pool we're using. We also connected spawn interval. It defines how often that enemy type spawns. Finally, I want to connect enemies per wave. Once we've spawned this many enemies, we increase current wave index from line 7, and our code will automatically start spawning the next wave. I keep track of how many enemies we've already spawned in this wave using this private float spawn counter variable. As the update method runs, we are counting down using spawn timer. Every time spawn timer reaches 0, we reset it so that it can count again, and we spawn one enemy. I will adjust this condition. Only spawn an enemy if spawn timer reached 0, and if spawn counter is less than current wave dot enemies per wave, the value from here. Else, if spawn counter is more than enemies per wave, we know we've spawned all enemies in that wave and we want to move on to the next wave, current wave index ++, which means increase it by 1. And in this block, every time we spawn an enemy, we increase spawn counter by 1. Let's save and play to test it. The first wave, as we defined, is 3 orcs. 1, 2, 3. And now we get dragons. I set wave 2 to be 6 dragons. After 3 dragons spawn, I get an error, which means I made a mistake in my logic somewhere. When we increase the wave index by 1 and move on to the next wave of enemies, I want to reset spawn counter so that it correctly counts the enemies in the next wave. I save and play. Wave 1 is 3 orcs. Wave 2 is 6 dragons. And then wave 3 comes, 2 kaijus. Then we get an error, which is expected, because we finished spawning wave 3 and we're trying to spawn the next wave, but we only have these 3 enemy waves. I exit play mode, I select spawner game object. Current wave index starts at 0, so we start here spawning orcs. Then, when it's increased, we move on to the dragon wave, then the kaiju wave. And then I want to reset current wave index back to 0, so we start spawning from the orc wave again. We can add as many waves as we want here, and then when we reach the last one, it will cycle back from the beginning again. I can do it by using a single line of code. Instead of using the ++ operator, I can also increase the index by saying current wave index +1. It's the same thing. I'll wrap it in brackets and I use the remainder operator and waves.length. We have an array that has 3 elements. Its length is 3. This line is a clever way to move to the next wave and automatically loop back to the start when you reach the end. The modulo operator, also called remainder operator, makes sure that if the index goes past the last wave, it wraps around back to 0. I'm basically saying, take the current wave index, add 1 using the plus operator, then use the modulo remainder operator to make sure it wraps around to 0 if it reaches the end of the list. The modulo operator is commonly called remainder operator because it returns what's left after division. So when we reach current wave index of 2, the last wave, because indexes are 0, 1, 2, plus 1 is 3, and the remainder of 3 divided by 3 is 0. The index becomes 0, and we start again from current wave index of 0. It can also be written as a normal if-else statement and it will work the same, but I like this clean one-line syntax better. It's just my personal choice. I save and play, and we'll spawn 3 orcs, 6 dragons, 2 kaijus. And again 3 orcs, 6 dragons, 2 kaijus. And again 3 orcs. We have an endlessly repeating enemy wave system. At this point, maybe you'd like to know how to start spawning the next wave only after the previous wave of enemies reached the last waypoint or has been destroyed, as it's usually standard in tower defense games. We can do it by keeping track of enemies we removed. This will count both enemies that reached the last waypoint and enemies that were destroyed by towers. We don't have towers yet in the game, so we will only account for enemies that reach the end for now, and we'll make a small tweak later when we have towers destroying the enemies. In this else-if statement, I add an additional condition. Only go to the next wave if we spawned all enemies per wave, and also all enemies in this wave were removed. So we are inside this update method, and we are counting down over and over. Every time the spawn timer counts down to 0, and as long as we spawned fewer enemies than the enemies per wave defined in our data here, we keep spawning that same enemy type over and over. Else, if we spawned all enemies in the wave and we removed all of them, only then we move on to the next wave. But how do I know that an enemy has been destroyed or reached the last waypoint? How can I detect that in my spawner script? I can use the observer pattern. This is one of the most useful design patterns for game development, and we will learn exactly how to use it right now. The observer pattern is a way to let one object broadcast a message, and the other objects can listen and react when that message is sent. So I will have the enemy broadcast that it reached the last waypoint, and our spawner will be listening for that event, and it will react to it. The advantage is that objects don't need to know about each other directly, they just listen for events. I go to the enemy script. To make an object broadcast a message, we create a public static event. I use the action class. To be able to use it, I need to be using the system namespace up here. This action will carry enemy data with it, so that objects who listen know some information about the enemy in question. And I give it some custom name, for example, OnEnemyReachedEnd. We are declaring a public event that other scripts can subscribe to. When triggered, it will send along some information, specifically an enemy data object. The static keyword here means it belongs to the class, not a specific object, so you don't need an instance to use it. The event keyword marks it as something that other scripts can subscribe to and respond when it's triggered. Action enemy data is the type of event, and it takes one parameter, an enemy data object. So I'm setting up a signal called OnEnemyReachedEnd that will notify other scripts whenever an enemy finished the path, and I'll give them some information about that enemy. Now I need to find a suitable place in my script where I want to broadcast this message. Inside this code block, we are checking the distance between the enemy's current position and its target waypoint. As the enemy moves along the path, if the path has more waypoints, we travel from one to another. The else block runs when there are no more waypoints, which means the enemy reached the end of the path. Before we deactivate the enemy and send it back to the object pool to be reused later, we will broadcast the event that will notify it reached the last waypoint and is about to be removed from the game. I can invoke the event with this line, OnEnemyReachedEnd, invoke data. This shorthand syntax combines null check-in and event invocation in a single line. This question mark says only call this method if it's not null, if it has subscribers. Invoke triggers the event and sends enemy data along as a parameter to all subscribers. The data we are sending along is this variable on line 6, which contains that scriptable object. We created a separate data file for each enemy type that has lives, damage, and speed for each enemy. We are passing that information along as we broadcast the event because it might be useful for the subscribers that are listening to this. We can now react to this event from anywhere in our codebase. I want to react from my spawner script. I need a method that will run as a response to that event being invoked. It will be private, and I will call it, for example, handleEnemyReachedEnd. We know that this event is carrying with it enemy data. I will call it, for example, just data here. We will not make use of it at this point, but later, if the spawner needs to know lives, damage, or speed of the enemy that reached the end, we can read these values from this data parameter. For now, all I want to do here is to increase the variable we called enemies removed by 1. We defined it up here on line 12. Finally, as the last piece of the observer pattern, how do we turn this spawner into a subscriber that is listening and waiting for the enemy to invoke that event? We will do it inside the OnEnable method, which runs after awake but before update. I subscribe to it by saying enemy.onEnemyReachedEnd plus equals handleEnemyReachedEnd. I'm simply saying listen and wait for the OnEnemyReachedEnd event. Whenever the enemy invokes it, react to it by running the code we put inside handleEnemyReachedEnd, and that's it. So, the observer pattern is a design pattern where one script broadcasts an event and other scripts listen and react when that event happens. Many objects observing one object. We define it like this using static event action keywords. We can invoke it with this syntax, broadcasting the event all over the codebase. If the script is meant to be the observer of this event, we subscribe to that event inside the OnEnable method, and we define some method that will run as a reaction. In this case, we are just counting enemies that were removed after reaching the last waypoint along the path. One small thing to finish this, it's a good practice to also unsubscribe from the event inside the onDisable method. Inside onDisable, I do -= here. We do that to prevent potential memory leaks and errors when a disabled or destroyed object is still trying to respond to events. Every time we move on to the next wave, we reset enemies removed back to 0. I save and play to see if it works. There are other ways we could have handled reacting to an enemy reaching the end of the path, for example through a direct method call or the singleton pattern, but the solution we used is probably the best go-to solution that many production-ready indie games use. It's because the way we implemented this decouples the code. Scripts don't need to know about each other directly. This solution also scales well. We can add many more independent scripts that will independently react to this event being broadcasted. As I'm playing my game, you can see we are spawning 3 orcs, 6 dragons, and 2 kaijus over and over, each wave starting only after the previous wave is finished, when all enemies reached the last waypoint and were removed. We are keeping things modular. Each system handles just its job. We will use the observer pattern for many more things in this codebase to really get the muscle memory and get comfortable with it. Because I can read your mind, I know that many of you will ask me in the comments, how do you define a short customizable break between waves? Because maybe you don't want the next wave to come immediately. Maybe you want, let's say, 2 seconds between waves, or even a button that allows the player to click it to release the next wave. I declare a private variable I call time between waves. Let's say 2 seconds as the default value. We will also need a timer that will measure how long we are in between waves. I'll call it wave cooldown. Finally, I need a flag, a boolean called isBetweenWaves. Initially, I set it to false. Inside the update method that runs over and over, I'll create an if-else statement. If isBetweenWaves is true, we will handle some logic. The else block will have all this existing code like this. So if we are in the pause between waves, this code will run. Else, we are not in between waves, so we are spawning enemies as usual. Here, when we finish all enemies in the wave and we increase the current wave index to move on to the next wave, I set the isBetweenWaves flag to true. I save that, and if I play, we get the first wave of 3 orcs, and then we are in between waves, and the spawning system pauses. Great. So when we are in between waves, in this code block, we will use the wave cooldown variable as a timer, decreasing it by the real time that is passing by, Time.deltaTime. While the spawning is paused, when wave cooldown drops to be less than or equal to 0, I take these 3 lines of code, cut them from here, and paste them in here. I set isBetweenWaves to false, which will make this else block run, spawning enemies in the next wave. Okay, so initially, isBetweenWaves is false, so this else block will run. We are spawning enemies over and over from the first wave until we've spawned and removed all enemies per wave. Then, isBetweenWaves is set to true. This block becomes active. We are not spawning any enemies, we are just counting down wave cooldown. As soon as wave cooldown reaches 0, we move on to the next wave. We set isBetweenWaves to false, and this else block will run, spawning enemies from wave 2. I also need to reset spawn timer. If I set it to the current wave, spawn interval here, the pause between waves will be wave cooldown plus spawn interval. Or I can set it to 0, and the next wave will start spawning immediately when wave cooldown drops to 0. One more thing, every time we go into the pause between waves, we reset the wave cooldown timer back to the time between waves value. Okay, that was a bit of logic, wasn't it? This is one way you can use these 3 helper variables to define a custom pause between waves. If you want a button that you can click to release the next wave, instead of using time between waves and wave cooldown, we create a click event and we tie this is between waves boolean value to it, flipping it between true or false. Okay, let's see. Yes, I think this logic will do what we want. Let's save that and play to test it. Keep in mind, we set time between waves on line 20 to 2 seconds. I play and spawn the first wave of 3 orcs. As soon as the last orc reaches the end and is removed, a countdown of 2 seconds happens. And only after 2 seconds, we start spawning the next wave, which consists of 6 dragons, one every 0.5 seconds. When the last dragon is removed, we get a 2-second pause, and the third wave starts spawning kaijus. This is a pretty clean way of creating a data-driven enemy wave system. Let me know in the comments if you understood everything so far or if you want to go deeper into this topic. I can make a bonus lesson. For now, let's move on and create some UI elements to display the wave number and player lives. If you downloaded the source code pack, right now we are here. I call this P2 Enemy Waves. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I want to display the currently active wave number. In the hierarchy, I right-click, UI, Text, TextMeshPro. TextMeshPro is Unity's system for rendering text. The first time you use it in a project, you'll get a pop-up like this, and you click Import TMP Essentials. I rename it to Wave Text. Notice that when I created the text, Unity automatically created a canvas element, and the text is nested under it. If I select canvas here and press F on my keyboard to focus it, the camera will zoom out really far, because by default, the canvas is large. We can work with it like this because it will overlay itself over the visible game area automatically, and in play mode, it will already work. But I prefer to work with a canvas that is the same size as my camera view. So with canvas selected here, I go to render mode and I select screen space camera. Now we get a field for the camera, so I drag and drop my main camera in here. This will shrink the canvas, and if I zoom in, the canvas is now the same size as the visible game area. I prefer to work with it this way. I rename it to UI Canvas, and I go to the Canvas Scaler component. And in UI Scale mode, I set it to scale with screen size. Reference resolution will be the same as this value I have in the aspect ratio field, so 1920 times 1080. Now the canvas and all UI elements we place on it will scale correctly when we play our game on different devices. Notice that when I created the UI text, Unity also automatically created this event system object, which can help us with button clicks, for example. We can just ignore it for now. Just to keep my hierarchy clean, I create an empty game object, I call it managers, and I put it up here. And I nest main camera under it, also Global Light 2D, and event system. Let's keep these here and focus on the UI canvas now. With wave text selected, I can automatically align it using this anchor presets menu. You can see here it says that if I hold Shift, it will also set the pivot, and if I hold Alt, it will set position. So I will actually hold Shift and Alt at the same time, and I will click this top left corner. This will put the text in the top left corner of the canvas, and it will set its pivot point, its rotation center point, to the top left corner of the text box. You can also see it in here, the text moved to the corner. I move it 50 pixels to the right, and minus 50 here will move it down. I will also increase the width to 400, or 500. By default, it will have some placeholder text that I can set here. We will control this field dynamically with code, so what I put here doesn't really matter. In game view, we can see the text here. Great. In the Assets Scripts folder, I right-click and I create a new MonoBehavior script. I call it UI Controller. This script will handle the values for UI elements display and also showing and hiding of panels and buttons later. I open it and I will need a variable to access that wave text. Serialize field because I want it to be visible in the Unity inspector. Type will be TMP text, spelled like this. For this to work, we need to be using the TMPro namespace up here. I will call it wave text. We will have a private method I call update wave text. It will take an integer for the current wave as an argument. To actually override and replace the text we put into the field earlier, I say waveText.text. I give it some value. Back in Unity, with waveText selected, you can see that waveText.text is referring to this field that we see here. And I'm setting its value to be this hard-coded part that says wave, and a dynamic part with the wave number. Indexes start from 0, but I don't want the first wave to say 0. I want it to start from 1. So let's do current wave plus 1. Alright, save that. With UI Canvas selected, I can collapse these components. And I drag and drop the UI controller script to attach it as a component to UI Canvas. You can see the field for wave text here, so I drag and drop it in. We are handling waves inside Spawner, so let's open that script. When we move to the next wave, I want Spawner to broadcast a message. We know from before that to do that, we have to define a public static event using the action keyword, which will work if we are using the system namespace up here. This action will carry with it an integer representing the wave number. I'll call it, for example, onWaveChanged. We will invoke this event inside update. Every time after we update the current wave index and move on to the next wave, if onWaveChanged is not null, invoke it. And it expects an integer, so we pass it current wave index. Okay, every time we move on to the next wave, we will broadcast this message that carries the wave number. I subscribe to it from UI controller, so in the OnEnable method. And inside, we subscribe to spawner.onWaveChanged. I say plus equals update wave text. I copy this block, and in the onDisable method, I unsubscribe. So every time we change wave, Spawner invokes an event called onWaveChanged. It carries the current wave index with it. It's an integer. Inside UI controller, we are subscribed to it, and whenever the event is triggered, the update wave text method will run, expecting that integer, giving it a variable name current wave, and using that value to update wave text. If I save and play, the first wave shows just the default text. When the next wave comes, the event is invoked, and wave text updates, telling us we are on wave 2 right now. It works. Will we get wave 3? Yes, great. Then our waves repeat again from the first orc wave, but maybe I don't want this value to go from 1 again. Maybe I want the wave counter to keep increasing. So first of all, I want the wave counter to update and show we are on wave 1 immediately when we enter play mode. Inside the spawner script, the start method runs once at the beginning of the script's lifecycle. So when we enter play mode, trigger the onWaveChanged event, which will cause UI controller to update wave text and show that we are on wave 1. I save and play. And yes, that worked. I exit play mode. We know that current wave index cycles between 0, 1, and 2 over and over because we have 3 waves here. So we don't want to directly display this value. Let's create a helper variable. An integer I'll call wave counter. Default value will be 0. Every time we move on to the next wave, we increase wave counter by 1. And then we will use that wave counter value here, making the onWaveChanged event carry it with it. I do the same thing here on line 50. Save that. Inside Assets Scriptable Objects folder, Wave 1 data asset, it will be only 2 orcs. Wave 2 will be 2 dragons, and Wave 3 will spawn a kaiju every 1 second, 2 of them in total. Enemy orc will have a speed of 5. Enemy kaiju will have 10 lives and speed of 7. I save and play. Immediately it says Wave 1. When dragons spawn, wave counter will show 2. Kaijus come in Wave 3. Then we get orcs again, starting from the beginning, but my wave counter keeps counting up, showing Wave 4 now, which is exactly what we want. Then, in Wave 5, we get dragons, and so on. So this is how we can handle UI updates in a modular, reusable way. I duplicate wave text and rename it to lives text. Let's do the same thing to display player lives in the opposite corner. Every time an enemy manages to reach the last waypoint, the player will lose a life. With lives text selected, I go inside its rect transform component and click Anchor Presets. I hold down Shift and Alt and set the pivot and position to the top right corner of the screen. Down here in the TextMeshPro component, I set horizontal alignment to right. Okay, good. I set the horizontal position to -50, moving it to the left, and vertical position to -50, moving it down. This will say lives. In the game view, it looks good. I need a reference to lives text in my script. I duplicate wave text and rename it to lives text. I duplicate update wave text and rename it to update lives text. It will take an integer for current lives. This will say lives, and it will display the current lives value that we passed as an argument to this method. I go to Assets Scripts and create a new MonoBehavior script. I call it Game Manager. In the hierarchy, I create a new game object and also call it Game Manager. I reset its transform and attach the Game Manager script to it as a component. Here on Game Manager, we will store important information, for example, player lives. It will be an integer. Let's say we start with a default value of 20. All 3 enemy prefabs share the same enemy script, so I'll open it. The player will lose lives when an enemy reaches the last waypoint, which means when its onEnemy reached end, event fires. We are invoking it here on line 41, and it's carrying with it enemy data. That data contains speed, lives, and damage of that enemy. We'll need that damage to determine how many lives the player loses if the enemy reaches the end of the path. Inside Game Manager, we'll have a private method I call handleEnemyReachedEnd. It will expect that enemy data, which I'll call, for example, data. Back in Unity, inside Assets Scriptable Objects, we see that enemy data. For example here, Dragon enemy data has this damage value. So when an enemy reaches the end, this method will run and we reduce player lives from line 5 by data.damage, this value. Some enemies can take more than 1 player life. It depends on what we put in this data. Just to see if it works, I will debug log lives. The enemy is broadcasting an event when it reaches the last waypoint, and Game Manager will subscribe to it inside OnEnable. So I say enemy.onEnemyReachedEnd, which is invoked here inside the enemy script on line 41. Notice it's carrying enemy data with it. So here in Game Manager, we subscribe to it, and as a reaction, we call handleEnemyReachedEnd, which expects that enemy data and uses it to determine how many player lives we remove. Same as we did before, it's good practice to always unsubscribe, so I duplicate OnEnable, rename it to OnDisable, and use -= here to unsubscribe. Save that. And here in enemy org data, let's set damage to 2. Dragon will be 1 damage, and Kaiju will be 3 damage. I save that and I play. To see private fields, I can click here and enable debug mode. And now, on Game Manager, I see player lives here. I can see that each orc reaching the end causes 2 damage. Perfect. Dragons cause 1 damage each. And then we get Kaijus, and they cause 3 damage each. It all works. Lives are not updated here in the UI. To update them, I need Game Manager to broadcast an event whenever anything causes player lives to be lost. And our UI controller will react to that and update the text that displays lives. Inside Game Manager, I create a public static event using the action keyword, and it will carry on an integer value representing the lives. I'll call it, for example, onLivesChanged. We have the action keyword here, so to be able to use it, we need to be using the system namespace up here. Every time player lives change value here, after they receive damage from an enemy, we will invoke onLivesChanged. As the integer parameter, I pass it lives value. We can use this system later for other things that cause changes to player lives. We are building this codebase in a very modular and scalable way. UI controller has this method that will update lives text. Inside OnEnable, I make it subscribe to Game Manager.onLivesChanged, and it will react to it by running update lives text. As usual, we also unsubscribe inside OnDisable to prevent potential memory leaks. Okay, so inside the enemy script, whenever an enemy reaches the last waypoint, I will broadcast the onEnemyReachedEnd event, passing it the data of the enemy, which contains a damage value, how much damage this enemy causes. Game Manager is subscribed to that event, and as a response, it will trigger handleEnemyReachedEnd. This method expects that enemy data, and it uses it to know how many player lives to remove. Then it broadcasts its own event we defined on line 6, which we called onLivesChanged, and it will carry with it the new updated lives value after we deducted the damage. Finally, we have UI controller, which is subscribed to the onLivesChanged event. Every time Game Manager broadcasts that event, it will react to it by running its update lives text method. This method takes the updated lives value, which I called here, for example, current lives, and it displays that updated value in game. I save that. I disable debug mode here. Inside Game Manager, I create a start method. In here, I also invoke onLivesChanged to make sure the lives UI display updates immediately when the game starts and not only after we lose some lives. Save that. UI canvas selected, and I drag and drop lives text into this field that expects it. If I play, the lives don't update, which means I made a mistake somewhere in my code. I exit play mode. Let's go inside the UI controller script to check the update lives text method. I created it by duplicating this other method, so I forgot to edit this line. I want lives text.text, so I update the value like this. Okay, I save that and I play. We immediately see lives update, showing the maximum of 20 player lives. We know that orcs have a damage of 2, so each one reaching the end will cost 2 player lives. Dragons deal 1 damage each. Let's wait and see. Yes, that works. If we keep going, eventually the lives will go to negative values. Let's say we want to prevent that. One neat way to do that is this line of code. Let's write it and then explain it. Inside Game Manager, inside Handle Enemy Reached End, we have some incoming enemy damage. And I say, player lives are either 0 or the current lives minus the incoming damage. Whichever of these two options is higher. mathf.max returns the larger of the two values. So, if the incoming damage would take the lives below 0, at that point 0 will be the higher value and it will show 0. It will show either the current lives value or 0. It will never show a negative value below 0. To test that, let's set the initial lives to 5. Save that and play. Each orc reaching the last waypoint will take 2 lives. Dragons do 1 damage. But as you can see, lives will not go below 0. Our little trick works. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. If I want, I can add more waypoints and make the path more complex. I can do it by taking the last waypoint in my path, and I copy and paste it over and over, creating copies. Now I have 12 waypoints in total. Only waypoints 0 to 4 are connected to the path logic, so to connect the new ones, I select my Path1 game object, and I lock the inspector. I need to get the new waypoints into this array in a specific order. I can see the last one is waypoint 4 here, so I left-click waypoint 5 here, and shift-click waypoint 12, selecting all elements in between. With all of them selected, I can drag and drop them over the header of the array here, and Unity will slot them into the waypoints array in order. I check if they go in the right order, 5, 6, 7, all the way to 12. Now we have new waypoints. They are part of the path logic, and all we have to do is place them in the game world depending on where we want the enemies to walk. Later on, you will have some graphics representing the game world, so these waypoints will be positioned to make sure enemies follow the predefined paths. For now, I will just place them in any way I like. I select the first waypoint, move tool here, and I can move it around. Waypoint 1, move tool, and I want the enemies to go down like this. Waypoint 2 will make enemies move to the right from that point. Waypoint 3, and we will go up, maybe somewhere here. Now we have a bunch of waypoints all on top of each other in the same position, so I will take them one by one and spread them to create whatever path shape I need. Feel free to create any path shape you want now. Waypoint 4 will go to the right like this. Waypoint 5 going down, but only halfway. Waypoint 6 will make the enemies go back to the left for a bit. From there, waypoint 7 will lead them down. Waypoint 8 all the way to the bottom right corner here. Waypoint 9 going up. Waypoint 10 going left again. Maybe the game art will have some obstacles and enemies have to walk like this. Waypoint 11 will go up. And waypoint 12 will be the end of the path, right here. We have a dynamic path that we can modify in any way we want. We have different enemy types that come in waves. We built 2 simple UI elements displaying the current wave and player lives, and we connected all of that together in a modular, data-driven codebase. This is a tower defense game, so the next step is adding the towers. I take spawner and I move it here, to the left of the first waypoint. Inside Assets Art, I expand my spreadsheet and let's pick an image for the first tower type. Let's say this triangle will be my fast shooting basic tower. I drag and drop it into the scene. Unity automatically creates a game object in the hierarchy and I rename it to Fast Tower. I'm keeping the project generic at this stage, but this fast tower can be turned into medieval archer post or sci-fi drone turret. It all depends on what art style you decide to give to your game. We are just giving it some default simple art assets, and we will keep focusing on game logic and clean and modular code architecture, while still keeping this simple and beginner-friendly. Inside Assets, Scriptable Objects, I create a folder I call Enemy, and I put these 4 files inside. I create another folder I call Wave, and let's put all the wave data assets in here. Now I create another folder I call Tower. Our towers will also be data-driven, and we will store properties for each tower type here. So inside the folder, I right-click, and I select Create, Scripting, Scriptable Object Script, and I will call it Tower Data. We are following the same set of steps we did for enemies and waves. I open my code editor. I make sure Unity auto-generated the basic scriptable object syntax here, and I need to decide what kind of properties the towers will have. Public float range, which will define how far it can detect and target enemies. If the enemy enters this range, the tower can shoot or activate its ability. We will also need shoot interval, which will determine how often the tower shoots or activates its special ability. Projectile speed will determine how fast the projectiles move. Projectile duration will determine how long the projectiles exist in the game world before they disappear. Damage is self-explanatory, how much damage the tower causes to enemies. For now, this is enough. I save that. I unlock the inspector. Inside Assets, Scriptable Objects, Tower, I right-click, Create Scriptable Objects, Tower Data. I will call it Fast Tower. My Fast Tower type will have a range of 3 world units. Units are these little squares you can see in the scene view. It will shoot every 1 second. Projectile speed will be 10 world units per second. Projectile duration will be 2 seconds. And if it hits an enemy, it will deal 1 damage. Inside Assets Scripts, I create a folder I call Tower. Inside, I create a new MonoBehavior script I call Tower. With the Fast Tower game object selected, I drag and drop the tower script, attaching it as a component. Each tower will need a reference to that tower data asset file we just created, so serial as field, private, tower data, I call data. Just a reminder that this attribute allows us to see private variables as fields in the Unity inspector. This keyword defines what data type is held in a variable, and this defines what is my custom name for that variable. Save that. Fast Tower selected, and on the tower script component, I see that data field. So I go to Scriptable Objects Tower, I select Fast Tower again, and I connect Fast Tower data with the Fast Tower game object, like this. Now we can access all these properties sitting inside the Fast Tower data asset from inside the tower script. We access it simply by saying data.range or data.damage. Let's try. I want to start by drawing a gizmo to visually represent the tower's range, the area where the tower can detect and target enemies. We used the OnDrawGizmos method before to visualize a path by drawing lines between waypoints, so let's use it again here. This time, I want to draw a circle around the tower, representing its range. I do it by saying gizmos.drawWireSphere. It takes 2 parameters, the center point in vector3 format, so I pass it the position of the tower this script is attached to, and the second parameter is the radius of the sphere in a float format. We'll pull that from our data. We set it to 3 here. If I save that, we can see the radius of the tower visualized. If you put your mouse here next to the field, notice it changes the icon, the cursor, and you can hold it down and drag left and right to change the values like this. We can see the wire sphere is reacting to it, so we successfully connected our data. I select the fast tower game object. To detect collisions, I add component, Circle Collider 2D. That collider has a radius field here, which determines its size. I can change it like this. The goal is to set this radius value on the collider to always be the same as the range of the tower, to make sure the tower detects enemies that come in range. We will do that with code. So I can set the collider range to any value here. It doesn't matter. I'll set it to 0. Inside the tower script, I need a reference to this collider component, so I declare a private variable. Reference type is Circle Collider 2D, and I call it Circle Collider, like this. Inside the start method, which runs once when the script becomes active, I point my Circle Collider variable to this component using getComponent Circle Collider 2D. On that component, we have this radius field that I want to access now. I access it by saying CircleCollider.radius is equal to data.range. Whatever is the range of the tower, set the collider to that size. Keep in mind that this is the start method. It will happen only once when you enter play mode. If the range of the tower changes during gameplay, we would have to set up the collider radius again. For now, this is good. Save that. Fast tower game object selected here, and I see the radius field here with a value close to 0. I enter play mode, and on the collider, radius field here is 2.79 units, which is the same value I have here in fast tower data. That works. I exit play mode. All our towers will keep a list of enemies. I will call it enemies in range. To be able to use list here, I need the system collections generic namespace, where all the common C# generic data structures live. Inside the start method, I set enemies in range to a new list of enemies. Unity has a built-in method called onTriggerEnter2D, which will run when two colliders interact. For it to work, I save this. The collider has to have this isTrigger checkbox ticked. By ticking this isTrigger checkbox, I'm saying this collider should detect overlaps, but not physically block or push objects. onTriggerEnter2D will only work if at least one collider involved has isTrigger checked. Inside, I want to check if the object this tower's radius collided with is an enemy. I can do that using compare tag, like this. We need to give enemies an enemy tag. Inside Assets Prefabs, I select the Dragon Prefab, and here I go to Tag, Add Tag. In the tags list, I click plus, and my new custom tag will be called Enemy. Save that. Now I can assign Dragon Prefab this new enemy tag. I also do that for Kaiju and for Orc. So if the object that entered this tower's radius has a tag of enemy, I get a reference to that enemy in a temporary helper variable. Type is enemy, I call it enemy, and it will be the object that entered the trigger area. I want the enemy component that's sitting on that object. So this variable holds a reference to the enemy component on the object that entered the tower's trigger area. I want to add this enemy to the list we defined on line 9. I take the enemies in range list, use built-in add method, and I add that enemy to the list. We will also need onTriggerExit2D. If the object that exits the tower's collision radius is an enemy, again I get its enemy component, and if enemies in range contains that specific enemy, I remove it, like this. I need to make sure I spell onTriggerEnter2D correctly, and also onTriggerExit2D spelled like this. I will uninstall my autocomplete plugin. It's doing a really bad job. So we have a tower with a range value. We set its circle collider to the same size. When an enemy object enters the collision area of the tower, we add it to the enemies in range list. If it exits the area, we remove it from the list. Now the tower will always be aware of all enemies that are within its range. Save that. Enemies in range is private, so to be able to see that field here, I need to enable debug mode. Here. I enter play mode. The enemies in range list is here, and it stays empty, so I know we forgot something. We're trying to detect collisions, but for any collision event, like onTriggerEnter2D to be called, at least one of the two game objects involved must have Rigidbody 2D component. I select the Dragon prefab. I disable debug mode here. Down here, I add component, Rigidbody 2D, and I set it to kinematic. By doing that, I'm saying, don't apply forces, gravity, or physics to this object. A kinematic rigid body will not move unless we move it with code. I want enemies and towers to be able to detect each other, but I don't want any pushing around. I also add Rigidbody 2D to Kaiju, and I set body type to kinematic. And I do the same for Orc enemy prefab. Add it and set it to kinematic. I select the Dragon again, add component, Circle Collider 2D. If I double-click the prefab, we'll see it like this, and I can set the radius to 0.3, maybe 0.4. I make it a little bit easier for towers to hit these small, fast dragons. Kaiju selected by double-clicking on it to enter the prefab. Add component, Circle Collider 2D. This radius seems fine. I double-click Orc prefab to get this view. Unity has colliders of different shapes, so maybe we can use Capsule Collider 2D here instead. I keep direction as vertical, and I squeeze it from the sides by setting X to 0.6, maybe 0.9 vertically. Sometimes this is useful if you want a collider shape that matches the enemy shape more closely. If I press this arrow, we get one level up into the scene. I made sure that all three enemy prefabs have kinematic Rigidbody 2D and some kind of a 2D collider. I play, I enable debug mode, and with fast tower selected, I can see its private enemies in range list, and I see that enemies get added and removed from that list as they move in and out of the tower's range. We see the tower's range here as this circle. Let's wait for the next wave of dragons, and yes, it detects them when in range. Perfect. We added an important piece to our tower defense logic. We have a tower that has a range property, and it is aware of all enemies that are within that range. We can do so many things with this. For example, we can make the tower aim at enemies and shoot projectiles in their direction. Let's do that now. Inside Assets Art, I have this placeholder sprite sheet with some basic simple art assets. Let's use this one, for example, as a projectile. I drag it into the scene, zoom in a bit, I rename it to Projectile. If I go to Main Camera Game Object, here inside its camera component, Background Color field, I can change the background color to anything I want. I'll just choose a random color, it doesn't really matter at this point. I guess something not too light, but also not too dark, because the enemy silhouettes are black. With Projectile Game Object selected, I disable debug mode. Let's go back to normal. I add component, Circle Collider 2D. I need to make it much smaller, maybe radius of 0.2 or 0.15. I add component, Rigidbody 2D. I set it to kinematic. In Scripts Tower folder, I create a new MonoBehavior script. I call it Projectile. I attach it as a component to Projectile Game Object. I open the script and I delete all this code. I will leave only the update method. Inside the tower script, my towers will need a reference to an object pooler holding all their projectiles. Each tower will have its own small object pool, reusing the same projectiles over and over, making our code more performance efficient. Because of the fact that I will add that object pooler component directly on the tower, I can simply reference it here using getComponent. I'm saying find object pooler component on this game object attached to this tower script. Save that. I go inside Assets Prefabs, and I drag and drop projectile game object, turning it into a prefab. I can delete it from the hierarchy now. I select Fast Tower game object, and I add component. Object pooler. Fast Tower will have its own pool of 5 projectiles. If I play, Fast Tower will have those 5 inactive projectiles nested under it, like this. Each of the towers will be storing its own small set of reusable projectiles. Tower will need a method that will aim at an enemy and produce a projectile in that direction. I will call it shoot. When shoot is called, first we will check if the tower still has any enemies in range. Enemies in range is a list, and if its count is more than 0, we will actually do something. First, we need to get a free available projectile from the object pool. Projectile pool, which is referencing this object pooler component, and we call its getPooledObject method, which will look if there is a free, inactive, and available projectile, and if not, if all 5 are being used, it will create a 6th one, for example, and it will give it to us. We are storing it in a temporary helper variable I called projectile. I take that projectile and I set its transform position to the same position of the tower, because if we are reusing the projectile, it might have flown off screen in the previous active cycle. Then we activate the projectile. The projectile will need to know which direction it should move away from the tower. The direction will be the relative distance between the position of the tower and the position of the first enemy in enemies in range list. By doing this, this tower will always target the first enemy that entered its range. Here we are dealing with vectors. Each of these values has x and y components. This line calculates the direction vector from the tower to the first enemy in range, and then it normalizes it. By normalizing the vector, we make its length, its magnitude 1, but we keep its original direction. That way, it only contains directional information and not distance, and we can multiply it by a speed value to move the projectile in that correct direction at any speed we want. If you've never dealt with vectors, don't worry about it too much. We will talk more about this later. Save that. Let's look at the projectile prefab, and let's open projectile script. Projectile will have a public method I call shoot. Back inside the tower script, we take that projectile, it's referencing this entire game object, and I want the projectile script component, so I say getComponent projectile. And from it, we call the shoot method we just defined. I pass it data. Up here on line 6, we have that tower data, which contains current stats of the tower, for example, its range and projectile speed. I will pass a reference to that entire data object to the projectile's shoot method. I will also pass it the shoot direction we just calculated. Okay, so shoot method of the projectile is called, and it's receiving tower data and shoot direction. We defined that method here inside the projectile script, and I make sure it expects those arguments. Tower data type, we call data. Vector3 type, we call shoot direction. I want to have these 2 values available outside shoot method as well, so I will create properties that will store them up here. Data and shoot direction, like this. I will also store projectile duration as a separate float property. When the shoot method gets called and receives these values from the tower that shot this projectile, this method will take those incoming values and assign this data to the data, shoot direction to the shoot direction property, and projectile duration from line 7 will be coming as a part of the incoming data, and I get it from there like this. This tower data we are referencing up here. Save that, and in Unity I go to Scriptable Objects, Tower, Fast Tower. Here we see all the data it contains. So this tower data is being passed to the projectile when the tower shoots. And here we are accessing, for example, this data.projectile duration. In this case, it's 2 seconds. I might refactor this a little bit later, but for now, the projectile knows everything it needs. So inside the update method that runs over and over while the projectile is active, we say, if projectile duration is less or equal to 0, deactivate it. Game object set active false. Else, meaning that projectile duration is more than 0, we are decreasing projectile duration by the real time that is passing, Time.deltaTime, and we are moving the projectile using the shoot direction value we received from the tower. We received it here inside the shoot method. We saved it as a property on line 6, and from there we can use it inside this update method. So I use its horizontal and vertical component. Keep in mind we normalized this vector, meaning its magnitude is 1, and now I can scale that vector times projectile speed, making it move in the right direction at whatever speed is coming from the tower data. We will also account for Time.deltaTime to make sure this movement happens at the same speed on any device, regardless of frame rate. We always want to time events in our game based on real time, not based on frame rate. This is a very simple example of a data-driven architecture. The code always remains the same, while the behavior dynamically changes based on the input data. For example, a fast tower, maybe it's an archer tower, may define a high projectile speed, resulting in quick shots, whereas a slower tower, let's say a ballista post with slow projectile speed, will still function correctly using the same logic. This decoupling of logic from data lets us build flexible and scalable tower configurations without modifying the underlying code. In short, the same code we have here will work for multiple different tower types by just changing the input data. Okay, so when the tower shoots, we get a projectile from its pool. We set its position over the tower and we activate it. We calculate shoot direction from the tower to the enemy and we call shoot method on the projectile, passing it tower data and shoot direction. On the projectile, we save those values as properties and we use them inside its update method to move the projectile in that direction until its duration runs out. Then we deactivate it, returning it back to the pool of available objects. So when do we actually call this shoot method on the tower? We want to do it periodically based on the shoot interval value we put inside tower data. For example, I set fast tower to shoot every 1 second here. We will need a helper property I call shoot timer. We will use it as a countdown. In the beginning, I set shoot timer to data.shootInterval. So when the tower is placed, we will wait 1 second before it shoots. Update method will run over and over. Here we set shoot timer to 1 second. We will be counting down using delta time as usual. As soon as shoot timer drops to be less or equal to 0, we reset shoot timer back to data.shootInterval to count towards the next attack, and we trigger the tower's shoot method. So this is how you can trigger something periodically to repeat over and over. Again, we are using data here to define how often the tower shoots. So if we plug in a slow shooting tower here, this code will work with that tower type as well. All we have to change is the data file we associate with this tower script. So every 1 second, this shoot method from line 59 will be triggered, producing a new projectile, activating it, and giving it direction. This method here on the projectile will run and this code will update the data. And while the projectile is active, this update method will run over and over, moving it in that direction. I save that and I play. The tower is shooting in the direction of enemies in range, and projectiles are too slow, so they miss, but everything is working exactly as we need it. I exit play mode. I go to Scriptable Objects, Enemy folder, and Orc Enemy will have speed of 2. Kaiju will be very slow, speed of 1. Dragon is a small and faster enemy, speed 3. Now if we play, the towers are managing to get the projectiles much closer to the enemies. Later on, we can introduce a projectile that can actually seek out enemies and always hit, but this basic fast tower type can miss, and it will be a key part of the game loop, where knowing where the enemies come from and positioning towers strategically is important to win. Now let's make projectiles and enemies actually register collisions. In the Prefabs folder, projectile prefab selected, I find its circle collider component and I check is trigger. Then I go in the projectile script and I define onTriggerEnterToD method. Inside, I check if the thing we collided with is an enemy, and if it is, I need a reference to its enemy script. So I do getComponentEnemy like this. In Unity, let's have a look at one of the enemies, for example, the dragon prefab. It has a tag of enemy here, and I want to access this enemy script component. I need that script because it will have a public takeDamage method that will accept a damage value from the projectile coming from data.damage in the tower data that we passed via the shoot method. Once the projectile hits an enemy, I want to deactivate the projectile. This method doesn't exist yet, so let's write it. I open the enemy script and I define public void takeDamage method. It will take that incoming damage value and its float, and I will call it, for example, just damage. In my scriptable objects, for example here, I see that the enemy dragon will have 2 lives. Inside the enemy script, I create a private float I call lives. Inside OnEnable, whenever we activate the enemy, we set lives to data.lives. So basically, this is the enemy's current lives, and in the data, we keep its max lives. Enemy is a pooled object. Every time we reactivate the enemy from the pool, we reset its lives to the maximum, in case it lost some lives in a previous active cycle. Whenever the enemy takes damage, I reduce enemy lives by the incoming damage. Maybe we don't want the lives to ever go below 0. So after that, I can again set lives to either the current value or 0, whichever is larger. If enemy's lives are less or equal to 0, we deactivate the enemy. Save that, and if I play, tower is hitting orc, and it will get deactivated. Let's pause here. The active orc enemy selected. I enable debug mode, and I can see it has 1 life. Okay, I unpause the game. Let's go back to normal. And if I play, as you can see, there is no second wave coming. We have to adjust the spawner a little bit now that towers can destroy enemies. I exit play mode. I open the spawner script. We are keeping track of enemies removed here to determine whether all the enemies of the current wave have been dealt with, and we can move on to the next wave. I need to make sure that this enemies removed value accounts for both enemies that reached the last waypoint and enemies that were destroyed by towers. Inside the enemy script, I will create another event. I will call it onEnemyDestroyed. And this time, it will not carry enemy data. It will have a reference to the entire enemy object. When enemy lives drop below 0, Before we deactivate it, we will invoke OnEnemyDestroyed event. I will pass it this keyword, passing it a reference to the enemy that was destroyed, the object that is running this code. Inside the spawner, we need a method that will run as a reaction to this event. I will call it handleEnemyDestroyed. We know the argument here is type enemy. I will call it, for example, enemy. For now, we will not use it. We will simply increase enemies removed by 1. Notice that in both of these cases, when the enemy reaches the end and when the enemy is destroyed, we are increasing the same enemies removed variable here and here. Up here on line 41, we subscribe to OnEnemyDestroyed event with this new handleEnemyDestroyed method. And we will also remember to unsubscribe here inside onDisable. So up here, we have enemies removed. Only when all enemies of this current wave spawned and the same amount of enemies were removed, we move on to the next wave. Save that. And on the main camera, I change background color to something else. I can also select my projectile prefab and use this color field to change its color. Okay, I click this arrow to go back. Let's make the main camera actually lighter. Enemies are dark, so they won't be visible with such a dark background. And on the projectile prefab, I make the color darker. I just want a bit more contrast so that we can see the projectile against the background. This is all just placeholder art anyway. Let's play it to test it. The first orc is destroyed by the tower. The second orc is destroyed, so we have no more enemies. So after a 2-second cooldown, we get Dragon Wave. Tower managed to destroy one dragon, and the other is out of range now. It works, perfect. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. We are almost done with the tower setup. We just need to make sure towers update their enemies in range list as the enemies get destroyed. Inside the tower CS script, I create a private void method I call handleEnemyDestroyed. It will take the enemy that was destroyed as a parameter. It will take the enemies in range list and remove the enemy that was just destroyed. The enemy script has this public action called OnEnemyDestroyed. When an enemy takes damage and its lives are less than or equal to 0, it invokes this event. The tower will subscribe to that event inside the OnEnable method, like this, and it will react to it by running the code inside the handleEnemyDestroyed method. Inside onDisable, we unsubscribe, as usual. And handleEnemyDestroyed will remove that enemy from the enemies in range list, so the tower will stop attacking it. I take the fast tower game object and drop it into Assets Prefabs folder, turning it into a prefab. Now I can drag the prefab into the scene as many times as I want, creating multiple fast towers. Each one of those towers will keep its own enemies in range list, keeping track of enemies that are within its range. Now that we have the towers that can destroy enemies, I want to give enemies health bars to see how much damage the towers are doing. I drag and drop the health bar image into the Assets Art folder. It's just a simple white rectangle. You can download all project resources in the description down below. With the image selected, I set sprite mode to single and I apply. I drag and drop it into the scene. I go to Assets Prefabs, and I drag the orc prefab into the scene. I delete this fast tower so we have some space here. I drag out the dragon prefab and the kaiju enemy prefab here. I rename the health bar to start with a capital letter. I drag it over the orc like this to nest it under it. I copy the health bar by pressing Ctrl-C or Command-C on Mac, and back on the top level I paste it by Ctrl-V or Command-V. I nest it under kaiju. Again, on the top level I paste it, and this copy will be nested under dragon. Orc health bar selected, and I set it to 0, 0. I move it up vertically, maybe plus 0.6. Dragon health bar, 0 horizontally, plus 0.5 vertically, moving it above the head of the dragon. Kaiju health bar selected, X is 0, Y is plus 0.6 or 0.55. Inside the enemy script, each enemy has lives here on line 14. We want to project that value onto the health bar and change the width of the health bar based on the current value of lives. This is a very common thing you might want to do in many different kinds of games. Let me show you a simple way I like to do it. First, we will need a reference to the health bar itself. I need access only to its transform component, this bit here. So let's set type to transform. What type I use here depends on how I plan to interact with the health bar. If I wanted to disable the health bar, access its components, or interact with the full object in some way, I would use GameObject type here to have a reference to the whole thing. In this case, we care only about positioning, rotation, or scaling, so we will use transform. You'll notice this is a very common way to do it in many different types of games, if you want to resize the health bar based on the unit's current health. If I save, orc selected, we have this new health bar field, so I drag and drop orc's health bar into this field. You can see this little plus here. It means that this single copy of a prefab has some changes on it that are not applied to the base prefab. Sometimes we want that, but in this case I want all the changes I made to this orc to be on the base prefab, so that all the future copies of the orc prefab have the health bar on them. When we instantiate a prefab in a scene and then change some of its properties, Unity tracks those changes as overrides. This plus means this object is no longer exactly like the original prefab. We have made changes to some parts of it. If I go to overrides here, I can see we made changes to the enemy script and we added a health bar. Now I want to select Apply All. It will push all the changes back to the original prefab, and all prefab instances will reflect those changes. All orc prefabs will have a health bar. Dragon instance selected here. I drag Dragon's health bar into the field here. Then I go to Overrides and Apply All to apply all these changes to the base prefab as well. I select Kaiju, I drag its health bar here, and I apply all overrides. I want the health bar to scale down as the enemy loses lives. We will need to keep its original size in memory. It will be a vector 3 I call health bar original scale, like this. The awake method runs once on each script when its game object appears in the scene before anything else happens. Inside, we save the original size of the health bar. Original scale is equal to healthbar.localScale. I create a private method I call updateHealthBar. A helper variable I call health%. It will be equal to the enemy's current lives divided by its max lives. We are storing max potential lives for each enemy inside its data. One more helper variable I call scale. It's equal to healthbar original scale. It's a vector 3, so it has x, y, and z components. We want to scale the health bar horizontally, so we only care about scale.x, its horizontal component. It will be the original horizontal scale value multiplied by health%. And then we set the local scale on the health bar to that scale with the modified X component, like this. So we are taking the horizontal component of the health bar's vector3 scale value, multiplying it by the ratio between the current lives and max lives, and setting the health bar to that updated scale value. Now we just have to call this update health bar method every time the enemy's lives value changes, right here. And also up here inside the OnEnable method. The enemy is a reusable pooled object, so when we reuse the enemy and reset its lives, we want to make sure the health bar resizes as well. I save my changes. I delete all these because we apply the changes to their base prefabs. Let's drag out one more tower and place it here. It works. The enemy health bar is shrinking horizontally when enemies lose lives. This might be what you want, but let's say we want the health bar to shrink to the left, which is probably the most common way to do it. I exit play mode. Inside the art folder, health bar image selected, I open sprite editor. This is its pivot point here, and I can change its position in this drop-down. I set it to left center, moving it here. I apply changes and close sprite editor. In prefabs, I can see it moved the health bars to the right, which was expected. I double-click the dragon prefab to get to this view. The health bar is sitting here, nested under the enemy. I set its horizontal position to -0.5 to center it. This works because health bars are exactly 1 unit wide. If you are using different sizes, you might have to play with this to figure out the right offset value here. I double-click Kaiju to get this view. I select the health bar and again set -0.5 as the horizontal offset. And I do the same for the health bar on the orc enemy. This arrow will take me back to the full scene view, and I enter play mode. Now we get health bars that shrink to the left, the most common way to do it, I guess. I move the towers around a bit so that each tower covers its own area. It doesn't really matter at this point. Currently, we have 3 waves of enemies that repeat over and over. What if I want the enemies to slowly get more health every time a new wave spawns, creating a simple difficulty curve? How would we implement that in a way that works with our data and with health bars? It's actually pretty easy. I create a public method I call initialize. It will take a float parameter for health multiplier. The point of data-driven code is to separate static configuration from runtime logic. That means values that don't change, like initial lives or settings, are stored in scriptable objects. Change in values, like the current number of lives during gameplay, should be stored in regular class properties or components. Every time initialize runs, we want to reset the enemy's current lives to the maximum value. So current lives of the enemy are the base max lives from the data times the health multiplier. As the waves come, the health multiplier will be increasing the total health enemies have over time. And as usual, we want to update the health bar to reflect these changes. Inside OnEnable, I delete these 2 lines of code. We will handle this inside the spawner script instead. So I save, and I open the spawner script. I want to do that here because we will calculate the health multiplier based on the current value of the wave counter. As the wave counter increases, enemies will be spawning with more and more health. Health multiplier is something we multiply base enemy lives by, so it will always be at least 1, the base value, plus wave counter value times 0.1. As wave counter increases, enemies' health will be increasing by 10% per wave. You can change this value here if you want to make enemies gain health at a different rate. Wave 1 will be 1.1, so 110% of base health. Wave 2 will be 2 times 0.1, so 1.2, 120% of the base health, and so on. Now I need access to the enemy script component on the enemy we just spawned. We are inside the spawn enemy method. I know the spawned object is an enemy, so get component enemy. I need that component because I want to access this initialize method we wrote on line 74. So let's call it here. And we pass it the health multiplier. This method will increase the maximum health of the enemy we just spawned based on the current value of wave counter, because we are passing it this health multiplier from line 95. Save that. I go to Scriptable Objects Enemies folder, and enemy orc has 3 lives, enemy dragon has 2 lives, and enemy kaiju has 10 lives. Those are the default base max lives values. I enter play mode, and waves are increasing. Dragon wave finished, so now kaijus are coming. We know that their base lives is 10, and tower projectiles do 1 damage, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Enemy health is already scaling. At some point you'll see that health bars grow noticeably. Like this. We don't want that. We want the health bars to never go over the maximum width, and if enemies get more health, the health bar will stay the same width, it will just fit more lives into that space. The issue is that here, the health percent ratio is using the fixed value of data.lives. We don't want to modify max health inside our data files, so let's hold that ever-increasing max lives value as a property up here. Private float max lives. Initially, this is max lives from the data, but as soon as wave number starts increasing, max lives value will be increasing by 10% per wave. So let's calculate max lives here instead, like this. Then, as we spawn an enemy, we reset its current lives to the increased max lives. And the health percent here, the value by which we scale the horizontal component of the health bar, will be the ratio between the enemy's current lives and those updating ever-increasing max lives. This will keep the health bar at the same width, fitting this increased lives amount into that same space. I start, and orcs have 3 lives. 1, 2, 3. Dragons have slightly over 2 lives, but not yet 3, as we increase the health by 10% per wave. Now we have kaijus, and we can see that if enemies have more lives, the health bar just shrinks by smaller chunks as they get hit. Then we get orcs again. The health bar is no longer too wide. We know that orcs start on 3 health, but if I count the hits, 1, 2, 3, 4. Our health scaling works, and the health bar doesn't go over its maximum width. In tower defense games, it's quite common to scale enemies' health like this to make sure the game stays engaging and doesn't become trivial as we build more towers, which would quickly overpower the basic weak enemies. Also, you can use this health scaling technique for many other games. I hope you are getting some value and learning new game development tricks. We have a way to defeat enemies. Now we need those enemies to reward some kind of a resource or currency that we will use to buy more towers or to upgrade our existing ones. I start by going inside Scriptable Objects enemy, and I open the enemy data script. I want to add a field with a float value for resource reward, how many resources we get when our towers destroy this enemy. Save that. And now each of those scriptable objects has a new resource reward field. So orc will reward 1 resource point, dragon will reward 2 points, and kaiju will give us 3 points. We will store and manage resources on Game Manager. I can close all these tabs. It will be an integer I call resources, and initially I set it to 0. I create a private method I call addResources. It will take an integer for amount, and inside we will increment the current resources value by the incoming amount. The amount will depend on which enemy was destroyed and what its resource reward value was. Let's open enemy script. For now, the only event that will give us resources is when an enemy gets destroyed by one of our towers, when this OnEnable event is invoked. Notice that it carries with it a reference to the entire enemy component. And when we invoke it here, we pass it this keyword. I need access to the enemy data we have here on line 6, because that's where we store resource reward values for each enemy type. So let's turn it into public read-only property. Public enemy data, data, fat arrow data, like this. We define a public property called data with capital D, and we are setting it equal to the value of the private field data from line 6. What I did on this line is a shorthand syntax. It's called expression-bodied syntax, and it's used to define read-only properties in C#. I could have also spelled this line like this, in a longer form. It would be the same. So this line is a public read-only way to access the private data field from outside the class. I do that because when OnEnable runs, it carries with it a reference to this entire enemy class, and from it we will be able to access this public data field to check how many resources this enemy rewards. Inside Game Manager, we will have a private method I call handleEnemyDestroyed. It will take that enemy reference as a parameter. Inside, we call addResources, which we defined here on line 37. And as the amount, we pass it the enemy that was passed here. .data, and on it, we get resource reward. So data is coming here from line 7, and we know each enemy data asset has a value for resource reward. Notice that resource reward in the data is defined as a float, but addResources expects the amount as an integer. So let's convert this value to an integer. Okay, so when we call handleEnemyDestroyed, it calls addResources and passes it whatever resource reward that enemy gives. The addResources method then adds that amount to our resources total. Now we want to run this method whenever the OnEnable event gets invoked. So up here inside Game Manager, we subscribe to OnEnable, and as a reaction, we will run the handleEnemyDestroyed method we just wrote. As usual, we will also remember to unsubscribe here. Save that, Game Manager selected, and I activate debug mode so we can see the hidden private resources field here. I play, and as we destroy orcs, we are getting resources. So let's create a UI element that will show the current resources amount to the player. I exit play mode and I go back to normal mode. Let's expand UI canvas. I copy and paste live's text to duplicate it. I rename the copy to resources text. I set its horizontal alignment to center. Default text will say something like resources. It doesn't really matter, we will override this value with code immediately as the game starts. I click here on Anchor Presets. I hold down Shift and Alt, and I choose Center Top Alignment here. I move it -50 pixels vertically to give it some space from the top. Yes, this looks good. I open UI controller script. I will need a reference to this resources text field, same as we did for wave text and live's text before. I copy this method and I rename the duplicate to update resources text. It will take an integer for current resources. Inside, I set resources text.text to a static part that says resources, plus a dynamic part with the current resources value. We have a function that will update the resources text. When will we run it? On Game Manager, I create a new public event that will carry with it an integer, and I call it, for example, onResourcesChanged. Whenever we add resources, we invoke onResourcesChanged, and we pass it the updated resources value. On UI controller, we wrote this method that will update the resources display in our UI. Up here, we will subscribe to GameManager.onResourcesChanged event, and as a reaction, we will run update resources text. And we also remember to unsubscribe down here. Save that. UI canvas selected. I see the new resources text field here. So I drag and drop resources text inside. Inside Game Manager, I also want to invoke onResourcesChanged event inside the start method when the game starts. Save that and play. Resources text will update immediately, showing 0. And as we destroy enemies, we are getting resources. We will spend these resources to buy new towers. We will be able to choose from multiple different types of towers. So we will need a UI panel that will display that selection of towers for us. But before we do that, let's create a game background and add more tower types for player to choose from. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Our game will have just the generic placeholder visuals. I want to build a fully functioning game that we can turn into different art styles. I drag and drop the Path1 image into the Assets Art folder. I put together an image where arrows point from waypoint to waypoint, showing where enemies will go. You don't have to do this part with the background, it's not that important. But if you want to, you can download the image in the resources section below. I set the sprite mode to single, mesh type to full rect, because this image has transparent parts. This will make sizing and positioning the image easier. I also set filter mode to point no filter and compression to none. Settings we use for pixel art. It doesn't really matter here, it's just a placeholder image anyway. I click apply, I expand the sprite, and it has only one frame now. I drag and drop it into the scene. I rename it to background. I reset the transform here. I scale it down horizontally and also vertically. I just want these arrows indicating how the waypoints follow one after another. Enemies will follow these arrows. I also added some spider webs in the corners just for fun. You probably have your waypoints set up in a different shape. Your path is probably different. That's why I said this part is optional. Having this image here is not that important for anything we will do next. I'm just playing a bit now. But if you want to have it and you want to use this image, you can always move your waypoints and make them create the same path shape I have here. Or you can create your own image. It's entirely up to you. We have this background image. We have towers and enemies in our game. Unity will decide kind of randomly what is rendered in front and what is behind. We want to be able to specify the draw order in our game. On the background game object or on any of the fast towers, I find the sorting layer field and I click Add Sorting Layer. This will take me to the Tags and Layers tab. Right now, everything in our game is on the default sorting layer. I click the plus icon here 4 times, and we will have 4 custom sorting layers: background, towers, enemies, and UI. This order matters. Background will be all the way in the back, behind towers and enemies. Objects on the UI layer will be all the way in front of everything else. My background game object will go on the background sorting layer like this. I will drag the background here under managers to hide it. Let's keep the hierarchy clean. Inside the prefabs folder, for the waypoint prefab, I set its sorting layer to background. But the order in layer will be 1 above the background image. The fast tower prefab will be sitting on the towers sorting layer. The projectile will also be on the towers layer, but in front of the towers, so order in layer 1. The dragon prefab will be on the enemies layer. Enemies will be in front of the towers for now, to keep it simple. I also double-click the prefab to get this view. I select the health bar, and I set it to the enemies sorting layer, order in layer 1. Kaiju will also be on the enemies sorting layer. Select health bar, enemies layer, order in layer 1. And I do exactly the same thing for the orc prefab. I click this arrow to go back to the regular scene view. UI elements, buttons, panels, and status text are all drawn on the UI canvas, so I set the UI canvas to the UI sorting layer, like this. UI will be in front, on top of everything else. I enter play mode. I have the background all the way in the back, towers in front of it, enemies in front of towers, and UI elements in front of everything. We are building this game as a data-driven code base, which means that the code that handles towers will stay the same, and we can create different types of towers by creating different data assets with different values. Just doing that will dramatically change what the towers look like and how they interact with enemies. Let me show you exactly what I mean. We will create 3 different types of towers, each with its own strengths and weaknesses. Inside Assets Scriptable Objects tower, we have the fast tower data asset. I want this tower to have a range of 3.5 units. It will shoot a projectile every 0.7 seconds. Projectile speed will be 10 units per second. Projectile duration is 2 seconds. And if it hits an enemy, it deals 1 damage. I duplicate the fast tower data asset by copy and pasting it here, like this. I rename the duplicate burst tower. This tower will shoot swarms of fast bullets, but they will not deal as much damage. Range will be 4, shoot interval 0.03 seconds. It will shoot very fast. We have object pooling for the projectiles, so we can afford to do this without sacrificing performance. Projectile speed will be 8. Projectile duration 0.5 seconds, and damage 0.1. We can always come back and tweak these values later when we are balancing our game. I duplicate burst tower and rename the copy strong tower. Strong tower will have a range of 3 units, shoot interval 1 second, projectile speed 4, it will spawn slow moving projectiles. Projectile duration is 3 seconds, but these projectiles deal a lot of damage when they hit, maybe 10. Okay, so we have burst tower, fast tower, and strong tower. They will need their own prefabs. So far, we only have this prefab for fast tower. I create a duplicate and rename it to strong tower. I select it and lock the inspector. I go to Art, expand this sprite sheet, and drag this frame into its sprite field. I go to Scriptable Objects Tower folder, and I drag and drop Strong Tower into the data field on the tower script. Tower script remains the same for all towers. We will only change this data, which will completely redefine the tower's properties and behavior. I go back to Prefabs and drag Strong Tower into the scene. If I play, this tower hits hard, but we can't really see that much difference yet. We will make each tower very distinct, but first let's duplicate the Strong Tower prefab and rename the duplicate to Burst Tower. My inspector is still locked, so I unlock it. make sure burst tower is selected, and I lock the inspector again. I drag this image into its sprite field. In the Scriptable Objects folder, I drag the burst tower data asset into its data field. Now I have a new burst tower prefab here, so I drag it into the scene. So we have a tower that shoots a lot of bullets. We have a slow, hard-hitting tower, and we have the base generic tower. We can now do so many different things with their data files to give them different behaviors or make them even more visually distinct. Let me show you an example of what exactly I mean. I open the tower data script and let's add something. How about projectile size? This will be a multiplier. Each tower will produce projectiles of different sizes. This will affect how it looks visually, but it will also have gameplay implications, because bigger projectiles have bigger colliders. My inspector is still locked, so I unlock it. Fast tower will have projectile at its base size. Multiplier here will be 1. Strong tower will have large, slow-moving projectiles, maybe double the base projectile size, or maybe 2.2 times larger. Burst tower will shoot many small projectiles. Size multiplier here will be 0.4, 40% of the original size, less than half the base size. All of these 3 towers use the same projectile prefab. They all instantiate their own reusable pool of these projectiles, and they hold it nested under them in the hierarchy. So let's open the projectile script. I will create a start method, which will run once when the object is first created. Now we can access the scale values here and apply the multiplier from tower data to them. Projectile has access to tower data on line 5, and from there it can access the projectile size value we just added to the data for each tower type. Transform local scale is equal to the base size of the projectile, vector3 1, which means 1, 1, 1. And we multiply the projectile's base value times data.projectile size. It's enough if we do it only once inside the start method here, because each tower holds its own projectiles. Once a tower creates its set of projectiles and sets the size here, we don't need to resize them again. Each tower will keep reusing its own set of projectiles. Save that. So strong tower, projectile size is 2.2 times the base size, fast tower keeps them at the base size, and burst tower shrinks them down to 40% of their original size. Just to keep it clean, I set the projectile prefab position to 0, 0. It doesn't really matter, since we move them around with code anyway. I will also set the position to 0, 0 on burst tower prefab, and on fast tower prefab as well. And actually also on strong tower prefab. And on waypoint. This will have no effect on anything, but I like to keep this clean. Enemy prefabs are all already on 0, 0 positions. To really see what we built, I need more enemies. Go to Scriptable Objects Wave folder. Wave 1 will spawn orc every 0.8 seconds, 15 of them in total. Wave 2, 20 dragons, once every 0.5 seconds. Wave 3 will spawn a kaiju every 1 second, 15 in total. I also go to the spawner script here and set time between waves to 1 second. Save that and play. Right, so now we can finally see a proper difference. We have 3 types of towers that all shoot the same projectile prefab, but they all do it in very different ways. We didn't change any code for separate tower types in the tower script or in the projectile script. Those scripts are identical for all types of towers. All we changed was the data we feed to those scripts, our scriptable objects. We can create more types of towers that shoot projectiles following this pattern we established, or we can keep this pattern even if we want to create different families of towers that don't produce this projectile prefab. Maybe they produce area of effect, like slow or fire, or another set of towers that produce bouncing energy beams, for example. The idea of how to do that would be to create code inside the tower script that is shared for all those different tower types. And the only difference would be in the data. For example, in the data, we specify what tower family this is. Is it a projectile tower, area of effect tower, or energy tower? And then in the tower script, we would create an if-else block that will only run certain parts of the code depending on the family this tower belongs to. That way, we keep this code base data-driven, and we can have unlimited creative ideas when it comes to tower types. But this is going into a bit more advanced territory. Let's keep this beginner-friendly for now. I will align my towers a bit here by setting their positions manually. Strong tower, minus 5.60. Burst tower, minus 5.61. I select all my towers and I duplicate them. Use the move tool here, and I move the duplicate fast tower somewhere here. Strong tower here, and burst tower duplicate somewhere here. I will also round down their position values just to make this cleaner. It doesn't really matter. We will not be placing towers like this in the final game. I'm just creating an example game map. I do this because I want to trigger and show you two very common bugs that will happen in a game like this, and I will show you how to easily fix them. As I play, we have lots of enemies come in, multiple towers shooting projectiles all over the place, and lots of situations can happen now. For example, enemies might get hit by multiple projectiles from multiple towers at the same time. Enemies might get destroyed while they are in the range of 2 towers at the same time. Many different situations can happen now with so many towers and so many enemies on the screen. So some of these situations can create an issue. To debug our game, we have to understand what is happening and why. We programmed our game to wait until the previous wave of enemies reached the end of the path or was destroyed by towers before the next wave starts spawning. But here, we can see that we get the next wave spawning before the previous wave is done. Why would that be? I will go to the enemy script. We know our enemies invoke 2 events, on enemy reached end and on enemy destroyed. One is when the enemy reaches the last waypoint here, and the other is when the enemy's lives fall below 0. Inside Spawner, we are subscribed to these events, and in both cases, we increase enemies removed by 1. Only when we've spawned all the enemies in the wave and removed the same amount of enemies, we allow the next wave to come here. So why would the next wave come early? It's because this enemies removed count is wrong. 1 or more enemies got counted twice. Maybe the enemy reached the end and was destroyed in the same frame. Or the enemy got hit by multiple towers and invoked its event multiple times before it got deactivated. All these things can happen, potentially. All we have to do is prevent the same enemy from being counted twice towards enemies removed, and everything will be fixed. I will give enemies a private boolean I call has been counted. By default, I set it to false. This enemy hasn't been counted towards enemies removed yet. Down here, where the enemy reaches the last waypoint, we set has been counted to true, because this event will send a signal to Spawner and it will be counted there. Same thing here, when the enemy's lives drop below 0, that enemy has been counted as well. And when we initialize the enemy reusing it, I set has been counted back to false. If an enemy has been counted, it means it was either destroyed or it reached the last waypoint, so we don't need to run this update method for the next frame. If has been counted is true, we return early and don't run the rest of the code inside update. That will prevent this event from being accidentally invoked twice. Same in take damage. Once we enter this code block and has been counted is set to true, the event is invoked, which will cause the enemy to be counted towards enemies removed inside the spawner script. We make sure this code cannot run again. And down here, inside initialize, I have to make sure I reset has been counted to false when we reuse the enemy. And initially, it will also be set to false here. Okay, now it should work. We fixed a bug with the next wave coming too early. We have one more bug that can potentially happen. Look at this strong tower. It's shooting into empty space. Why is it shooting when there are no enemies in range? I pause the game while still in play mode. Let's select the problematic tower and enable debug mode to see its private enemies in range list. We are on the kaiju wave, but the tower is still holding a reference to a deactivated orc object. It sees it in its list and it's shooting at it, even though this orc is no longer in the scene and it was probably destroyed by another tower. There could be a scenario when an enemy is within a tower's range and gets destroyed. Our towers hold a list of enemies in range, and they add and remove enemies from it as enemies move in and out of range. But sometimes a specific set of circumstances can cause the tower to keep a reference to a deactivated enemy. I don't know what these specific circumstances are that make that happen occasionally, but I can still fix it easily. Our enemies are reusable pooled objects. We know that this orc it's holding in its list has been deactivated, probably because another tower destroyed it. So all we have to do to fix this is to make sure that towers keep active enemies in their lists and automatically remove enemies that were deactivated from their lists. I resume play mode and I go back to normal mode. When the orc wave comes again and that same orc game object is reused, the tower manages to clear it from its list, it seems. It's not shooting into empty space anymore, so it kind of fixed itself. But let's make sure this bug can never happen in our game. I open the tower script. This same script is shared for all our tower types. Every time before the tower shoots, we will first check its enemies in range list, and we will filter out enemies that are null and enemies that are not active in hierarchy. Remove all method removes all elements that match a condition. I'm saying remove the enemy if the reference is missing, if the enemy has been destroyed, for example, and also if the enemy object has been deactivated in the scene, which is more likely here because we are reusing our enemies. Enemies are in object pools. That way, our towers will not shoot into empty space trying to target deactivated enemies. We have 3 projectile towers with different properties implemented in a data-driven way. We need a system that will allow the player to place these towers in the game world, if they have enough resources. To do that, we have to learn a few basic and useful UI techniques. Let me show you how to create a UI panel and how to create an in-game system that will allow us to show and hide it by clicking on game objects in the game world. We will use this panel to show the player a selection of towers whenever they want to place one. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I select all these towers and I disable them by unticking this checkbox, just to keep the scene a bit cleaner while we work on the UI. I will also disable the path, but I have to enable it before entering play mode. The way we wrote the code, the game will not play without a path. I right-click UI Canvas and go to UI Panel. Notice that its Rect Transform Components anchor preset is set to stretch to fill the canvas. We can set its left, right, top and bottom offsets, and the size of the panel is calculated based on the distance between the anchors and the offset values we set here. I want to be able to set the width and height of the panel. To do that, I have to change the anchor presets from a layout with stretch anchors to a layout with fixed anchors. I hold down Shift and Alt, and I will go for this center middle preset. Now, these fields changed to X and Y position and width and height. I set the panel to 1400 by 800 pixels. We can also move it vertically up and down like this. It has a background image, and I can change its color here. I want to go for black, and this alpha slider all the way to 255 will make it non-transparent. We will use a panel like this for the pause screen and also for a menu to select which tower type to place in the world. I created this simple pixel UI image as a placeholder that will give us cards, buttons, and a cross for a close-in button. You can download all resources in the description down below. Eventually, this will be replaced by a proper slick UI, but for now, this is fine. It's pixel art, and I want to keep it sharp, so I set filter mode to point no filter, and compression to none. I click apply. If I expand it, you can see Unity already sliced the individual elements automatically. I rename it to Tower Panel. I right-click the panel and select UI, Button, TextMeshPro. I will call it Close Button. Let's go to Assets, Art, and I want this big X. With Close Button selected, I drag and drop it into the source image field. Right. I set its width and height to 170 pixels. Anchor presets, and I go for top right while holding down Shift and Alt. I move it 50 pixels outside the panel like this. Okay, this will be our panel. It has a text element under it. I'll just delete it, no text needed here. I select Tower Panel and I uncheck this checkbox to disable it, and I check it to enable it. We want to be able to show and hide it like this, but with code. As usual, we'll handle it from inside the UI controller script. I need a reference to the entire game object. I'll call it Tower Panel. Save that. On UI controller, I see this new field for Tower Panel, so let's drag it in. I will create two methods. Private void show Tower Panel and hide Tower Panel. Here I say Tower Panel dot set active true, and here I set active to false to hide it. I will make this one public so we can call it from other scripts and from buttons in the Unity inspector. That way I can go here on the close button, I find its on-click block, and I click plus. I drag the UI canvas here, and here I select UI controller, hide Tower Panel. So when we click this close button, take UI controller and run its public hide Tower Panel method. Now if I play, I get an error. I exit play mode. This path game object has to be active, otherwise our game breaks. I might refactor that later, but for now it's not a problem. Path is active, UI canvas selected, and I play. Inside the game view, I can now click the close button and it will close the Tower Panel. Okay, great. We learned how to create a UI panel and how to create a button we can click to close it. I select the panel and it will be hidden by default, so I uncheck this. This panel will have cards that allow the player to choose which tower to place. So how do we open the panel? By clicking on a platform game object. Our game world will have platforms set all around the map that we can click, and we can choose which tower we want to place on them. Time to create the platform so that we can click it, and that click will open the tower panel. I go to my spreadsheet, and this small square will be the platform, for now, placeholder art. I drag it into the scene, and I rename it to platform. In the final game, this platform can look like anything we want. It can be almost invisible, blending in with the game world, if that's what we want. This is all just placeholder art. These platforms will be clickable, so they will need a collider to detect that click. I add component, box collider 2D. I could resize the collider, but I will actually leave it larger than the image, so that we can click somewhere around the platform and it will still trigger the click event. I go inside Scripts Tower and I create a new MonoBehavior script. I will call it Platform. Let's open it, and I delete all the code inside. Platform game object selected, and I attach the platform script to it as a custom component. When we click this platform, I want to open the tower panel we made earlier. It will give us a choice of which tower we want to build on this platform. Detecting clicks on game objects in Unity can be a bit tricky if our scene has many towers with huge colliders around them and maybe other objects that also have colliders, because I want to only detect click on the game object that is this platform and its collider. So I want to detect a click, but I want to filter it. We will detect clicks on platform colliders only. I will use Unity's new input system, which comes pre-installed and enabled by default in Unity 6 and later. The new input system is notoriously quite complex compared to the old one, but it actually also has a simple syntax for quick actions. So let me show you how easy it can be. Basically here I just want to say if left mouse button was clicked using the new input system. The way to do it is to say mouse dot, and to be able to use it, we will need the Unity Engine input system namespace up here. Then we can say if mouse.current.left button dot was pressed this frame. Simple syntax using this new input system. Inside, we want to get the position in the game world where the mouse is currently pointing. Screen to world point takes the current mouse position in screen coordinates, pixels on the monitor, and converts that screen position to a world position, which is what Unity uses to place game objects in the scene. This line simply means detect where in the game world we clicked. I will now use Raycast Hit 2D to filter platform colliders to make sure our clicks don't get blocked by huge colliders when our game world is full of towers. This code is casting a 2D ray from the mouse position into the world to see if it hits something. Let's write this line of code and then explain it. World point is where the mouse click was detected. Vector to 0 is the direction of the ray. 0 means no direction. We want to detect something that's exactly under the point where the mouse was clicked. The next argument is the maximum distance the ray should check for collisions. Infinity means check as far as needed. And finally, layer mask is what the ray can hit. Here I'm saying only detect collisions with objects on the platform layer and ignore everything else. This is a pretty good way you can filter your clicks to only respond to collisions with specific objects in your game world. I just have to create this platform layer mask and associate platform game object with it. Let's create a private layer mask property. I will call it platform layer mask. Save that. Platform game object selected, and inside Unity Inspector, we have this layer dropdown. These layers can be used for a few things. In this case, we will use them for physics interactions to define which objects can collide or raycast with each other. We have some predefined layers here, but I want to add a custom layer. I will call it platform. Now I can select the platform game object and I associate it with my new platform layer. In the script, we have the platform layer mask field, and we set the layer mask to the platform layer, like this. Okay, so the platform is on the platform layer, and we are filtering this Raycast Hit 2D to interact only with objects on that layer. Platform game object has box collider 2D, so I say, if the raycast hits a collider, we know we clicked a platform because we are filtering all of the other ones out. And I save it in a temporary helper variable I call platform. It will be the game object that was hit, and on it I find the platform component. I know this seems like a lot of code to detect a simple click on a specific game object, but it's a quite robust and reliable way to do it, and I like to use it to make sure our game is not buggy. Debug log platform clicked, just to check if it works. Do you know another reliable way to use the new input system to detect clicks on game objects that are placed in the game world? Keep in mind, this is different than detecting clicks on UI, because for that we would use a completely different technique. Let's discuss that in the comments. I save my changes, and back in Unity I go to Assets Prefabs, and I drag the platform game object in here, turning it into a prefab. Let's drag out multiple platforms into the game world, maybe here. And let's put one up here and here. somewhere where the tower panel won't cover it when it's active. I enter play mode. I can click the platforms, and I'm getting the debug log. We are detecting platform clicks. Perfect. When we click a platform, I want to invoke an event that will carry with it a reference to the specific platform that was clicked. I will call it onPlatformClicked. I'm using action here, so we know we need the system namespace up top. When the platform collider is clicked, we invoked the onPlatformClicked event and we pass it the platform that was clicked. It's important we know which platform was clicked because later we will place a tower on that specific platform. UI controller has this function to show tower panel. I want it to run when a platform is clicked. I create a private method I call handlePlatformClicked. Inside, we will run showTowerPanel. Up here, we will subscribe to the platform onPlatformClicked, and as a reaction, we call handlePlatformClicked, which will open the tower panel. I'm getting an error because onPlatformClicked is carrying with it a reference to the platform. So I need to make sure it's expected as an argument here, like this. We will use it in a moment. First, let's try if everything works. As always, I should also unsubscribe inside the onDisable method. Okay, so we are filtering clicks here, and only if the raycast hits objects on the platform layer, it invokes the onPlatformClicked event. UI controller is subscribed to that event, and whenever it's invoked, it will run the handlePlatformClicked method that will open the tower panel. Save that, and let's see if it works. I play, I click any platform, and it will show the tower panel. I can close it by clicking the big white X, the close button. I click this one to open it, close button to close it. This is a very useful thing for your games. Clicking a game object in the game world to open a UI element, like this panel, useful in so many different scenarios. When the tower panel is open, I want to stop the game. I want the game to freeze so that the player can strategize and take time to think. Let's create a generic method to pause and unpause the game that we can call whenever we need it. I have a lot of freedom here in terms of where to place this functionality, but I think it makes sense to put it inside Game Manager. Down here, I create a public void setTimeScale method. It will take a float parameter for scale. Inside, we set Time.timeScale to the scale value that was passed. The way Time.timeScale works, if it's 0, the game is frozen. If it's set to 1, the game runs at a regular speed. And for example, 2 means the game is running at double speed. And we will also do that later because this is a tower defense game and it needs buttons to speed it up and slow it down. But first, let's do this bit. I can follow the structure we used before, invoking events and reacting to them. But if we overuse this, it can result in a convoluted web of events and subscriptions. So in this case, just as my personal choice to keep this a bit simpler, I will implement a singleton pattern, which basically means make Game Manager available globally and call method on it from anywhere in our codebase. This line makes Game Manager instance globally accessible from any script. Get private set means other scripts can read it, but only this class can assign to it. Whenever we create a singleton, we have to do this bit in the awake method, and this bit of code is always the same. Inside the awake method, I say, if there already is an instance and it's not this one, destroy this duplicate. Otherwise, set this as the instance. This is a pretty standard thing to do. It prevents multiple instances, in this case multiple Game Manager objects, from coexisting to avoid bugs. So, I made Game Manager instance globally accessible so that I can call this public setTimeScale method from other scripts. Let's do it. Inside UI controller, when we show tower panel, we pause the game. Game Manager instance setTimeScale 0f. F stands for float. Inside Hide Tower panel, we set timescale back to 1f to make game time flow again. Save that and let's play. I click a platform. I close the panel. I click a platform. Tower panel shows. Game is paused. I close the panel and we play again. I open Tower panel to pause the game. Close it to play again. I hope you learned something new in this lesson. In the next part, we will add some cards representing our 3 tower types, and we will be able to choose which tower we want to place on the platform we selected. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I start by selecting all these deactivated towers and deleting them. We will place towers on the platforms from now on. I want to create a set of cards, one for each tower type. When we click a platform, we open a panel with a selection of cards to let the player choose which one to place. I open the tower data scriptable object and I will define a few more properties. We will need an integer for cost, how many resources it costs to place this tower type. And we will need a sprite, an image that will represent the tower on the card. Save that. Inside Scriptable Objects Tower folder, Fast Tower Data Asset, I set the cost to 50 resources. If you want, you can lock the inspector here. I will do it without locking it by clicking the Art folder, expanding this sprite sheet, and dragging the Fast Tower image into this field. I want this image to represent the Fast Tower on the selection cards. You can choose a different image if you want. It doesn't have to be the same image we use for the actual tower game object. I'm just using the same ones for simplicity. Back to the tower folder, Burst Tower Data Asset will cost 75 resources. In the Art folder, I drag and drop this image into the sprite field. Finally, Strong Tower. Cost will be 100 resources. And sprite will be this one, so I drag it in. So all 3 data assets have a cost value and a sprite image. On UI canvas, I select Tower panel and activate it here. Let's deactivate the path for a moment, just so I have a cleaner workspace. I right-click Tower panel and I create an empty game object nested under Tower panel. I will call it Tower Card. I go to Art and I find my Pixel UI art asset. On Tower Card game object, I add component, image. I drag and drop this card frame image into the source image field. Card width will be 300 and height 450. I right-click Tower Card and I go to UI Image, making sure it's nested inside the card. The image will be 200 times 200 pixels. For anchor presets, I hold down Shift and Alt and choose Top Center. Move the image 75 pixels down here. I right-click the Tower Card game object again and select UI Text, TextMeshPro. For anchor presets, Shift and Alt, and I select Bottom Center. It will be 300 times 100. Alignment center middle. Font size 50. I move it vertically and adjust the height. Maybe this looks fine. So this will be a tower card. What it displays, which image and which text will depend on the data asset we connect to it. I rename this to tower image and I rename this to cost text. Default text will say something like cost. I go to Scripts Tower folder and I create a new MonoBehavior script. I call it Tower Card. I attach the tower card script to the tower card game object as a component and I open it. Inside, we will need a field for image. I call it, for example, tower image. To be able to use this, I need the Unity Engine UI namespace up here. We will need another field. Type is TMP text, so the TMPro namespace here, and I call it cost text. I need a method that will check data and associate this card with the image and cost of that particular tower type. It will be public because I want to be able to call it from outside this script file, and I will call it, for example, initialize. I will take the tower data as a parameter, and I call it, for example, data. Inside, I set towerImage.sprite to the sprite we put into the tower data, and costText.text will display the cost of the tower coming from the data. Cost is a number, and we want to display it as text, so I convert it to a text string using the built-in toString method. So we have a tower card. When we call initialize from somewhere in our code base, it will take tower data as an argument, and it will set the image and cost text on that card based on the data we pass to it. Save that. On the tower card game object, I see two new fields. I drag its tower image here, and cost text here. Inside assets prefabs, I drag tower card in, turning it into a reusable prefab. We will need it because we want to create multiple cards. It turns blue here, telling us it's a prefab now, so I can delete it from the scene. I have the card inside my prefabs folder saved for later. I want to create, let's say, 3 of these cards dynamically with code, and align them in some sort of a grid under the tower panel. In Unity, we can organize UI elements in a grid very easily. I right-click tower panel and I create an empty game object. I will call it cards container. Anchor is center middle here, so I can set its width and height. I will go for 1300 times 500 pixels. I don't know if my game will display 1, 2, or 3 cards. It will depend on how many cards I have unlocked. So I will give cards container a component called horizontal layout group. It automatically arranges the child UI elements of cards container in a horizontal line. That way, we don't have to manually position each card, and we make sure they align based on how many of them we display. I will show you. Horizontal layout group is great if you want automatic horizontal arrangement, consistent spacing and alignment, and dynamic resizing support. It does all of that automatically. We just need to set it up. With cards container selected, I drag and drop tower card prefab under it to create 3 copies, like this, just so we can see how the alignment works. Cards container selected, and I set child alignment to middle center. Perfect. If I delete one of the cards, you can see the 2 remaining ones reposition, like this, still evenly spaced out. And if we have only 1 card, it will be centered, like this. This is exactly what we need. Let's delete this card. I have cards container with a horizontal layout group, and we know we can dynamically add up to 3 cards under it, and they will be perfectly aligned. I right-click tower panel, and I select UI text. I will call it title. The text will say choose a tower. Anchor preset, I hold Shift and Alt and select bottom center. Width 1200, height 100. Text alignment center middle. Font size 50. I move it up vertically a little bit. Cards container selected, and I move it vertically up as well. Tower panel selected, and I disable it. I play. I forgot to enable path again. I exit play mode, enable path 1 game object, and enter play mode again. When I click any of the platforms, we get tower panel. I want to dynamically generate 1 card per each tower type to give the player a choice. Which tower do you want to place on this platform? Where will I handle that logic? For a bigger game, I would create a separate tower manager script, but for our small game here, I can handle that inside UI controller, since that's where we handle all other UI elements as well. I will need a field for the tower card prefab. It is a game object. And I need a transform for cards container. Save that. On UI Canvas, I see the new fields, so I drag cards container in here. And from prefabs, I drag tower card prefab in. I will keep an array that holds tower data. I will call it towers. We will have a list of game objects. I call it active cards, and initially I set it to a new empty list. To be able to use list, I need system collections generic namespace up here. Down here, I create a private void method called populate tower cards. Whenever we call it, first I want to make sure we delete the old cards if there are any. So for each card in active cards, destroy that tower card prefab instance. And then clear the list to make sure it's empty. After that, I will cycle over the towers array that holds data asset files for each tower type. We defined it up here on line 15. Let's actually save this, and on UI Canvas, I see the towers list here. I go to Scriptable Objects tower folder, and I drag fast tower in. Let's leave it like this. And back in the script, for each data asset inside this towers array, I create an instance of tower card prefab. Temporary helper variable, game object type, I call it card game object. We know that instantiate method creates an instance of a prefab, a copy of a prefab. That prefab is tower card prefab from here. And as its parent element, I set this cards container like this. I need its tower card component, so one more helper variable of tower card type. I call it, for example, card. It will be the card game object we just instantiated, dot get component tower card, like this. Why do we need this component? Let me show you. Save that. Prefabs, tower card prefab here. I open tower card script that we just accessed from inside UI controller, and we need it because we want to call this public initialize method, which will fill the card with relevant image and cost text based on the tower data we pass to it. So I call it using this card reference .initialize, and I pass it data. As we cycle over towers array, data will represent all tower types one by one, filling them with relevant data. And as we do that, still inside the for each loop, we add that card we just created and filled with data to active cards list. Okay, so we destroy the old prefabs, we clear active cards list from old data, and for each data asset inside towers list, we instantiate a copy of tower card prefab. We fill it with data for that particular tower type, and we add it to active cards list. Now I just have to call this every time I show tower panel, which we know runs every time we click any platform in the game world. I save that, UI Canvas selected, and the towers list has only the fast tower in it at this point. I play, I click a platform, and we get a card with the image and cost for the fast tower. Let's say that this is how the game starts. We've unlocked only one basic tower type. But as we play, we unlock more types of towers. I exit play mode, I go to Scriptable Objects tower, UI Canvas selected, and I drag the burst tower into the towers list. So now I have two. If I play and I click a platform, this is what it looks like when we unlock two tower types. They align horizontally. I exit play mode, I add the strong tower to the list, and when I play, when I click a platform, we have all three towers displaying their sprites and their cost to the player. If you have more tower types in your game, you can always make the cards smaller to fit more of them here. I will keep it simple for now. Now the fun part. Let's write some code that will let the player click one of these cards, and the tower they select will be placed on the platform. On the tower card script, I define a private variable. The type is tower data, and I call it tower data like this. When we initialize a tower card to fill it with values for the image and text, we also take the incoming data and save it as tower data here to make sure this tower card knows which tower data type it is associated with. Then I will make tower card broadcast an event, public static event using the action keyword, and it will carry with it the tower data of the selected tower type. I will call the event, for example, onTowerSelected. To be able to use action, I need the system namespace up here. I will have a public placeTower method here. When called, we will invoke the onTowerSelected event, and we pass it tower data. So whichever script subscribes to it will know which type of tower was placed. This method is public because I want to call it from a button click. Save that, Prefabs folder, and tower card prefab here. I add a component to it, and it will be a button. It has an on-click block here. I click plus, and I drag in tower card itself. And here we will run tower card place tower. So when the tower card is clicked, it will call the place tower method, which invokes an event broadcasting to other scripts which tower was just placed. I go back to tower data, and I add one more field of game object type. I call it prefab. We need to know which prefab is associated with which tower type. Save that. Burst tower data asset selected, and we can see the new prefab field here. If it helps you, you can always lock the inspector here. I don't need to do that. I just go to the prefabs folder, and with the burst tower data asset still selected here in the inspector, I drag and drop the burst tower prefab into this field. Back to Scriptable Objects tower folder, fast tower data asset selected, and I make sure I see it in the inspector here. Prefabs folder, and I drag the fast tower prefab into the empty prefab field. And one more time, this time for the strong tower, prefabs folder, and I drag the prefab into the prefab field. Okay, so we added this line to the script, and we made sure all tower data assets have a value in this field. Whenever we click a tower card, this place tower event will run, which invokes a function that carries with it tower data, which contains the specific prefab we want to place. Save that, and inside the prefabs folder, platform prefab, I set its position to 0, 0, just to keep this nice. Let's open the platform script. I could have a separate tower manager script to do that there, but for our small game, I will handle placing towers here. I create a public place tower method, which will take tower data as an argument, and I will call it, for example, data. Inside, we will instantiate the prefab from that incoming data. Where do we want it? At the position of this platform. Rotation will be the same as the platform, so no rotation. Quaternion identity means no rotation. And I want the tower nested under the platform in the hierarchy, just to keep it clean. So as the parent, I set transform, which means set this platform as the parent of the tower we are about to place. So now let's open the UI controller script. We have the tower card script. When a tower card is clicked, it will run the place tower method that will invoke this event, carrying with it the data of the tower that is associated with the card that was clicked, so we know which tower the player wants. UI controller will subscribe to that event, towercard.onTowerSelected plus equals handle tower selected. And as always, we also unsubscribe here. This method doesn't exist yet, so let's write it. Down here, private void handle tower selected. We know that the event is carrying tower data with it, so we make sure it's expected here. Like this. So now, UI controller knows which tower was selected, and I will need to know which platform we want to place that selected tower on. So up here, I define a private property. Type is platform, and I call it current platform. the platform that was clicked, and we are about to place a tower on it. The platform class has this public method that will set the platform itself as the parent of the tower. So how do we keep track of what is the currently selected platform the player wants to place a tower on? We can do it in here because we are already subscribed to handle platform clicked, and we already made sure that this event is carrying with it platform that was clicked. So convenient, almost as if we planned this. So whenever any platform is clicked, we will always set it to current platform here. And when a tower card is clicked, handle tower selected will run. We know what the current platform is, so we take it, and we will call its public place tower method, passing it the tower data of the selected tower the player clicked when choosing from the 3 tower cards. And here, the instantiate method will run, creating an instance of the prefab from tower data, placing it at the position of this selected platform, and setting the selected platform as the parent in the Unity hierarchy. Once we select a tower, we can hide the tower panel, which will also unpause the game and resume gameplay. I save that and I play. This is probably the most complicated thing we did so far in this class. From my experience as a beginner, the biggest struggle always was keeping track of the logic between script files, how the methods talk to each other, and how the data is passed around. This was quite advanced because so many things happen between files, but you made it. We are here, and we can click any platform, we get a pop-up, and we can choose which tower to place. When we choose it, the game will place the tower we selected on that platform. Finally, we have something closer to a playable game. After this, the rest of the class will seem so easy for you. What's next? Right now, we can place unlimited towers because they are free. Let me show you how to clean this up to prevent bugs, and then we will implement a simple mechanic that spends resources when we are placing towers. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. So here is a bug and how to easily fix it. I play my game and notice I'm clicking on this platform. I want to place a tower here. I get a tower panel pop-up, but before I choose a tower, I click on a different platform, let's say by accident, for example on this one. And when I choose a tower, it isn't placed at the platform I selected originally, it's placed on the last platform I clicked accidentally. Let's try one more time. I click this platform, I want to place a tower here, but while the panel is open, I click this other platform, and only then I choose a tower. The tower is placed on the last platform that was clicked. I want the tower to always be placed on the platform that initiated the opening of the tower panel. Once the tower panel is open, we should not be able to switch platforms again until we close the panel first. This is a very easy fix. I exit play mode and I open the platform script. Let's do a public static auto-implemented property. The type is Boolean, and I initially set it to false. Public means it can be accessed from anywhere, and static means it belongs to the platform class itself, not to any instance of the class. This getSet allows us to read and write this property. I want to have this global flag that can be checked and unchecked to track whether the tower panel is open or closed. If the tower panel is open, we return, preventing the rest of this code from running. So if the tower panel is open, we are no longer detecting clicks on platforms. This means that after we open the tower panel, it's impossible to accidentally select a tower platform and place the tower in the wrong place. Now I just have to make sure this global flag is being set to true and false appropriately. It's public, so I can access it from other scripts. Save that, and I open UI controller. Inside Show Tower Panel, I access the platform class and that static property we just defined, called TowerPanelOpen, and I set it to true. As we said before, the static property belongs to the platform class itself, not to any instance of the class. When we open the tower panel and set it to true, we are no longer detecting clicks on other platforms here, and when we hide the tower panel, we set TowerPanelOpen to false, allowing clicks on platforms again. Save that and play. I click this platform to open the tower panel. While the panel is open, I click this other platform. Then I place a tower, and the tower was correctly placed on the original platform that initiated the opening of the tower panel. Perfect. We fixed it, and we learned a use case for public static properties. I exit play mode. I move Game Manager up here just to stay organized, and I open Game Manager script. I set the initial resources to 175, so we have enough to get a few starter towers. Down here, I create a public method called spendResources. It will take one parameter, an integer for the amount. If our current resources are greater than or equal to the amount we are trying to spend, initially we start with 175. We take the current resources and reduce them by the amount. And whenever resources change, we want to invoke onResourcesChanged event and pass it the updated resources value, which will make UI controller update the resources display text. Inside UI controller, whenever we select a tower we want to place, we will call this new public spendResources method that is sitting on Game Manager instance, and the amount we want to spend depends on which tower was selected, so we take it from TowerData.cost, like this. Save that and play. I click a platform, and depending on which tower I choose, that amount of resources will be deducted from my total resources. Let's say I select the strong tower, which costs 100 resources. The tower is placed, and I only have 75 resources now. But if I choose another tower that costs 100, we can place it, but that amount was more than what we have, so the resources were not deducted. If I choose a tower I can afford, like this one, that costs 75, it will deduct the resources correctly. I can keep placing towers even if I have no resources to afford them, so let's adjust the code a little bit. Every time I want to place a tower, I need to check how many resources we currently have. This is a private property I can't access from other scripts, so let's create a getter, a way to read the current resources amount from anywhere in our codebase. This is a shorthand syntax that creates a public read-only property I call resources. When I use it, it returns the value of this private variable. Since there is no setter, we cannot assign a value directly from outside the class. We can only read this current value. In short, this line exposes the private resources variable publicly as a read-only property. A simple getter returning the private field's value securely. So here, in UI controller, when the user selects a tower by clicking one of the cards, we first check if the resources we currently have are greater than or equal to the cost of the tower we are trying to place. Only if we can afford it, we spend resources and place the tower. I put this hide tower panel outside the block because even if we can't afford the tower, we will close the tower panel and resume the game. Okay, let's playtest again as we go just to make sure everything is working so far. I place the strong tower for 100 resources. I place the burst tower for 75 resources, and now I have 0. So if I try to place another tower now, the panel will close, but there is no tower placed on the platform. Perfect. I want to display a message that will tell the player that they can't afford to place the tower. I make sure I'm not in play mode, and I right-click Resources Text. I go to UI Text TextMeshPro. I will call it No Resources Text. I make sure it's nested under Resources Text, because this error message will relate to that field. With No Resources Text selected, I go to Anchor Presets. While holding Shift and Alt, I go for top center here. Width will be 600 and height is 50. I want to move it down, maybe minus 75. The text will say not enough resources. Alignment center middle here. and text color will be red. Okay, I move it up, -50 here. That's better. And I make sure I spell resources right. By default, it will be disabled. This text will only appear when the player tries to place a tower they can't afford. This message will appear for a few seconds, and it will automatically disappear again. To do that, I need a reference to the entire game object up here in UI controller script. I will call it noResourcesText. Save that. On UI canvas, I find the field here, and I drag noResourcesText inside. Notice this is text, same as these, but the type here is game object, not TMP text. We do this because we want to show and hide the entire game object dynamically. We don't want to modify the text it contains, so that's why the different type here. Down here, inside the handle tower selected, I create an else block. And inside, I want to start a countdown to show and automatically hide that error message. So start coroutine, and I pass it show no resources message like this. This function doesn't exist yet, so I define it down here. Private IEnumerator. And to be able to use this, we need system collections namespace. My compiler is also accepting it from system collections generic namespace up here, so let's see if it works. Down here, I will call it show no resources message. And inside, I will first immediately make the no resources text visible. Then I will do a countdown of 3 seconds using yield return new wait for seconds 3f, and after 3 seconds we deactivate no resources text again. And now I can see I can't actually use IEnumerator from this namespace. I need to go up and use system collections for the non-generic IEnumerator, because that one is what Unity's coroutine system uses internally. Okay, now we got this right. When we select one of the towers on the cards, if we have enough resources, we place the tower. Else, meaning we can't afford it, we start the coroutine, this countdown that will do things with a delay. In this case, it will show the error message. Wait 3 seconds and hide the message again. We will also immediately hide the tower panel. Coroutines in Unity are methods that can pause execution and continue later. They can run alongside the rest of our game logic without blocking it. The most common use case is this, where we want to create a delay between events, when we want to wait a little bit and run some code with a delay. Let's save that and play to see if it works. I will place some towers to spend my resources. Now I have only 26 resources, which means I can't afford any of these towers. If I click one of them, the panel closes and I get the not enough resources message that will show for 3 seconds and then disappears again. I try again. Let's try to place a tower we can't afford. And again, I get the warning message that I don't have enough resources. Awesome. Also notice that towers we place are nested under their associated platforms in the hierarchy. This is good to keep this area organized. We learned how to show and hide messages to give player feedback, a useful skill in game development. We are also no longer able to place towers if we can't afford them, so we cleaned tower placement up. We have a pretty solid system here. Nice work. I exit play mode and I create an empty game object. I call it platforms. I will put all platforms inside, just to keep this tidy. If I want these platforms to be aligned perfectly, I can adjust their x and y coordinates manually here. It's not necessary, but it will look better. You might have a different map and different platform placement, so don't worry about this. I will just clean up my platforms. I will actually delete all of them and leave only this one at position -5 plus 4. Let's start from up top here. I copy and paste it 5 times. Notice my parent platform's game object is not exactly at position 0, 0, which might help with alignment. I can move all the platforms by moving just the parent. This helps me to be able to use whole numbers for the platform positions to make this part easier. If I can't place the platforms by using whole numbers, whole units on the platforms themselves, I can move the parents platforms object to some position with decimal points, just so I can use simple coordinate systems for the platforms. Positions like -5 plus 3 for this one. And all of them are horizontally at -5, and this one is vertically at 2 units. This one is under it, so +1 vertical position. This one is at position 0. And this one is -1. I copy this one and let's place it at -2. So we have a nice line of platforms perfectly aligned. It's not that necessary, we will move them later depending on world map art, but I like to have clean lines. You don't have to align them like this, it's just for me. I duplicate platform 6 and I set platform 7, the duplicate, to -5, -4 down here. Another duplicate to -6, -4, and another one at -4, -4. Next one will be at position around here, so I move it, so that will be -2, +2. Duplicate it, and this one is at position -1, +2, and one more at position 0, +2. Yes, I like how they are aligned in neat lines. As I said, you don't have to position them in the same way. Put your platforms wherever you want them. Design your own map if you want. There is always source code you can download with my Unity project that will have the platform placements exactly as you see here. The next platform will be at 0, -1. I will speed this up a bit. 0, -2, +1, -2. I duplicate it 7 more times. This one will be at +1, -1, +2, -1, +2, -2, 3, -2, 4, -2, 5, -2, 6, -2, and a few more up here around this area, I guess. So 5, 1, duplicate it, do 6, 1, and one more at 7, 1. Okay, we have a nice organized map layout with plenty of platforms. Players can strategize and choose where to place their towers. If I select the parent platforms object that contains all the platforms, and if I place it at 0, 0, it will be too far to the right side. I can just use the move tool and position my platforms exactly where I want them, all of them at the same time, like this. This looks good. I can collapse this to hide them. I might move them around a bit later as well. For now, this is good. Let's play. I have all these places now where I can place my towers. The projectiles are not that fast, so the platforms we choose can affect if the tower hits or misses the enemy because of the angles where the enemy is coming from towards the tower. We have so many features already, but I can just keep going. What should we implement next? How about 3 buttons that will make the game run at different speeds to allow players to fast forward through the easier waves and slow down during the more intense moments. It will also let the players match the game to their personal pacing. Some like to play with slow, careful planning, others prefer quick action. Our game can work with all of these kinds of players. Let me show you how. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I need a little bit of space in one of the corners for 3 UI buttons, so I will move these 2 platforms. Move this one to -3, -4, and this one, let's put it here at -2, -1. I want this corner empty for some more UI. I right-click UI Canvas, and I create an empty game object. I will call it Speed Buttons. I make sure Speed Buttons is nested under UI Canvas. I right-click Speed Buttons, and I go for UI Button TextMeshPro. I will call it Speed 1 Button. It will be 100 pixels wide and 100 pixels tall. I select this Speed Buttons container object, anchor presets, with Shift and Alt keys pressed. I select bottom left, That will move it down here. Button selected. It has a text element inside. I set it to a greater than sign for now. Text color will be black. Font size 50. I make sure the alignment is middle center here. I select this speed buttons container object. It's set to bottom left, but I set this to 0. Okay, let's do 50-50. Button selected. I copy and paste it 2 times. I make sure all 3 speed buttons are direct children of the speed buttons container. I rename this to speed 2 button. Its text will use 2 greater than symbols. And this one will be called speed 3 button. And the inner text will show 3 greater than signs. Right now, all 3 of these buttons are stacked on top of each other. So let's select the parent, speed buttons game object, and I add a component called horizontal layout group. Child alignment middle center, and spacing maybe 5 or 15. We will add functionality to them inside the UI controller script, where we handle most buttons and UI elements. We will need fields for the 3 buttons we just created. Type is button, and I call it speed 1 button. To be able to use button here, we need the Unity UI namespace. I duplicate it 2 more times, and this will be speed 2 button, and speed 3 button here. Down here, I create a method that will set game speed. It will take a float value for timescale as a parameter. We have this setTimeScale method that we are using to pause and unpause the game when the tower panel appears. So for now, this will be used for that, when the game needs to be paused because the UI needs it. For game speed buttons, I have to do it separately here. I can't set timescale directly from the speed buttons. I will show you why in a moment. So public void setGameSpeed. It takes a parameter of float type I call newSpeed. Game Manager will keep a private float value for game speed. By default, it will be 1, the normal speed. We also need to be able to access this game speed from other scripts as a read-only property, just to check what was the last game speed set up by one of the 3 speed buttons. Inside setGameSpeed, after we press one of the 3 speed buttons, we will set that private variable that keeps track of the current game speed to the new speed coming from the button. And then we will call setTimeScale, which will actually make the game run at that speed. Now to call this function back in UI controller, when we click one of the speed buttons, we call GameManager.instance.setGameSpeed, and we pass the timescale along. Up here, I create a start method. It runs only once in the beginning. I give the speed buttons an onClick event. This is a Unity event that triggers whenever the button is clicked. The addListener method registers a callback. This is a lambda expression, an anonymous function. This syntax means, when called, do what's inside the brackets. So this code says, when speed 1 button is clicked, call the setGameSpeed method with an argument of 0.2f. You might notice that usually I would just find the button inside Unity. I would find its onClick block there, and I would trigger setGameSpeed that way. We did it that way a few times in this course. But I want to pass setGameSpeed this argument of 0.2, defining how fast the game should run. That's why I'm doing it in code instead of inside the Unity inspector. In the inspector's onClick event, you can only assign functions with no parameters, or functions taking a single parameter of a type Unity can serialize, like a game object or a string. but you can't specify arbitrary numeric arguments like 0.2f directly in the inspector. Using code with a lambda like this lets us assign any arguments we like. So now that we understand what this line does and why we decided to do it this way, let's do the same thing for speed2 button, which will set game speed to 1, the normal speed, and speed3 button, which will set game speed to 2, double the normal speed. The first button with 0.2 will make the game run very slow, 1/5 of the normal speed. We can change these values later however we want. Maybe you want a button to make the game 4 times faster. You can just put 4 here as an argument and it's done. Let's make sure we assign speed buttons to these fields. Save that, and with UI Canvas selected, I will see them here. So I drag speed1 button to its field here, speed2 button here, and speed3 button here. If I play, the buttons already work. This one will make the game run at 1/5 of its normal speed, very slowly. This button is double the normal speed. Notice this behavior. I click the platform that showed the tower panel. Our game is paused, as expected. It was running at double speed, but when I select the tower, the game runs at normal speed. So our speed buttons work, but we know we have a small issue where selecting a tower sets the game speed back to normal. I want the game to remember what was the last speed selected by one of the 3 speed buttons, and when a tower is selected and the game unpauses, it returns to that speed. The issue is here, inside the hide tower panel method. When we close the panel, we set TimeScale to 1. That's why earlier we created this separate method called setGameSpeed. That first saves the preferred speed coming from one of the 3 buttons in a variable, and then it calls setTimeScale, which will actually make the game run at that speed. We are storing the game speed that the player wants based on their choice between the 3 speed buttons here on line 15, and we are exposing it as a public read-only property here on line 16. So here, when we hide the tower panel, instead of going back to speed 1, we will go to whatever is the last stored player-preferred speed, which we are exposing as a public read-only property under Game Manager instance game speed. I hope this makes sense. Let me know in the comments if you have any questions. I play to test this. Let's try the slowest game speed. And I open the tower panel, which will pause the game. When I select the tower and the game unpauses, we are still at the slow 0.2 speed. Perfect. As I said before, I assigned 0.2, 1, and 2 modifiers to these buttons, but you can go into the code and give them different modifiers. Maybe you want 1, 2, and 4 times the game speed. I'll leave it up to you. I'm just giving you this template and showing you how things work. How you actually design your game is up to you. I think some of you would also want to have the active speed button highlighted in a specific color as a confirmation, so we can see which speed the game is currently running at. Let's do it in a bit more robust way, where we define global button colors here, so that if we add other buttons later that need to be highlighted, we can reuse these colors there. I want to be able to see and modify these in the inspector for now, so serialize field, private color, normal button color is equal to color.white, which is not exactly what it seems. In Unity's UI system, the color property acts as a multiplicative tint, applied on top of the sprite's original pixels. For example, if you have a blue button and you set its color to color.white, Unity multiplies each pixel's RGB by 1, which leaves the sprite's original colors unchanged, so the button stays blue. This can be confusing at first. The important thing to remember is that setting a button's color to color white removes any tint, displaying the sprite's original appearance. To clarify, I'm not saying the normal button color is literally white. Rather, the normal state is untinted, showing the sprite exactly as it was created in its original colors. We will also define selected button color, maybe color blue, for example. Let's also recolor the text on the buttons. Normal text color is black. Any color multiplied by black will result in black. Selected text color will be color white again. So not white in the sense of plain white, but whatever color it was originally. I hope this makes sense. Let's create a private method I call, for example, updateButtonVisual. It will take two parameters, the button we want to style, and a boolean I call isSelected, which can be true or false. Let's write this line of code and then we explain it. Button image color is equal to isSelected, question mark, selected button color, colon, normal button color. Here I'm saying access the color of the button's image. If isSelected is true, set it to selected button color. Else, set it to normal button color. This syntax is called the ternary conditional operator. In this case, it's just a way to write an if-else statement on a single line. Expanded version would look like this, and it would work exactly the same. So ternary operator, because it has three operands, the condition to evaluate, if true, question mark, do this, else, colon, do this. At the same time, I also want to recolor the text of the button, which we know is a game object nested under the parent button. Let's access it directly here to make this easier. Type is tmp_text, and I will call it text. It's the button we are updating. And I want to find that child text game object and its tmp_text component. So text is equal to button.getComponent in children, and type is tmp_text. If there is an element we can find there, if it's not null, we take it and set its text color, again depending on if the button is selected or not. If it's selected, we use selected text color. If it's not selected, we use normal text color. So this helper method is setting the button and text color between selected and normal. Every time we select any of the three speed buttons, we have to run this method for all three of them, setting one of them to selected colors and the other two to normal colors. We will handle that logic here inside a method I call highlightSelectedSpeedButton. It will take a float parameter for selected speed. Let's write this line and then I'll explain it. So I call updateButtonVisual. As the first parameter, we pass the button, speed1 button, and as isSelected true or false, we do an expression to evaluate if selected speed is equal to 0.2f. This might be a bit strange, so let's do it for all three buttons and then I'll explain how it works. Right, so every time we call highlightSelectedSpeedButton, we will always call updateButtonVisual for all three buttons we have. We pass each button as the first parameter, speed1 button, speed2 button, speed3 button. And as the boolean is selected, we check if the speed that was selected matches the speed associated with this button. Only one of them will match and be selected. For example, let's say we selected a speed of 0.2. Then selected speed equal to 0.2 will be true, which means speed1 button will be colored in selected button color and selected text color. And the other two will be false, because the selected speed won't match those values. So the remaining two will be colored in normal button color and normal text color. I like this shorthand syntax, I think it's pretty clean. The only thing to keep in mind is I'm hard-coding 0.2, 1, and 2 here. So if I ever decide to change the speeds associated with my buttons, I have to change these values here and the values up above so they match. Otherwise, none of the buttons will get highlighted because none of them will match. Does it make sense? Let's talk about it in the comments if you want. Okay, yes, so finally, every time we click one of the speed buttons, we need to run this highlightSelectedSpeedButton method to color our buttons. Notice it takes selected speed as a parameter, so here, when I call it, I pass it along time scale, which will be either 0.2, 1, or 2. It will all work nicely together. Maybe we could put these three values into variables later. For now, let's see if it works. Keep in mind that clicking these buttons will call setGameSpeed, and it will carry with it this value. That timescale value will then be passed along as an argument to highlightSelectedSpeedButton, and if that value matches one of these three buttons, that button will be highlighted, and the other buttons will be set to their normal colors. That was pretty intense. Let's see if it works. I play. And let's go to the fastest. Slow it down, speed it up, And normal speed. Yes. Buttons and text inside change colors exactly as we need. What if I want one of the buttons to be automatically selected even as the game first starts? I can just go here inside Start method. I call highlight selected speed button and I pass it the current game speed from the read-only property we defined on Game Manager instance. Like this. Now if I save and play, the normal speed button is immediately highlighted when we start the game. We're doing some cool stuff with UI, and this is only placeholder assets. It will look even better when we use a proper asset pack. Maybe I should resize the tower panel now that we added these new buttons. I make sure I'm not in the play mode and I set tower panel to active here. I reduce height to 700 pixels. Cards container selected, and I set the vertical position to 0. Title text selected, anchor presets, I hold down Shift and Alt, and I set it to top center. Vertical position maybe 50. I set font size to 75. Vertical position 30. I'm not sure about this yet. Tower panel can now go a little bit up so it doesn't overlap with speed buttons. 0 here. What does this look like? Close button selected and I do 75, 75, like this. Let's put the title text inside, -20 maybe. And I move cards container a bit down as well, -20 or -50. Yes, this looks better. I hide tower panel again and I play. When I open tower panel, we can see the new layout and the panel is a bit smaller, so there is some space between it and the speed buttons. This looks pretty good. I can now play my game at double speed, which might be useful at some point. Awesome. Let's also add a pause panel, and on it we give the player some options to restart or quit the game. This will be much easier than what we just did. Unity handles most of this automatically or with just one line of code. I right-click UI Canvas and I go for UI Panel. And I call it Pause Panel. I make sure Pause Panel is nested under UI Canvas. Anchor presets with Shift and Alt. I select Center Middle. I think I want the Pause Panel to look the same as the Tower Panel, so width is 1400 pixels and height is 700. Color will be black and alpha set to 250, so a little bit transparent. Sorry, I think you can't see this panel fully. I right-click Pause Panel and I select UI Text TextMeshPro. I call it Title. The text will say Paused. Font size 100. Anchor top center. Width 600. Height 100, alignment center middle, and -20 vertical position here. On the deactivated tower panel, I select Close button, I copy it, I select Pause Panel, and I paste it to create a duplicate. I make sure it's nested under Pause Panel, like this. Okay, so we have a pause panel that looks the same as the tower panel. Close button selected, on-click block down here. For now, I will set no function. We will get back to this. Now I want to have a way to show and hide the pause panel, to pause and unpause the game. I right-click UI Canvas and I select UI button TextMeshPro. I will call it Pause Button. It will be 100 × 100 pixels. Anchor presets, Shift Alt, bottom right corner, and position will be -50, 50. The text inside selected, and text input for now just 2 vertical bars, which roughly looks like the standard pause symbol. Just a placeholder. Color will be black, font size 50, alignment center middle here, and maybe let's make it bold. Okay, so when we click this button, Pause Panel will show. I expand Path 1 and this Waypoint object. I will move it slightly to the left, not too far, maybe 7 horizontally here, and the waypoint below also 7. This is just to make sure enemies don't walk under the new pause button. Okay, this looks good. As always, we start by creating a new field inside UI controller. Type will be GameObject, and I call it pause panel. GameObject type because I want to show and hide the whole thing. And another field, type is button, and I call it pause button. Save that. On UI canvas, I see the new fields here. I drag pause panel here and pause button into this field. Actually, I would need a reference to the pause button if I was planning to assign onClick event to it in code. I can do it in the same way we did it for the speed buttons here, but actually I will delete this. We will assign it inside the Unity inspector, it's easier. Okay, so I have a field only for pause panel here. I will create a custom method I call togglePause. It will need a helper flag, private bool I call isGamePaused. Initially, I set it to false. When we call togglePause, if isGamePaused is true, we deactivate the pause panel to hide it. Else, we take pause panel and activate it. Save that. Pause button selected here, on-click here, and I click plus. Drag UI canvas here, and from its UI controller script, we want to call togglePause. But it's not here, and that's because I set it to private in my script. Let's set it to public. Save that. UI canvas here, and here UI controller.togglePause. And also on close button, UI canvas here, and when click, we want to run UI controller togglePause. Close button is only visible if pause panel is visible, so it will always just hide the pause panel. Back in my script, when we hide the pause panel, we set isGamePaused to false. When we show the panel, we set isGamePaused to true. Save that. I deactivate pause panel here, and I enter play mode. I click this pause button to show pause panel. I click the close button to close pause panel, and I can also click the pause button repeatedly, and it will toggle pause panel on and off. It works perfectly. I exit play mode. Now I want to show and hide pause panel also when we press a key on the keyboard. We will use the new input system we used before for detecting mouse clicks, so it will be inside the update method. And I say if keyboard. This will work if we have the new Unity Engine input system namespace up here. Checking if a key was pressed with the new input system is easy if you just want to react to a single immediate key press without needing complex input management. So here I check if the escape key was pressed on the keyboard, and if it was, we call togglePause. Save that and let's play. I press escape and I click the close button. I click the pause button and I press escape to close it. Perfect. We also want the game to freeze when we pause. We already have a system for that, so here, when we unpause, I can just say GameManager.instance set TimeScale, and I set it to the last player-specified game speed, like this. And when we pause, we set TimeScale to 0. Save and play. When I pause, the game freezes. When I unpause, the game resumes. But there is an issue. I open the tower panel, which also pauses the game, and when I press escape, we have pause panel overlaid over tower panel. I want to prevent this situation from happening. When tower panel is visible, we will not allow pause panel to appear for now. We might rework this later. Let's see. Inside togglePause, If tower panel is active, return and don't run the rest of this code. Don't pause the game. Let's clean this indentation. Okay. Save that and I play. I click one of the platforms to open tower panel, and now if I press escape, there will be no pause screen. We have a pretty nice game already, don't we? While tower panel is not active, I can pause the game by clicking this pause button or by pressing escape. When tower panel is open, clicking the pause button does nothing. I might change how this works later. Maybe open and pause panel could also close tower panel instead. That might be even better. For now, let's leave it like this. Or if you are confident in what you learned today, why don't you try to implement that functionality yourself and tell me in the comments how you did it. We have a pause panel. I want to put some buttons on it, a little menu that will give the player an option to restart and quit the game. I right-click pause panel and I select Create Empty. I will call it Button Group. This will be a simple wrapper that will help us keep the buttons aligned and evenly spaced out. I right-click it and I go for UI, Button, TextMeshPro. I will call it just Button. I set it to 350 by 100 pixels. Inside Assets Art, I have my Pixel UI sprite, so I expand it and I drag one of these rectangle outlines into the source image field on the button. It has a text element inside, so I select it. Font color white. Font size 35. Maybe set the height to 80 to make sure we can squeeze all of them here. We will need 4. Down here inside the button component, I can define how the button visually responds when the user interacts with it. I set it to color tint. We can define the colors for what happens to the button's appearance during different interaction states. Normal color is when the button is idle. Highlighted color is when the user hovers or navigates over the button. I will choose some colors here, but you can pick any colors you want. It doesn't really matter at this point. We can change them later to match our game art, depending on which asset pack we decide to use. Pressed color is when the button is clicked or tapped. Selected color is when the button is selected via keyboard or controller navigation, and disabled color is when the button is not interactable. If I play and I hover over the button, if I select and unselect it, you can see it changes colors based on those state changes. I exit play mode. I don't want to have to set up each button individually, one by one like this. Let's turn this one into a reusable prefab. Inside Assets Prefabs, I create a folder I call UI. I drag the tower card prefab inside, and I will drag the button we created inside as well, turning it into a prefab. Now it's turned blue, and I can delete it from the scene. I can now duplicate it as many times as I want, and they will all be set up in the same way. I drag and drop it over button group to make sure it's nested under it. I do it 3 more times, so I have 4 buttons. Currently all of them overlapping each other. With button group selected, I add component, vertical layout group, anchor presets, Shift and Alt, and I go for center middle. I add one more component called Content Size Fitter. It will make the element resize automatically based on the size of the child elements. So in this case, it will make button group resize to wrap around all the buttons. I make sure it adjusts its vertical and also its horizontal size. Since we already gave it a center middle anchor point, it will center the entire group of buttons in the middle of the screen. Let's give them some spacing, maybe 20. Alright. Button group selected, and I set vertical position to -50. Okay, I'm happy with the layout. I rename the first one to Resume Button. Its nested text component will say Resume. I select Resume Button again, and I go down here to OnClick, and I click plus. Resume Button will close the panel. It will unpause the game, so I put UI Canvas here. And on its UI controller component, I want to run toggle pause. The second button now, I rename it to Restart Level Button. Its text element here will say Restart Level. The third button will be called Main Menu button. Its text will say Main Menu. The fourth button will be Quit Game button. Its text will say Quit Game. So this will be our pause menu. We can do many things here, as you can see. By default, pause panel is hidden. I play, I pause the game, and all the buttons have their hover animations changing colors. Right now I can't click any buttons, but I also clicked the platform under the panel and it opened Tower panel underneath. That is an easy fix. I exit play mode. Let's open platform script. I want to make sure we can't click platforms when the game is paused. So let's add an OR operator here. If Tower panel is open, or if Time.timeScale is 0 for any other reason, like for example when pause panel is active, we will return early and we will not be detecting any platform clicks. Save and play. When Tower panel is open, I can't pause the game and show the pause panel. Good. Close that and escape to pause the game. When the game is paused, timescale is 0 and I can click buttons, but if I click any of these platforms in the background, they are not triggering Tower panel. Perfect. I exit play mode and I make pause panel visible. We want to create a function to restart the level and to quit the game. These are very easy. Inside UI controller, I create a public method I call restart level. First, I set timescale back to 1 because the game is most likely paused when this code runs. And then we will use scene management. We will need to be using Unity Engine scene management namespace up here. I create a variable, type is scene, and I call it current scene. I simply want to reload the current scene we have open in Unity, which will restart the level. We get the current active scene using scene manager getActiveScene. And then we call scene manager load scene, which can take either the name of the scene or an integer of that scene's build index. We will cover that a bit later when we build a playable version of the game. To restart the game, to reload the current scene, we call load scene and we pass it the current scene.buildIndex, like this. Restart level button selected, on-click block here, and plus. I drag UI canvas here, and on its UI controller component, I find the public restart level method we just wrote. I deactivate the pause panel, and I will play to test it. Okay, so let's speed up and play some towers. I pause the game, and if I click resume, we unpause. And if I pause again, and I restart the level, everything restarts to the default original state. I place a few towers and restart again. Yes, this works. Quit game is even easier. I create a public function I call quit game. And inside I say application.quit. And that's it. This will not do anything inside the Unity editor, but when we create a playable build, this will quit the application. If I wanted to quit the play mode in the Unity editor here as well, I can do this syntax. If we are in Unity editor, call unityeditor.editApplication.isPlayIn and set it to false. This will exit play mode. Else, meaning we are not in the editor, we are in a playable build, call application quit, and I end if like this. Sometimes this syntax can cause issues and we don't really need to quit game in the editor, but let's see if it works for me. I save that, quit game button selected, and here in onClick, I click plus, I drag and drop UI canvas in here, and when we click quit game button, I want to run UI controller quit game like this. I enter play mode, pause game, and quit game will exit play mode in the editor. That works. Play again, pause game, and quit game will exit play mode. We have one more button for main menu here. We will handle that next. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Main menu will be a separate scene. Let's learn how to transition between different scenes in Unity. I go to Assets Scenes folder. So far, we have only the main game scene here. I right-click Create Scene, like this. I rename it to Main Menu. I double-click it to open it. You can see the hierarchy is empty. All those game objects we created exist only in the game scene. We can still reuse things from the other scene. We don't have to build everything from scratch here, but let's start simple. I right-click here in the empty space. I go to UI, Text, TextMeshPro. You can see it automatically created canvas, because UI elements in Unity only function properly when placed under a canvas. Without a canvas as their parent, they won't render or behave as expected in the UI system. They need to be inside the canvas to be visible on screen. You can see that Unity also automatically created Event System, which is a core part of Unity's UI. It handles interactivity with mouse clicks, keyboard navigation, and so on. I rename the text to Title, and let's call our game, for example, Tower Defenders, for now. We know that canvas is huge by default, but in game view, it still overlays the visible game area and it scales. You can see this tower word is very small down here. We can work with canvas like this, but I prefer to shrink it. I rename it to Main Menu Canvas. I set its render mode to Screen Space Camera, and I drag Main Camera into this new Render Camera field. Doing this will make sure that the canvas size matches the size of the assigned camera's viewport. I prefer to work with UI elements like this. Title selected, Anchor presets, Shift and Alt, and I will use middle stretch settings. Font size 150, alignment center middle. Down here I add component, content size fitter. I set horizontal and vertical fit to preferred size, which means it will wrap around the text, adjusting to its size. The content size fitter tells Unity to automatically resize the rect transform of the text element to match the text content's preferred size. That's our simple provisional game title. I right-click Main Menu Canvas and I create empty. We need a wrapper for the buttons to keep them aligned. I will call it Button Group. Project assets like these prefabs exist across the scenes. They can be added and reused anywhere. So let's grab Button Prefab and parent it under Button Group, like this. And we will need one more. 2 buttons should be enough for now. Button Group selected, add component, content size fitter, and horizontal and vertical fit is preferred size again. Add one more component, vertical layout group, child alignment middle center, spacing 50. I right-click Main Menu Canvas and let's create one more empty game object. I will call it UI Container. I make sure it's nested under Main Menu Canvas, and Title and Button Group will be its children, like this. UI Container selected. I add component, vertical layout group, child alignment is middle center, spacing 100. Add component, content size fitter, and I make sure I set these to preferred size, which will automatically set its width and height to fit all the elements it contains. Now that it has the correct width and height, it will also go into middle center of the screen. Maybe I move it 50 pixels up, like this. This is a very simple main menu, but we can add art assets, animations, or whatever we want. I rename the first button to New Game Button. The second one to Quit Game Button. Text inside here will say New Game. and here it will say quit game. If I enter play mode, you can see that our buttons that come from a prefab already have the basic set of animations. Inside Assets Scripts, I create a new MonoBehavior script. I will call it Main Menu Controller. I attach it as a component to UI container and I open the script. Here I want to have a public method called StartNewGame. It's public because I will attach it to buttons onClick event inside the Unity inspector. Inside, we will use Scene Manager, so I will need Unity Engine Scene Management namespace. I call Load Scene, and here I can give it scene's build index, or I can pass it a string with the name of the scene. New game will load the game scene, like this. I have to make sure this word game is spelled exactly as we named the scene we want to load inside Assets Scenes folder. So Start New Game is easy. Just load the game scene. Quit game is also easy. Public void quit game method, and inside I run application quit. We know this will only work inside a playable build. It will not quit the game inside Unity editor. I save that, and I will actually put that script on a different game object. UI container selected here, and I remove main menu controller from here. Instead, I will add it as a component on main menu canvas. On New Game button, down here, inside onClick, I go plus, main menu canvas in here, and main menu controller, and Start New Game. Quit Game button here, onClick plus, main menu canvas goes here, main menu controller script, and quit game method. If I save and play, clicking New Game will load the game scene, and this is how we can travel between scenes in Unity. Pretty useful for so many things. Now I want to be able to click this main menu button and load the main menu scene from here. I save changes to main menu scene, and I go back to game scene. I go to File, Build Settings, and Scene List here. If I want to load a scene with code, like we just did, that scene has to be here in the scene list. I can simply drag it in, and I put main menu first and game second. You can see they have build index 0 and 1. We can use names of the scenes or their build indexes to load them. Okay, so when we click this main menu button, I want to load this main menu scene. We already know how to do that. UI controller script, let's go all the way down, and I create public void go to main menu method. My auto indentation is getting confused by this syntax, so let's delete all this code. We don't need the quit game button to exit play mode. I will keep it simple, like this. This will quit the game when we create a playable build. When I go to main menu, it will most likely be when the game is paused. So first, we set time scale to 1. Then I take Scene Manager and load scene main menu. Save that. Main menu button selected, plus. UI canvas goes here. And we call UI controller script and its go to main menu method. I play. Escape to pause the game. I click main menu button and main menu scene is loaded. I click new game and game scene is loaded. I can go back and forth between game scene and main menu scene. In a similar way, you can create individual levels, one scene per level, load in the next level scene when we complete a win condition, for example after we survived 20 enemy waves or something like that. I want to create a game over scene. Inside enemy script, we have this onEnemyReached method. If enemy manages to reach the end of the path before towers destroy it, players will lose a life. Inside Game Manager, we are dealing with that here inside Handle Enemy Reached End. We reduce player lives based on the incoming enemy damage, and we invoke onLives Changed event, carrying with it the updated lives value. UI controller reacts to that by running its update lives text method, which takes that reduce lives value and it updates lives text display. In here, I will check if current lives are less than 0. If so, we will run showGameOver method. I will comment it out just for a moment, and I will save and go back to Unity. I right-click Canvas, UI, Panel. GameOver panel will look a little bit different than Pause panel. It will be full screen. I set the color to black and alpha to 250, only a little bit of transparency. I go here to Pause panel, I hold down Ctrl and select title and the entire button group, and I copy it. This new panel selected, I paste title and button group, making sure they are nested under it as its child objects, like this. I rename the panel to GameOver panel. Title will say Game Over. In the button group that we copied from Pause panel, I delete the Resume button. After Game Over, we will have options to restart the level, go to main menu, or quit the game. We copied these buttons, so they are already fully set up and working. I will deactivate Game Over panel. It will be hidden initially. Inside UI controller script, I need a field for Game Over panel, as usual. You probably already know how to do this. Save that. I see the new field here on UI Canvas, and I drag Game Over panel in. Back to UI controller script. And down here, I can define my private showGameOver method. First, we make sure the game runs at normal speed. And I take GameOver panel and set active true to show it. Now I can uncomment showGameOver here to call it when the current play lives drop below 0. Save that and let's play. We have 5 lives. So when we allow enemies to reach the end, we will get a game over. I exit play mode. Actually, let's set timescale to 0 when game over happens. I go to Assets Prefabs and I will hide the Waypoint sprites by disabling their sprite renderer component here. Let's play. Again, I speed it up. Enemies still follow the path, but the waypoints are hidden. When the enemies reach the end and the player loses all 5 lives, we get a game over screen and the game freezes. Timescale is set to 0. I can go to the main menu by clicking this button. I can start a new game like this. We have all the key features in place. We can just expand on this further, give it nice graphics, and try to follow the same coding patterns we introduced so far to keep our codebase consistent. Maybe you've already put in some background artwork with a nice game world at this point. I'm keeping it generic still at this stage. Let's learn how to create a playable build. Unity makes it very easy to package your game into a standalone, runnable version that can be distributed and executed outside the Unity editor. It is able to generate files needed to upload your game to Steam, App Store, and so on. Sometimes builds can also reveal platform-specific issues and bottlenecks not visible in the editor. We will encounter one and learn how to fix it. If I go to File, Build Profiles, we make sure all our scenes are here in the scene list. If some are missing, you can just drag and drop them here. As you can see here, Unity supports building for a wide range of platforms, including desktop, mobile, web, consoles, and even extended reality. I'm working on a Windows machine right now, and you can see my Windows build profile is active. If I wanted to build a web game playable in a browser, I would select Web here and click Switch Platform. Console development like PlayStation or Nintendo might require a special Unity license or a registration as a developer with the platform holder. So let's start with something simple. This is a beginner class. If you are on a Mac, make sure you install the Mac build module, and then you'll be able to see the Switch Platform button here and build your game for Mac. I will create a playable Windows build. I click Build, and I navigate to an empty folder somewhere on my computer where I want to create the necessary files. It should be a different folder than where your Unity project is. Let's keep the builds separate. Create your folder, go inside, and click Select Folder. This will trigger a compilation process, but almost immediately I get a bug. And to make things even more challenging, my console will show the bug only for a second, and then it will clear. We can change settings in the console to uncheck Clear on Play or Clear on Build, or we can also check a persistent log file that Unity keeps on your system. In there, the error message during the build process, if an error happens, will guide you to the problematic script file. It's usually a script or a library issue. In our case, the issue is here inside the path script file that we wrote all the way in the beginning. I will wrap this line in a special syntax. This means only include using Unity Editor if the script is being compiled inside the Unity Editor, and exclude it for builds for other platforms like Windows or Mac or WebGL. I will do the same thing here. This code will not be executed if we are not compiling it inside Unity Editor. We use this to display helper labels above waypoints. It is not meant to be visible in the final game. Handles is an editor-only API. It's not available in runtime builds, and that's why I'm getting an error when creating a Windows build. Now it will be excluded, so I save that. I go to File, Build Profiles. I make sure my build is active. All scenes are in the scene list. And I go to Build again. I select the folder where I want to create all the necessary files, and I wait for the process to finish. This can take some time depending on the size of the project and the processing power of your computer. When it's done, I have a folder with my playable Windows build. When I click this exe file, my game opens as a full-screen playable standalone application. We can choose towers to place. We are destroying enemies and gaining resources to buy more towers. We have a pretty good game here. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. When you click a platform, you can place a tower. But look what happens when I click the same platform again. I get to choose another tower, and I can place multiple towers on the same platform. We want to prevent that. I can handle that in multiple places, but I think the easiest way to fix it is here inside the UI controller, inside Handle Tower Selected method. If you remember, when we place a tower, it becomes a nested child element of the platform it was placed on. So here, when Handle Tower Selected method runs, I say, if current platform.transform.child count is more than 0, we hide tower panel and we return, preventing the rest of the code in this function to run, which means place tower method will not run and no tower will be placed on the occupied platform. Save and play to test it. I place a tower. I click that same, now occupied platform, and I select another tower. The tower panel closes and no second tower was placed. I exit play mode. Let's use this no resources text to show all different kinds of warning messages, like in this case, to tell the player that the platform they chose already has a tower. I rename it to warning text. Inside UI controller, up here, I rename no resources text field to warning text. Down here, inside show no resources message, I replace no resources text with warning text in 2 places. And in these 2 places, I rename show no resources message to show warning message. Save that, and in Unity, the field lost the reference. I drag warning text game object into warning text field here. Now that the field is connected again, I want to use this show warning message method to send different warning messages to it. depending on situation. Show warning message will take a parameter, type is string, and I call it message. Now, when I call it here, it will need some value, so I pass it not enough resources as an argument, because this block runs if we are trying to place a tower, but we can't afford it. When we call this, we will take warning text.text and we set it to the message that is being passed to it. So for example, this not enough resources text. You can see I'm getting a compilation error here. It's because warning text needs to be a different type. Right now it's GameObject, but to be able to access its text component in the way I'm trying to, it needs to be TMP text. Save that. I'm trying to access this warning text GameObject and its text component here. Changing field type from GameObject to TMP text means that I have to access the GameObject here, like this, to be able to set active true and to false here, like this. Okay, so when we call show warning message, we always have to pass it some text we want to display. We set message value to the text field here, we show it, we wait for 3 seconds and we hide it. Save that. I make sure we have a reference to warning text and we haven't lost it because we changed the data type. All is good, so I enter play mode. I place a tower. Now I don't have enough resources to afford this tower that costs 100, so if I try to choose it, I get not enough resources warning. That still works. Exit play mode. I do lowercase r here. If you are trying to place a tower on a platform that already has a tower, we will also call show warning message like this, but I want to show a message that says this platform already has a tower. Save that and play. I place a tower here. I select the same platform that already has a tower, and I select another tower. Tower panel closes, and I get a warning message saying this platform already has a tower. Perfect. We have a simple warning message system. We can reuse this later for other kinds of warning or status messages. Maybe at the start of each level, I want to have a text that will appear for a limited time, showing the mission objective. Something like survive 20 waves to finish the level. Let's implement that. I right-click UI Canvas and I create a new text element. I make sure it's nested under UI Canvas and I rename it to Objective Text. The text field will say something like Objective Text as the default value. It doesn't really matter. Anchor presets and I set it to bottom center. Width will be 1100, height is 100. Alignment middle center, font size 80. Vertical position may be 50 to move it a bit up. By default, it will be disabled. Inside UI controller script, I define a new field for it. Type is TMP text. And I call it Objective Text. Save that. UI Canvas selected, and I drag Objective Text GameObject into this new field here. Let's say I want to run this every time a level starts or restarts. In our case, that means that a scene was loaded or reloaded. We can use onSceneLoaded method that runs after a new scene has fully finished loading. For that to run, we need to use Scene Manager here, which needs Unity Engine Scene Management namespace. And we subscribe to Scene Manager Scene Loaded, a static Unity event that fires after a new scene has finished loading. As a reaction to it, we will run our onSceneLoaded method. I also make sure I unsubscribe, as usual. You can see it's complaining about something, and that is because this onSceneLoaded method needs to be able to accept two parameters, scene, and load scene mode, mode. What scene was loaded, and how it was loaded. We don't need to use these for anything right now, but we need to include them here for Unity to allow us to subscribe to that static scene loaded event. Now that we included those parameters, you can see it accepts this line up here. so it will all work. Here we can put anything we want to happen every time a scene is loaded or reloaded. I want to show that objective text for a few seconds, so let's again use IEnumerator that we used to show the warning message for 3 seconds before. I will call it show objective. On scene loaded here, I will start coroutine and I pass it this show objective. Inside, we will wait 5 seconds, so yield, return, new, wait 4 seconds, 5f. But before that, I first set the message text to whatever I want to display. I will use string interpolation, a syntax that will allow us to include a variable inside this string to replace this XXX with a value from our data. Then we show the objective text like this. We wait for 5 seconds, and we hide it. Let's create some level data. Let's say each level will have a different win condition, a different number of waves the player has to survive to complete the mission. If I save and play, we will see this objective text appear for 5 seconds. I exit play mode. Inside Scriptable Objects, I create a new folder I call Level. We will follow the same pattern we did before for enemy data, tower data, and waves data. Inside, I right-click and I go to Create, Scripting, Scriptable Object Script. I call it Level Data, and I open it. Here I have to think, what kind of data do we want to define for each game level? We will need public string level name. This has to match a scene name. We will use this value to load next level. Each level will also have integer waves to win, how many enemy waves the player has to survive to complete the mission. Maybe we also want each level to have different starting resources. This value will affect how many towers we can place in the beginning of the level. Tweaking it can make the level much easier or harder to beat. We also might want to set different starting lives for the player for each level. How many enemies can reach the end of the path before we get a game over? We can do so many other things here. For example, each level can have different background music and so on. We can really put a lot in here, but let's comment this out and focus on the 4 main fields for now and learn how to actually connect them to our game logic. Save that. We have a blueprint for level data, so if I go inside this folder and I right-click, I can go to Create, Scriptable Objects, Level Data, and I create a data file for level 1. Level name will be level 1 here. Waves to win is 2, just for testing. Starting resources 180. Starting lives 5. OK, I right-click again, and I create level data for level 2. Level name is level 2. 5 waves to win, 300 starting resources, and 3 starting lives. Doing this allows us to set up each level with different starting properties. Let's just focus on level 1 data file here. We can do the next part inside Game Manager, but I will actually separate the logic into Level Manager to keep it cleaner. I create a new blank game object and I call it Level Manager. I reset its transform here. Inside the scripts folder, I create a new MonoBehavior script. I attach Level Manager script as a component to Level Manager game object. I open it in my code editor. I will give it a public static instance to make it easily available to other scripts in the scene. As always with singleton, I have to check if this is the only instance. And if I find a duplicate, I destroy it. Otherwise, set this to the instance. This makes sure we always have only one Level Manager instance. Level Manager will have a public level data array I call all levels. It's an array holding data files for all levels we have inside the game. Level Manager will also keep track of which one of these data assets is the currently active level, and we set this to a public read-only property. If I save that, I select Level Manager and I see all the levels array here. From Scriptable Objects Level folder, I drag Level 1 data file and Level 2 data file into the array. Back in the script, all the levels array here contains data for all the levels we created, and inside awake, we set current level to all levels at index 0. When Level Manager is first loaded, we set the current level to level 1, basically, the first element in all levels array. So the job of Level Manager is to keep track of all levels and to always be aware which one of them is the current level. We can also use it to load levels later if we decide to build more. So far we've only built one map here. If I check my data file for level 1, I have all these values in here, and because we put this into level data array and we're setting current level to the first index in that array, at this moment current level property is pointing to this data file, and from it we can access all these values when we need them. We turned Level Manager into a public static instance, and current level is a public property, so I can now access this level data from other scripts. For example, let's access this waves to wind value that we set to 2. We need it here inside show objective on UI controller. I can put a dynamic variable into this string like this. I want to access levelManager.instance and its current level property, which currently points to this data file. And that's why I can access waves to win. If I save and play, let's see if it shows number 2. It does. I exit play mode. To be absolutely sure, I put a different value in the data, 1540. And yes, it says survive 1540 waves. I exit play mode and I set this to 3. We have this level data available all over our codebase. Wherever in this scene, we might need it. So let's now make sure when we start the level, we get 180 starting resources and 5 starting lives, or whatever value we put inside this data. We can do that inside Game Manager script. I will create a public method I call resetGameState. Inside, I set lives to Level Manager, instance, current level, starting lives. Save that. Let's just open level 1 data file so I can see it side by side. Okay, so I'm setting lives to starting lives from the data here. We know that whenever lives value changes, we want to update the UI display as well to show the current lives value to the player. We do that by invoking onLivesChanged event that UI controller is listening to, and it will update lives text based on the lives value we broadcast here. We will do the same thing with resources. We set resources to Level Manager instance current level starting resources, so from the data coming from here. And we will invoke onResourcesChanged so that UI controller can update UI. We will also set game speed to 1. In case we are resetting the game from the game over screen, where the Time.timeScale is set to 0. I want this method to run when a scene is loaded, so we will do the same thing we already did. I take Scene Manager. I make sure I'm using Unity Engine Scene Management namespace. We will subscribe to SceneLoaded event with onSceneLoaded method that we haven't written yet. And we also remember to unsubscribe. Let's define private void onSceneLoaded here. For it to work, we need to make sure it expects these parameters, scene, and load scene mode, even though we don't need them for anything right now. When the scene is loaded, we run resetGameState that sets lives and resources to the values from level data, and it sets game speed to 1, the normal speed. Alright, with level 1 data asset selected, I set starting lives to 700 and starting resources to 10,000, just to see if the values are coming through. I play, and we have 700 lives and 10,000 resources. Perfect. I exit play mode. I set this maybe to 300 and this to 8 for now. Next, we will need a mission complete panel, When we survive the number of waves specified in the data, we will get a mission complete, where we can go to the next level. And maybe we will also do endless mode to see how many waves we can beat. Mission complete panel will look very similar to game over panel, so I select game over panel here and I copy and paste it to create a duplicate. I rename the duplicate to mission complete panel and I make sure it's nested under UI canvas, otherwise it won't render for us. I enable it to make it visible, and inside mission complete panel and its title object, I set the text to mission complete. I increase the width to 1100 pixels and the vertical position will be maybe -180. Yes. Okay, initially it will be hidden, so I disable it here. Now we want to show and hide mission complete panel with code, so we will need a field for it inside UI controller. Game object I call mission complete panel. Save that. And on UI canvas, I set the new field here, so I drag mission complete panel inside. We will have a private function I call show mission complete. Save that. And I open spawner script because this is where we handle enemy waves. We will give it a new event. I will call it onMissionComplete. It will not carry any value with it. It will be simple, like this. This wave spawning logic is a little bit complicated in this part. Not sure if you remember when we wrote this, but basically, whenever we are about to go to the next wave, before we actually increase wave counter, we will check if wave counter +1, the upcoming wave, is greater than or equal to waves to win, coming from level manager, instance, current level, from our current level data. So, if we already defeated enough waves to pass this waves to win check, we can complete the mission. I make spawner script invoke this onMissionComplete event. And after that I return, so we are no longer increasing waves further. If we defeated enough waves, none of this code will run after that. Spawner is invoking onMissionComplete event, so inside UI controller we will subscribe to it, and we will react to it by running showMissionComplete method. And here we also unsubscribe. When showMissionComplete method runs, we take MissionComplete panel and we activate it. We take Game Manager and we set Time.timeScale to 0 to freeze the game. Save that. And here inside level 1 data, I set waves to win to 1, just for testing. After we defeat one wave, we should get MissionComplete panel. I play. Let's make sure we destroy all enemies. And we have mission complete. Nice. We have the option to restart the game, go to main menu, or to quit the game. I restart, and it works. Great. I exit play mode. I make mission complete screen visible, and I want to add 2 more buttons here. One for the next level, and one for endless mode. I go to Assets, Prefabs, UI folder. We have this button group inside Mission Complete panel. I take button prefab and I drag and drop it over the button group. And I drag one more. I make sure both of them are nested under button group game object. I select the first one, I rename it to next level button, and down here inside its button component, I unchecked interactable. Right now the button will be here, but it will be disabled. We are not doing multiple levels yet. The text inside will say next level. I drag the button to the top to make sure it's the first option. Okay, so we have a non-interactable next level button. The second button, I rename it to endless mode button. The text will say endless mode. When we enable it, the idea is that we can just continue the level and play as long as we can survive against the endlessly more and more difficult enemy waves. We already implemented logic earlier that increases enemy health with each wave. So when mission complete screen appears, we have these 5 buttons to click. I open spawner script. In this code block, we are preventing waves counter from increasing if we've reached the waves to win limit. But when we decide to enter endless mode, we want to keep moving past that point, so we will only run this block and return if isEndlessMode is false. Exclamation mark means false. We haven't defined that variable yet, so I go up here and I define a private bool I call isEndlessMode. And initially I set it to false. If isEndlessMode is true, we will keep increasing waves even past waves to win limit. Down here, let's define a public enableEndlessMode method. When called, it will switch this flag isEndlessMode to true, allowing spawner to keep spawning more and more waves because of this logic we wrote here on line 64. When we first complete the level, isEndlessMode is false, so onMissionComplete will be invoked and we will get mission complete screen. If we click the Endless Mode button, that click will set isEndlessMode to true, which means that level continues because this block will be skipped. So all we have to do now, if I want endless mode, is to make sure that isEndlessMode is set to true by calling the public enableEndlessMode method we just wrote inside spawner. To be able to call that method, I will turn spawner into a singleton, public static instance, like this. We did that before for Game Manager, for example. So I can actually copy this code inside awake method from Game Manager script, and I paste it down here. This code makes sure we only have one spawner instance. Okay, so we are all set up. To enable endless mode, all I have to do is to take this public static spawner instance, and from it I call enableEndlessMode method, which sets the isEndlessMode flag to true. Now, finally, I go to UI controller script, and down here I define a public enterEndlessMode method, and inside we hide mission complete panel. We set Time.timeScale to the last recorded player selected speed, like this. And I take that new spawner instance, and from it I call the public enableEndlessMode method we just wrote 2 minutes ago. Save that. On mission complete panel and its endless mode button. Down here inside its button components on click block, I click plus. We put UI canvas in here, and we call UI controller enter endless mode. That will do it. I select mission complete panel and I disable it. Inside Scriptable Objects level folder and level 1 data, I set waves to win to 2. Let's play to test it. I need to place some towers and defeat 2 waves of enemies to win. Okay, first wave down, second wave of dragons is coming, and when I destroy all of them, I get mission complete panel. Next level button is non-interactable, but I can click this endless mode button and we continue with the level. We kept all our towers, resources and lives, and we are on wave 3. We are in endless mode. Now the game will end only with a game over when we can't prevent enemies from reaching the end of the path and we lose all 8 lives. It might take a while because enemy scaling is pretty forgiving. So I exit play mode and we scale enemy health here on line 114 inside spawner script. Every time we move on to the next wave, we increase enemy health by 10%. Let's make it a bit more challenging. I will increase enemy health by 40% each time. Also, let's do one more thing. Here in level 1 data asset, I set level name to level 1. I go to assets scenes and I rename game scene to level 1, making sure it's spelled exactly like this. This can be used to load next levels if we decide to create a scene for level 2, level 3 and so on. By renaming the scene, we broke a few things, but it's an easy fix. I open Level Manager and I create a public load level method. This method will be able to reload the current level or load next levels if we create some. It will take one parameter, type is level data, and I call it level data. Whatever level data we pass to it, we load a scene with that name, basically. We set current level to that new level data we are loading here. Then we take Scene Manager, as always making sure we include Unity Engine Scene Management namespace, and we call load scene. We know it can be called in two ways, by passing it a scene name or by passing it a build index. That's why inside level data, under level name field, we make sure we put a value that exactly matches how we call the scene file. So we are loading by scene name here. I named the scene I want to load level 1. So the thing that is broken, if I open main menu scene and I play, I click new game, which will try to call the scene we renamed from game to level 1. So it will not load. I exit play mode, I open main menu controller, and here we are trying to load the scene by its old name. So instead of hard-coding that, I will use this public load level method we just wrote. I do it by taking level manager instance, load level, and if you remember, on level manager instance, we are keeping an array of all levels. And this is the start new game method. So we always want to load the first level in that list, the element with index 0. Okay, keep in mind we are inside main menu scene and I'm trying to do this by using level manager. I save that and I play. And now when I click new game, I get an error. Why is that? I exit play mode. The problem is that if you look here, there is no level manager game object, but I need it here to load that next scene. If I open level 1 scene, this is where level manager is. We turned it into a public static instance, but it still exists only in level 1 scene. Main menu scene doesn't have access to this level manager. I will copy level manager in this scene. I open main menu scene and I paste it here. That will fix it, but we don't really want to have copies in both scenes. Those copies are independent. In theory, I would have to make sure I always update both of them. This level manager is actually simple enough that we could do that, but a proper way is to have only one level manager game object that can jump between scenes instead of being destroyed. That way, I have just one level manager, but it's always available in every scene across our project. To do that, I go inside Awake. Here, if we detect a duplicate level manager, we destroy this duplicate. If this is the only level manager in the scene, we set it as the instance, and we make sure it's not destroyed when jumping between scenes. Don't destroy on load. And I pass it this level manager game object that I want to make sure is not destroyed. I save that. I make sure I save changes to all my scenes. Currently, I have 2 copies of level manager, one in main menu scene, one in level 1 scene. It will work because the one that is in the scene where we start playing will be marked as don't destroy on load, and when we enter the other scene, the duplicate will be destroyed because of the logic we wrote inside Awake. Having it in both scenes has an advantage that we can enter play mode from both scenes. If I enter play mode now and I open this don't destroy on load, we will see level manager here. Now I can click new game and level manager will load level 1 scene. As you can see, the main level manager survived here and the duplicate is gone. It was destroyed. I can restart the level, or I can go to main menu. Both of these things are loading a scene. Inside UI controller, I have restart level function here. It does 2 things. It sets Time.timeScale to 1 and gets the active scene and loads it. We don't really need to set timescale here because here, inside Game Manager, we have this onScene loaded. And every time a scene gets loaded, we already set game speed to 1, so restarting level reloads a scene. We don't need this line here. And I want to replace these 2 lines with our new way of loading levels using the ever-present level manager that will be available in all our scenes. And we call the load level method, and we pass it the level we want to load. When we restart level, we want to load the current level we are playing right now. We store that in the current level property, like this. Now if I play, I can still restart a level. I can increase game speed, place some towers, and restarting level resets the game speed to normal. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I open level 1 scene, and first let's do a quick cleanup. Manager's game object here. I reset its transform just to keep the numbers clean. This affected all the game objects nested under it, including the main camera, so I selected here and I set its position to 0, 0, minus 10. And now everything is visible again. Global Light 2D, I reset transform. Event System, reset transform. And Background, reset transform. We will be duplicating some parts of this scene to create level 2 and level 3, so this is the best time to clean everything up. I put UI Canvas down here and Game Manager as well. We already set up Level Manager as Don't Destroy on Load. I want to do the same thing for UI Canvas and Game Manager. I want these 3 important game objects to persist between scenes, especially with UI Canvas. We want to have just one. It would be a lot of work managing separate independent UI for each scene. We want to have just one UI that is shared for all scenes for a much simpler workflow. I delete Level Manager here. We will have just one that will come from the main menu scene and jump from scene to scene as we load them. I save changes to Level 1 scene. I copy Game Manager and UI Canvas. I open main menu scene and I paste them here. So now this simple main menu scene is going to serve as our bootstrap scene. As you can see, we have a bit of an issue with UI Canvas. I lost the camera reference, so with Screen Space Camera still selected here, I drag and drop main camera in here. I know it worked because in Scene View I can see all the UI elements. I save changes to main menu scene and open level 1 scene. I delete Game Manager and UI Canvas from this scene because we have them in main menu and they will come from there. I save that. Back to main menu scene. And I open Level Manager script. I also open Game Manager script. You can see we have a public static Game Manager instance here, and in Wake we make sure there's always only one. I'll do the same thing we did for Level Manager. I use Don't Destroy on Load to make sure this Game Manager game object is not destroyed and persists when we jump between scenes. Level Manager is also a public static instance, and we used Don't Destroy on Load here, so let's do the same thing for UI Controller as well. Singleton, I create a public static UI Controller instance. And I copy the entire awake method from Game Manager, and I paste it here. I make sure this game object is the only UI Controller instance in the scene, and mark it as Don't Destroy on Load, like this. So, UI Controller is a public static instance, and we used Don't Destroy on Load here. Level Manager is also an instance, and Don't Destroy on Load. And Game Manager, also an instance, and Don't Destroy on Load. I save that. From now on, for our game to work, we always have to enter play mode from main menu, because this scene will initiate these 3 game objects that we will need inside level 1 scene and other level scenes as well. I enter play mode. I ignore all the UI that should not be here. We'll fix that in a minute. When I click New Game, we load Scene 1. Notice the UI is not visible here. It's too large, but it renders correctly in game view at least. If I go to main menu, it loads, but the pause panel doesn't disappear. And again, we have a lot of UI that should not be visible in main menu scene. If I open the Don't Destroy on Load object, inside we have Game Manager, UI Canvas, and Level Manager. That's good. If I click New Game, these 3 objects didn't get destroyed. They persist between scenes. I exit play mode. So we have a few issues coming from the fact that now we have one persistent UI canvas that exists across all our scenes. It's easy to fix. Let's take it step by step. Inside UI controller, down here, I create a private method I call hideUI. There will be times in our game that we want to hide some UI elements, so let's turn that into a reusable block of code. We want to hide the wave counter, waveText.gameObject, and I set active to false. If I save that, we also want to hide resources text, lives text, speed buttons, and pause button. So let's do it. I hide lives text. I hide resources text. We also have that little warning text that tells us if we don't have enough resources to place a tower. I hide speed 1 button, speed 2 button, and speed 3 button as well. And I don't have a reference in my code to the pause button that sits on the bottom right corner, so I create it up here. Save that. On UI canvas, I have the new field for pause button here. And I drag pause button in like this. And now we can hide pause button here. I copy the entire method and paste it here. I rename the duplicate to show UI. I remove this warning text, we don't want to show that here. And now I set all of these to true. We have a method to hide UI and to show UI. I'll do a simple solution for now. Inside onSceneLoaded, if the scene we just loaded has a name of main menu, we call hideUI. If the scene that was loaded is anything else, we call showUI, because that will be level 1, level 2, or level 3 scene. And I also want to show the level objective text if we are not in main menu, so I put it here. So now we see all the UI here. But if I enter play mode, UI in main menu is hidden, and when I click New Game to load level 1 scene, we see all the UI text and buttons, but only in the game view. Why don't we also see them in the scene view? They are here, but they are huge. When we loaded the scene, the persistent UI canvas object lost the reference to main camera in this new scene. As you can see, the camera reference is missing. I exit play mode. Inside main menu scene, we have main camera here. There is one of these cameras in each scene. I never tried to set main camera as a persistent don't destroy on load object. It might work, but I will do another thing. We make sure UI canvas always finds main camera when a new scene is loaded. Notice that main camera has this automatic main camera tag, so we will use that to find it. UI controller script persists as we jump from scene to scene. Whenever we load a new scene, we create a temporary helper variable. Type is camera. I call it, for example, main camera. It will be equal to GameObject, find GameObject with tag main camera. It's a built-in method. You can see that tag here, and on it I want the camera component, so get component camera. Like this. Save that. On UI canvas, I want the canvas component, and I need to access its render camera field. Type is canvas, variable name canvas, for example. I get this canvas component. I will use world camera. This is the camera used by the canvas for rendering. For simplicity, think of it as accessing this render camera field and setting the main camera we found by its tag to this field. Save that. I always have to enter play mode through main menu scene from now on for everything to work. I enter play mode, UI canvas here, and it has a reference to main camera. When I click new game, even in the scene view, my UI is not huge anymore. It's sized correctly, and UI canvas still has that main camera reference. That worked. I exit play mode. Actually, I enter play mode again. We have another issue. Before, when we had UI canvas only as a scene object and it wasn't persistent, we counted on that scene reload to close panels when jumping between scenes. But now, This canvas is persistent, so those panels will stay open when I go to main menu from the pause screen, for example. Again, this is an easy fix. Inside UI controller script, I create a new utility method I call hide panels. Inside, we take pause panel and call setActive false. We do the same for game over panel and also for mission complete panel. Let's close all of them at once. And whenever we call hide UI, I also want to hide these 3 panels, so I call it here. But I also want to hide these 3 panels whenever we load a new scene or reload the current scene, so I call it here, like this. So as you can see, turning UI canvas into an object that persists across scenes created a few challenges, but we managed to fix it. I think we covered all the edge cases, but if something else comes up, we will come back to this. If I go to main menu from pause panel now, main menu is loaded and pause panel was closed. It works. In Game Manager script, inside onSceneLoaded, we currently call resetGameState, but we don't want to call it in main menu, because in main menu, Level Manager doesn't have any current level data to set lives and resources to. So we'll only call resetGameState if we have access to Level Manager instance, which we should always have, but mainly if current level is not null. If we actually have level data for the scene that was loaded. Level data such as starting resources, starting lives, and so on. Okay, so we do it like this. Inside Level Manager, I delete this line of code. We don't need it anymore. I save that. And when I play, everything seems to be working. Is there anything else that needs fixing? I think we're good. If something else comes up, we'll get back to this. If I open level 1, we really simplified it. We have only the most necessary things here. Each level will have its own path, defined by waypoints, its own enemy spawner, and a set of platforms where we can place towers. Let's copy and paste this simplified level 1 scene and rename the duplicate to level 2. Let's create a new level with a completely different layout and let's connect it with the rest of the game. I open level 2 scene. Currently, it's just a copy of level 1, so let's change it, starting with the background image. I have this background game object here. I go to Assets Art and I drag and drop my Path to image. You can download it with all the other project resources down below, or you can use your own image if you want. With the image selected, I set sprite mode to single, mesh type to full rect, and apply. With the background game object selected, I drag Path to image into its sprite field here. Level 2 will be just 2 caves connected by a straight line. Path is here. I select Spawner game object, Move tool, and I move spawner somewhere around here. Inside Assets Prefabs folder, I find Waypoint Prefab, and I enable its sprite renderer so that I can see the waypoints. I select the first waypoint, Move tool, and I move it somewhere around here. The next waypoint, Waypoint 1, will go here. Waypoint 2 will go all the way here, because this map has just this simple long path. Waypoint 3 goes here into the other cave, and that will be the end of the path. I select waypoints 4 to 12, and I delete all of them. This path for enemies is made out of only 4 waypoints. If I select the path game object, we still have them inside the waypoints array, but we have missing references in the field for the ones we deleted. Up here I set the length to 4 and confirm. Level 2 will have just this simple path. I can't fully play the game when I enter play mode from this scene because we are missing Level Manager, Game Manager and UI Canvas, which get only initialized from main menu scene, but it looks like the game still works partially, showing me how the enemies follow the new path. I exit play mode. I move the first platform to coordinates -5, 2. The next one, platform 1, will be -4, 2. Platform 2 is -3, 2. Platform 3 is -2, 2. Platform 4 is -1, 2. Platform 5 is 0, +2. Platform 6 is +1, +2. Platform 7 is 2, 2. Platform 8 is 3, 2. Platform 9 is 4, 2. Platform 10 is 5, 2. Platform 11, 6, 2. Platform 12, 7, 2. Platform 13, 0, 1. Platform 14, 1, 1. Platform 15, 2, 1. Platform 16, 3, 1. Platform 17, -6, -2. Let's put it somewhere below the track. Platform 18, -5, -2. Platform 19, -4, -2. Platform 20, -3, -2. Platform 21 is +1, -2. Platform 22 is +2, -2. Platform 23, 3, -2. Platform 24, 4, -2. Platform 25, 6, -2. Platform 26, 7, -2. Platform 27, 8, -2. Okay, so this is my level, a straight path between two caves with platforms on both sides. This will be a very different challenge compared to the winding roads of level 1. I can enter play mode from here, but we are missing level manager, game manager and UI canvas, so the game is not running properly. I exit play mode and I save changes to level 2 scene. I want to be able to load level 2 scene, so first I have to add it to the scene list. File, build profiles, scene list. And because I have the scene open, I can just click add open scenes. Or I can go to assets scenes and I drag level 2 scene in here. I make sure they come in this order. Inside UI controller, I create a public method I call load next level. It's public because we will attach it to the next level button in our UI. I will need level manager instance multiple times, so I will save it in a helper variable called level manager. Integer, I call current index, and I want to use array, so I will need the system namespace up here. Built-in indexOf method. And let's go here to main menu scene and level manager, just so we can see the all levels array side by side with our code for clarity. Let's write it and then explain what it means. Level manager all levels, and the second argument is level manager current level. So in this line, I want to get the current index of the scene that is currently loaded. Let's say we are in level 2 scene and we want to load the next level. Current index is the index of this current active level inside this all levels array. We have those variables here on level manager. We want to load the next level, so the next index in this array. We know what the index of the current scene is, so next index is current index +1. We check if there is another level available inside all levels array. If next index is less than level manager all levels length, length starts from 1, indexes start from 0. If there is another level available and we have a level to load, we first hide mission complete panel, because the next level can only be loaded when we completed the previous level. Do I need this line of code? Let's see later. Then we take level manager and call its public load level method we wrote earlier. And the level we want to load is that all levels at next index we calculated here. So, when load next level runs, we check what is the index of this currently active level inside all levels array. We know that next index is current index +1. If there is another level available inside all levels, we hide mission complete panel and we load the next level scene using the logic inside our custom load level method. Save that. In Unity, inside UI canvas, I have mission complete panel and it has a next level button here. I check interactable here to make sure it can be clicked. And inside its onClick block, I drag UI canvas here, and I want to run the public load next level method we just wrote. Okay, I hide mission complete panel. I need one more helper method that will enable or disable that next level button depending on whether we have another level to load or not. It will be private and I will call it update next level button. I will copy these 2 lines of code and I set next level button interactable to something, but first I need a field for it, so I comment this line out for a minute. Up here I create another button field. I will call it next level button. Save that. On UI Canvas I find the new field and I drag and drop next level button inside. Now we have a reference to the button so that we can access its interactable property with code down here. And I will set it equal to an expression. Let's just write it first and then explain it. Whether or not the button is interactable depends on whether this expression evaluates to true or false. If current index plus 1 is less than level manager all levels length, interactable will be true. If there are no more levels, if we are in the last level, this will be false, and next level button interactable will be set to false. Making sure if there is no more levels, we can't click next level button. It will still be there, but it will be disabled. And when do we call this? Whenever we show mission complete panel. So up here inside this method, like this. Save that. I go to Scriptable Objects level folder, and level 1 will have 1 wave to win actually, and 10 starting lives. Level 2 will have 2 waves to win, 500 starting resources, and 5 starting lives. I play level 1 scriptable object here and I check if the correct values are pulling through. Let's place some towers and win. I get mission complete panel and next level button can be interacted with, so if I click it, we load level 2. I check if all values are coming through and it seems good here. So let's defeat 2 waves to complete the level. The second wave of dragons is coming now. This level is much more difficult because enemies have only a short path to get to the exit. When I defeat all the dragons, I get mission complete, and next level button is non-interactable because we didn't build that third level yet. We have only level 1 and level 2 data inside all levels array. Time to create level 3. Inside Scriptable Objects level folder, I create a duplicate of level 2 data file, and I rename the copy to level 3. Level name is level 3, and I make sure I will name the scene exactly like this when I create it in a minute. Waves to win will be 3, just for testing. Starting resources 400, starting lives 3. So we have this data file for level 3. I go to Assets Scenes folder and I duplicate level 1 scene again. This time, I rename the duplicate to level 3. I open level 3 scene. We want to give it a different background image first. Again, you can download Path 3 image in the resources section below, or you can use your own image. I drag and drop it into Assets Art folder, Path 3 image selected, sprite mode is single, mesh type is full rect, and I apply. Background game object selected, and I drag Path 3 image into its sprite field, like this. This will be a round path around a pond, or maybe it's a lava lake. I will leave that to your imagination for now. Spawner game object, move tool, and I move it here. Path 1, I take the first waypoint and I move it here. The next waypoint, waypoint 1, will be here. Waypoint 2 goes here. Waypoint 3 in this corner. Waypoint 4 down here. Waypoint 5 continues to the left, and waypoint 6 to the end of the path. I place it here. I delete waypoints 7 to 12. Path 1 game object, waypoints array, and I set length to 7, and I press enter. And finally, like we did before, I have to move the platforms around the map to define where we allow the player to place towers. I will speed this part up. Feel free to distribute your platforms anywhere you want. No need to copy my layout. Make it your own if you want. I will just use Move tool to place them in a circle around the lake like this. And the rest will go down here, and 2 up here. Let's play just to see the enemies travel around. The game will not work fully without our persistent objects. Okay, exit play mode. I tweak these positions a bit more. When I'm happy with my layout, I go to File, Build Profiles, and I drag level 3 scene in here, making sure they follow in this order. We have a scene for level 3, and we also have this level 3 data file that we use to define which scene to load and what's the win condition, starting resources, and lives. For testing, in level 2 data, I set waves to win to 1. I save changes and I open main menu scene. Inside Assets Prefabs folder, I find Waypoint Prefab and I disable its sprite renderer to hide the waypoints. On Level Manager, we have this all levels array, so I drag level 3 inside. I make sure my levels are in this order. Okay, let's play. New game. Let's place some towers and defeat one wave quickly. Mission complete, and I click Next Level. Again, we have to defeat one wave to win, so I place some towers to destroy all enemies before they reach the other cave. Mission complete, and Next Level button is still interactable because we have level 3 ready to load. So Next Level, and here we have to defeat 3 waves to win. If you want source code from this point, it's available to download down below. What's next? Now might be a good time to choose a theme. It will be a pixel art game, or is there another art package you have been wanting to use for a while? Now it's your opportunity to make it your own. You can also create as many levels as you want using the same techniques we just learned. When I get Mission Complete panel, Next Level button is non-interactable because we haven't created any more levels, but I can enter Endless Mode to keep playing. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. If I play and I change speed, then I restart level. The speed resets to normal, but the button highlight doesn't reflect that. I try one more time, I go slow, I restart, and game speed is normal, but slow button is still highlighted. I need to make sure I call this highlight selected speed button method we have here in start, for example, and we define it down here. I make sure I call it as well whenever a scene gets loaded, and that scene is not main menu, and UI is shown. So calling it here inside show UI should do the trick. Save that. I play. I speed up. I restart the game, and button highlight resets. Perfect. So now we have fixed this minor bug. Let's implement sound effects and music in our game to make it feel even more responsive and give it some atmosphere. I open main menu scene and I create a new game object I call Audio Manager. I reset transform. Inside Assets Scripts, I create a new MonoBehavior script I call Audio Manager. I attach Audio Manager script as a component to Audio Manager game object, and I open it. We give this Audio Manager game object 2 separate audio source components: sound effect source and music source. This will allow us to control effects and music separately. Save that, and on Audio Manager, I see the new fields here. I add component and I search for audio source. Add it. And I add one more audio source component, so I have two. I assign one of them as sound effect source and the other one as music source. This will make our workflow pretty easy. I will have a public method here that will play audio, and I want to be able to call it from all the other scripts, so I will turn Audio Manager into public static instance. We did that before with other scripts, for example with UI controller, and we know that we need to add this awake method, so I just copied this entire code block and I paste it here. It will be identical. This code makes sure we always have only one Audio Manager instance in the scene, and it sets it as don't destroy on load, making it persistent as we travel between scenes. Up here, we will define some audio clips to play. Public audio clip I call button click clip. Another one I call button hover clip. First, let's start with a really simple one. I want to play a sound whenever we place a tower. I call it tower placed clip. Save that. On Audio Manager, you can see the new fields here waiting for audio clips. I go to the top level of Assets folder, and inside I create a new folder I call Audio. You can use your own sound effects, or you can download the ones I'm using in the resources section below. I drag and drop 3 MP3 files into the audio folder: button click, button hover, and tower placed. I drag and drop the audio files into the fields on Audio Manager here. First, let's play this tower placed clip. Inside Audio Manager script, I create a helper method, public void play sound. It will take audio clip I call, for example, clip as a parameter. It will take sound effect source, because we have a separate audio source for effects and for music, and it will call play one shot. Play one shot built-in method plays an audio clip once. It doesn't stop any currently playing audio in this source, which is important because we will be playing many different sound effects here as the game runs. I will also create public void play tower placed method. We can use this compact syntax. This line is simply declaring a method called play tower placed. When we call it, it will call this play sound method from line 28, and as a clip to play, it will pass it tower placed clip, we defined on line 13. So we have two methods here, a generic play sound method we can call and we can pass it the audio clip we want to play, and a method that will play a specific sound, in this case tower placed sound. We will also call this play sound method directly later, when we create separate unique sounds coming from tower or enemy data, when we want unique sounds for each tower. But first, let's focus on this thing, where we create simple methods like this for sounds that we will commonly need. Audio Manager is a public static instance, so we can play sounds from anywhere we need now. Inside UI controller, we have this handle tower selected method. Here we check if we can afford the tower, and we place it at the current platform. That's when I can play the sound by saying Audio Manager instance, and I call the public play tower placed method. Save that. And when I play, new game, when I place a tower, we get a sound like this. That works. Let's try the same thing again. I define a new field for audio clip. I call enemy destroyed clip. Save that. I drop enemy destroyed MP3 file into assets audio folder, and I drag and drop it into the new field we just created on Audio Manager. And let's say we only have one sound for now, regardless of enemy type. Every time any enemy gets destroyed, it will play this sound. So public void play enemy destroyed method that will call play sound from line 29, and it will pass it the new enemy destroyed clip. Okay, we have a method ready. Where do we call it from? I open enemy script, and when enemy takes damage, if enemy lives drop to be less or equal to 0, we call Audio Manager instance play enemy destroyed like this. Save that and I play. We get a sound whenever an enemy gets destroyed. So this is how we handle common frequently used sounds. We give each one a separate method to make it easy. We can add many more sounds to other things happening in the game by just following the same process. We just have to be careful where we play the audio from. We have to make sure it's a code block that doesn't run over and over for each frame. We will do more of these later, but now let's try something different. Let's use our audio manager to play a sound whenever we hover over or click any button in the game. We have a lot of buttons all across this project, all coming from the same button prefab. I don't want to set up sounds on each button individually because we have so many of them, but unfortunately I can't simply go on the prefab here and set up the sound here in the onClick, because we already customize each duplicate of this prefab with different actions in this onClick block. So if I do it in the prefab, it will not apply to the existing copies. Lucky for us, there is another solution. I can just do it once and it will apply to all existing and future buttons created with this button prefab by writing a simple custom script and attaching that to this prefab. I will go inside Script Utils folder and create a new MonoBehavior script. I will call it Play Button Click. I open it, and inside I want to write some logic that will play a specific sound when the button is clicked, and another different sound when we mouse over the button. I'll do some new syntax we haven't used yet. Above the MonoBehavior class declaration, I create an attribute, so square brackets like this, and inside I say require component type of button, spelled like this. We will need Unity Engine UI namespace up here. This line tells Unity that any game object with this script attached must also have a button component attached to it. If there is no button component, Unity will automatically add the component when we attach this script to a game object. We will also add this thing, which implements the interface for iPointerEnterHandler. We will need Unity Engine Event Systems namespace for this to work. By doing this, Unity will automatically call onPointerEnter method when the pointer enters the UI element with this script attached, which we need for the mouse hover detection. Let's write the whole thing and then it will make complete sense when you see it. I will need a private field for the button, like this. Inside awake method, when the object is first initialized, we take that button and we point it towards that required button component. Then we can simply take that button component, access its onClick, and we add listener. When the button is clicked, call Audio Manager instance playButtonClick method. That doesn't exist yet, so let's write it. Inside Audio Manager script, I define another public method I call playButtonClick, which will play button click clip that we already included earlier. And one more method I call playButtonHover, and this one will play button hover clip that we also already defined before. Back to playButtonClick script. So here we are adding listener for onClick, and whenever a button is clicked, we call playButtonClick to play the sound. And now the other sound, onPointerEnter method, which takes pointer event data. I call it event data. Inside, I call Audio Manager instance playButtonHover like this. If you remember, we implemented iPointerEnterHandler interface up here, which basically tells Unity that this class wants to handle pointer-enter events. If we didn't use this here, Unity would not call onPointerEnter automatically every time the mouse cursor enters the object's interactive area. I hope it makes sense. We need this here so that this object fires the onPointerEnter event automatically. So instead of setting all this up individually on each button we have in our project, we wrote this script, which I can just attach to the prefab that all our buttons originate from, and just like that, all the buttons will have click and pointer-enter sound effects. I check on Audio Manager to make sure we have some audio files in button click and button hover fields. I go to Assets Prefabs UI, and on the button prefab, I go to Scripts Utils, and I attach playButtonClick as a custom script component to the button prefab. Save that. And when I mouse over the buttons, we are getting sounds. Pointer-enter event works. When I click a button, we get a click sound. Nice. So this is another use case how we can use our Audio Manager to implement sounds in our project. I hope you are learning some valuable techniques here. Let's learn another thing that might be tricky for beginners, how to stop a sound that plays over and over and make sure it plays only once. Because depending on how you structure a codebase, sometimes there isn't a suitable code block that runs only once where you can easily play the sound from. For example, in the case of this codebase with mission complete, all the code blocks there related to mission complete are looping, because we are waiting to see if the player chooses to continue the level in endless mode, or if they decide to go to the next level. Let me show you what I mean. I defined new fields for mission complete clip and game over clip. As usual, I will create play mission complete method, and play game over to play these specific audio files. Now I go to UI controller and I find show mission complete block. And when we show mission complete panel, I will call audio manager instance play mission complete. Save that. In Unity, I drag and drop these two new sounds inside assets audio folder, and I associate them with their fields on audio manager. I play the game and I need to destroy all enemies in wave 1 to get mission complete screen. When it comes, I can hear that the sound is being played over and over. This code block, where we put it, is being run many times, because Spawner is invoking its own mission complete event over and over, and that's triggering this code block. I kinda need Spawner to keep doing that to leave our endless mode functionality intact, so let's create a flag here to check if the sound already played or not. I create a private bool I call mission complete sound played, and I set it to false initially. When Spawner invokes onMissionComplete and this showMissionComplete method runs, I will check if MissionComplete sound played is false. Exclamation mark means false. If it is, we can actually put all this code in. We need all of this to happen once for mission complete, and then I set mission complete sound played to true, which will prevent this code block from running again until we decide to reset this back to false. And I will only set it back to false when a new scene loads, so here, inside onSceneLoaded, after we hide panels, like this. So when we enter the next level, we set it back to false, and when we complete that level, the sound will again play just once. I play to test it. I place some towers and I quickly complete the mission. Yes, we get the mission complete sound and it plays only once. We also created a game over sound, which is much simpler. Inside UI controller, this show game over code block actually does run only once, so I can simply call play game over from here, like this. Save that and play to test it. I don't place any towers, I just let enemies to reach the end of the path until the player loses all lives, and we get a game over sound. And as you can see, even these buttons on the game over screen have sounds, so our button sound script works well. So these are kind of in-game sounds. We will add more, but those will be tower-specific, coming from Scriptable Objects data. We will learn how to implement that in a moment, but before that, here I will have a few more generic UI sounds to make the interfaces feel a bit more polished and responsive. I want a sound when we pause and unpause the game. I want to have a specific slowdown time effect when we click the slow speed button. We will have a different sound for the normal speed button, and another sound for the fast speed button. We will also have another sound for when we display a panel, for example when we click a platform and the tower panel appears. And one more UI sound for the warning message that tells us not enough resources. We are just following the same pattern. We already know everything. There is nothing complicated about these. I create methods I call play unpause, play speed slow, play speed normal, play speed fast, play warning, and play panel toggle. All of them have their specific clips associated here. I save that, and I drag the sound effect files I need into Assets Audio folder. With Audio Manager selected, I have a bunch of new fields here, waiting for their audio files. So I put unpause here, speed slow, speed normal, speed fast, panel toggle clip goes here, and warning clip here. Okay, so we have some new methods here, and I have to find a suitable place in the codebase to play them from. Let's go one by one. This is pretty obvious and easy. Nothing tricky here with these. Inside UI controller, when we click a platform and show tower panel method runs, I call play panel toggle. Inside show warning message, I will play warning here. I make sure it's before this wait 4 seconds delay. Inside toggle pause, in this block, we have play unpause. And here we play pause, which it looks like I didn't write. So I go to Audio Manager and I create play pause method, which will play pause clip like this. And we play pause here from this block. For speed buttons, I go up here to the start method and I will expand these single expression one-liners into a regular syntax so that we can both set game speed and also use Audio Manager to play speed slow, play speed normal, and play speed fast, like this. New game, pause unpause sounds, speed up button, normal speed, slow down button. Click the platforms to show the tower panel that also has a sound now. Adding sounds really goes a long way to make the game feel more reactive to player actions and also more polished. If you are coding along, I'm sure you can feel the difference when you play your prototype now. We are still creating a generic project, but you can replace these sounds with a different set. Make them all fantasy, sci-fi, retro, or horror to fit whatever game feel you want. You can always do that later as well. This codebase we are building is very reusable, and you can turn it into multiple different tower defense games. I want a little burst of particles when the mission complete screen appears. I haven't covered particle systems in this class yet, so let's do it. I make mission complete panel visible. I right-click mission complete panel and I go to Effects, Particle Systems. I rename it to Particle Burst. I untick looping checkbox here to make sure it plays only once. Duration is 5 seconds, so when I click play, it will play once for 5 seconds. Start speed will be 8. And I set delta time to unscaled to make sure it animates even when the game is paused. Emission block here. Rate over time is 100. I play. That's a lot of particles. Size over lifetime. I click this bit and I select the one that goes down to 0 to make particles start large and shrink down gradually, like this. Start lifetime 3 to make them shrink faster. And the whole effect duration will be 3. Start speed may be 10. Velocity over lifetime linear x. +5 will do this. Back to 0. Look at orbital x. I get some interesting motion patterns. 7 looks like this. 1 is just like this. Y set to 3 will do this. 2, 0 is this. Interesting. -2. -1. No. -3. There are many other settings and options for particle systems, but I will let you experiment and create your own unique effect. How do we make sure this particle effect plays the 3-second loop once every time a mission complete screen appears? It's actually very simple. Inside UI controller, I create a new serialized field private particle system, mission complete particles. Then I can go down to show mission complete, which was being triggered many times, but we added this flag and we made sure this code block runs only once per mission complete event. So now it's safe to go inside, take mission complete particles and call play like this. Make sure you call this from a code block that doesn't get triggered over and over for each frame if you want to add particles to other places in your code base, like when you're placing a tower, or when tower shoots, or when enemy is destroyed, for example. When play method runs, it will play just once for 3 seconds because we set duration to 3 and we unchecked loop in here. I hide Mission Complete panel here. I select UI Canvas, and on the UI controller script, we have this new field for Mission Complete particles. So I drag that particle system I just created in there. It is behind the panel, so I can also select the particle system, and inside its renderer block, I select the UI layer and order in layer to 1. This will kind of cover the buttons for a while, I guess, so I'll have to tweak the sorting layers, or I can just adjust the effect so that the particles move around the buttons, I guess. Particle systems have many different customization options. For now, it's fine. Your particle system probably looks completely different than mine anyway, so I make sure I disable Mission Complete panel and I play to test it. When I complete the level, we get Mission Complete sound and a big firework of particles. I can still interact with the buttons even when the particles are covering them, so this is fine for me for now. I will set duration only to 1 second. Now it's shorter. This is alright. We can polish this when we create the final game build. I hide Mission Complete panel, and let's add a few more audio effects. But this time, we will learn how to define specific audio effects for each tower inside their tower data scriptable object, and how we use Audio Manager to play those unique sounds for each tower type. I open tower data and I defined a new field, public audio clip attack sound. Save that. And inside Assets Audio, I drop 3 new audio files, Tower Attack 1, 2, 3. I go to Scriptable Objects Tower Fast Tower Data. I see the new field for attack sound. I can lock the inspector if I need here, but I won't do that. I will just directly access the other folder and I drag Tower Attack 1 audio clip into the attack sound field on Fast Tower, like this. Strong Tower selected, and I will use Tower Attack 2. Burst Tower Data asset selected, and I drag Tower Attack 3 into its attack sound field. So now all 3 of our tower types have a link to a unique audio clip in their attack sound field. I open Tower Script, and we will play the sound from here. I could play a sound every time the tower shoots a projectile, but in this particular case, it doesn't make much sense, because look here. Inside Burst Tower, it shoots projectile once every 0.03 seconds. That would be a lot of noise. And even for the other towers, we don't want to play sound every time the tower shoots. It would be too much noise. So let's say I only want the tower to play its attack sound when its list of enemies goes from 0 to anything more than 0. Basically, only when the tower is activated. Let's see how that feels, and we can always change that later. I will do that inside the tower script here on its onTriggerEnter2D method. I will do a little minimal solution here. Inside the block that detects collision with an enemy, I want to check if the enemies in range array was empty in the previous frame. Temporary helper variable, type is bool, which can be true or false, and I will set it to an expression. At this stage, when we know we collided with an enemy, but before we add that enemy in the array, I check if at that point enemies in range count is equal to 0. If it is true, if it is empty, was empty is true. If it is false, was empty is false. I hope it makes sense. We are evaluating an expression and directly assigning that to a variable here. And only if the tower had no enemies to target, and now it has at least one, if was empty is true, and maybe we can also do an error check to make this more production ready. We should do null checks for everything as a good practice, to be honest. So if we actually have attack sound assigned in the data and it's not null, then we take Audio Manager instance and we call that playSound method. And as the audio clip to play, we pass it data.attackSound. So we have 2 ways to play sounds now. We can create these ready-made methods that already have the logic to call playSound and pass it an audio clip for us, or we can call playSound directly and we pass it the audio clip ourselves, like we are doing here. And because I'm passing it the value of attack sound field from the tower data, different sound will play for each tower type. Let's see if that worked. I save and play. When I place a tower, it will make a sound only when it starts detecting enemies. When it starts attacking. If all enemies in range get destroyed, the flag will reset, and next time an enemy is detected, the sound will play again. I think doing it this way is pretty reasonable to avoid too much noise, especially when we have too many towers all actively attacking. Do you have a better idea when the tower attack sound should play? Maybe once a second, as long as the tower is detecting enemies? Yeah, that could work as well. Let me know in a comment and we can talk about how we would implement that. Now we know how to play sound effects from the data. Let's try that one more time. This time, we will play a specific sound every time we spawn a new wave. And again, we will associate specific sounds with specific enemy waves. In Unity, I drag and drop these new sounds inside Assets Audio folder. I open wave data, and I define a new field. Audio clip, I call, for example, wave spawn clip. And inside the update method, after we invoke onWaveChanged, I take Audio Manager, I call playSound, and I pass it the current wave data and its wave spawn clip field, which will hold a unique audio clip for each wave. And I will also play it inside the start method to get the sound for the very first wave. Save that. Inside Scriptable Objects wave folder, I select wave 1, and I see the wave spawn clip field we created. And from the audio folder, I drag and drop wave 1 audio file in here. Wave 2 data, and I drag wave 2 audio in, and wave 3, and I drag wave 3 inside, like this. New game, and we get the sound I created for wave 1. You can use any other sounds you want. I created these sounds to match sprite sheets I plan to use later, but you might want different sounds and different graphics in the end. I expect when we start adding graphics, all of us will end up with different unique tower defense games. I do this mainly to show you how to actually implement these sounds if you want them. It's about the technique, it's not about the specific sounds we are using. You can easily replace the audio clips with something else. Mission complete panel, and I get next level. Let's fast forward a little bit to level 3. I deal with the first wave here. And when I get the second wave, I get this flapping wings and insect sounds. Because maybe my bug dragons might be coming here. Let's see. And wave 3, I get a growling noise announcing a wave of large, angry kaijus. Nice work. What's next? Maybe we can add some music. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. If I play the game, I notice a strange bug. I will fast forward a bit, and when scene 3 loads, the sound for wave 1 and wave 2 will play at the same time. The issue is here, inside Spawner, when we invoke onMissionComplete inside in-between waves block. This is not the best place to do this. I will cut this entire code block, and instead I will paste it down here in this block that runs when we have defeated all enemies in the wave. I say, if we have defeated enough waves to win, and if endless mode is not active, then we invoke onMissionComplete, and instead of returning, we will do an else and enter in between waves block. Like this. So when we defeat enough enemies, we check this condition and decide if we should complete the mission or continue the spawn-in cycle. Invoking this here prevents accidentally running the top block that contains the audio twice, back to back. So now only the correct audio should play when a new wave spawns. I play to test it. I will adjust these particles so they don't cover these buttons as much in a minute. Also, I notice when I click next level, the panel will disappear and we can still see the old level for a split second before the next level pops in. We will fix these two things next. But now I will quickly complete this level to see if the correct sound plays when we enter level 3. Yes, that's fixed. Perfect. Inside UI controller script, I go down here to load next level method and remove this entire line of code, because mission complete panel will be hidden by the hide panels method that runs on scene load. So when the next level, the next scene loads, mission complete panel will be hidden by this. I save that. Let's find the particle system on mission complete panel and tweak some values to make it move mostly outside of the buttons, making sure they are not covered completely. I set the duration to 2 to make it last a bit longer. Start speed, I click here and choose random between two constants. It will be 20 to 40, which will make them move very fast at first. Start size is also random between two constants, and it will be between 0.5 and 1. So now they are different sizes. Inside the emission block, I set rate over time to 150. I want more particles. Shape will be circle, a 2D shape, which is better for this situation. Mode will be loop, which will do this. Nice. Speed of that loop will be 2, like this. Velocity over lifetime, I can leave this the same, but I will add this block to limit velocity over lifetime, making them move fast at first, but gradually slow down to speed 0. And I try some value like this in the dampen field. This looks interesting. Okay, they start large and then they shrink. What if I go here to size over lifetime? I click here, and down here I click on the curve to add another handle. I use these handles to shape the curve, so I move these handles around to make the particles start small, grow to the full size, and then shrink again. Maybe a curve like this. Yeah, this looks pretty interesting. One more time. Nice. We can also rotate them, for example like this. Or I remove this and rotation over lifetime will do this. Okay, that looks nice. I guess for now, to go along with the pixelated simple art style, no rotation like this is the best. You can customize this however you want. My main goal was to make sure the particles don't spend too much time covering the block of buttons in the middle of the screen. I hide mission complete panel, and when I play, new game, I place some towers. We get this mission complete effect. I like it. Time to add some music. I open Audio Manager, and as you know, we have a separate audio source for sound effects and for music. I create a field for main menu music and another for gameplay music. We will need a public method to play music. It will take an audio clip as a parameter. First of all, if we are already playing the music clip, and play music is called again with that same clip to play, for example when we load a new scene, it will just return, which means it will continue playing the same clip. It will not reset it from the beginning. If this return doesn't run and the code is allowed to continue, we give that clip to music source, which is one of these audio source components. We attached two of them here. We will set the music clip to loop and we will call the built-in audio source play method to start playing the music. Save that. We have 2 new fields here. You can use any music files you want. I will use this retro music audio pack, and I will link this URL in the resources section below if you want to use the same clips I'm using here. I choose 2 music clips that I like, and I drop them inside Assets Audio folder. I then drag them here, one for main menu music and another for gameplay music. Where do we play this from? Ideally from one of our persistent objects that don't get destroyed on scene load. For example, I can do it here inside Game Manager. We already have this on scene loaded method here, so whenever we load a new scene or reload the existing one, we will check if the name of that scene is main menu. If it is, we will play main menu music by calling the public play music method we just wrote, and we pass it main menu music clip. Then I will have another block here, which will run only if current level is not null, so it shouldn't run in the main menu. In there, we reset the game state and we play gameplay music like this. We might have to put else if here to make these blocks mutually exclusive, but let's play test it and see. I can also set music and sound effect volume separately since they both use separate audio source components. I can do it here, like this for example, as a simple quick solution. We can also allow the player to do this by connecting this value to a UI slider, but I will not be doing that now. I want the music to be quieter, to be less volume than the sound effects. Maybe let's try 0.4, save that, and I play. I get main menu music, I start a new game, and I get gameplay music. Notice the music is quieter to make sure we can hear the sound effects. When enemies move all at the same speed, following the exact same path like this, it seems a bit artificial, like the movement is on rails. We can make it much more natural, closer to what you see in tower defense games like Kingdom Rush by doing 2 things: randomizing enemy movement speed and making them follow the same path, but adding a little randomized offset. Let's start by randomizing enemy movement speed. We still want the speed values to come from enemy data, but instead of having one speed here like this, I will create 2 separate values for min speed and max speed, like this. That might give me an error because this enemy script can't find the speed value in the data anymore. So let's open it and fix it. We will have this helper speed property here. Inside update, we will use that speed here, like this. And inside initialize, I will set speed to a random range between min speed value coming from the data and max speed value coming from the data. And finally, inside Scriptable Objects enemy folder, I open enemy kaiju data file and I set min speed to 0.5 and max speed to 1. Enemy orc will have min speed 1, max speed 1.5. Enemy dragon, min speed 1.5, max speed 2. If I save and play, enemies move at slightly different speeds. This helps a little bit. Now the other thing, to make sure the enemy movement doesn't look like they are moving on rails. This block will have to do with the path, so I will keep them together and I define a private vector3 variable I call offset. We still make sure enemies move from waypoint to waypoint, but they will not be all set in their target position exactly at the coordinate of the next waypoint. We will add a little bit of randomness there. Inside OnEnable, target position will be the enemy's current target waypoint along the path, plus that offset we just defined. And we do the same thing here inside update. When the enemy reaches the current waypoint and changes its target position towards the next waypoint along the path, we will also add that little offset. Finally, down here inside initialize, we set offset x to a random value between, let's say, minus 0.5 and plus 0.5. Offset y is also random between minus 0.5 and plus 0.5. And then finally, we set that offset field we defined up on line 15 to a new vector2 that uses this randomized offset x and offset y. Save that and play. This will cause enemies to walk along the paths that follow the waypoints we defined, but they will all walk along their own lanes that are slightly offset from the main path, giving it more natural look. How much of that offset we allow will depend on how wide the roads are in your game world art. We hard-coded the offset to 0.5 for now, which is fine. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Let's keep the codebase clean, so before we add touch controls and build a quick and easy mobile version of the game, let's fix a few bugs. Bug number 1. When I play the game and return to main menu, gameplay music is still playing. Also, because we entered main menu from a pause screen, when I start a game thinks it's paused, so the first trigger of pause will only play the unpause sound, and it will do nothing. I have to pause again to actually show the pause panel. Inside Game Manager and its onSceneLoaded method, I use elseIf here to make these blocks mutually exclusive. This will fix the issue with music. Save that. And inside the UI controller, we have this isGamePaused boolean. Whenever we load a new scene, we hide panels here, which includes the pause panel, and I set isGamePaused to false, because whenever we reload a new scene, the game will never be paused. This will fix the pause panel issue. Inside enemy script, we use this convention where we start private field names with underscore so that I can easily see that speed is a class level private field. This will have no effect on any functionality, just to keep our naming conventions consistent. I also rename it here on line 43 and here on line 94. That's better. Inside Spawner, in this block we edited recently, there is a small chance that our game can display Game Over panel and Mission Complete panel at the same time. So let's add one more little condition here. Only invoke on Mission Complete event if player lives are more than 0. We store player lives here inside Game Manager, so I expose them as a public read-only property. Same as we did with resources earlier. This means that other scripts can check how many player lives we have, but they can't edit that value from the outside. And back here in Spawner, we only invoke on Mission Complete if we defeated enough waves to pass this waves to win check, and we are not in endless mode, and if player lives are more than 0. Now it's not possible for Game Over panel and Mission Complete panel to show up at the same time. I go to Assets, Scenes, and I open Level 1 scene. Move tool here, and I notice that Platform 9 and Platform 10 are on top of each other. They both sit at the same coordinates, so I select Platform 10, and I will move it to a position, for example up here, x3, y4. Let's talk about mobile games. In Unity, it's so easy to make your game playable on mobile phones, at least the very basic setup. Let's go over it step by step. If I click here, I have an option for Simulator. This should come pre-installed in Unity 6. If you don't see it here, you need to install it in Package Manager. Let me know if there is someone who doesn't have Simulator here by default, and I will tell you how to add it. The Unity Device Simulator is there to let you preview how your game will look and behave on different devices without actually building and deploying it to a real phone or tablet every time. We will actually deploy it to a real phone in a minute, but let's start in the simulator. First of all, this game will always be played in landscape mode, so I click Rotate here. For now, let's focus purely on mobile phones, not on tablets. Cross-device compatibility can be tricky, but Unity helps us a lot here. If I click here, we have a selection of commonly used devices. You can also add more, but these are enough for us right now. I will do an Android build, but everything we do should be very similar for an iPhone. I select, for example, Google Pixel 5. This is what the game will look like on it. We can see that the background image doesn't quite reach the edges of the screen, but I'm not worried about that because this is only placeholder art. The real game map would be built in a way that accounts for this. We will do that later when we add actual art assets. I'm inside level 1 scene. I will keep this as a game with a static camera for now, so this will be the visible game area on a landscape mobile phone. I will take spawner, move tool, and I move it just off the visible area to make the enemies spawn off screen. I open the path and the last waypoint, move tool, and I move it outside the visible game area as well, like this. I save changes to level 1 scene, I open level 2 scene, I move spawner off screen, like this, and I move the last waypoint in the path outside the visible area as well. Save that, level 3 scene, spawner will be off screen here. Path, waypoint 6, the last waypoint will be somewhere here. This ensures enemies walk off screen before they disappear. Before we create a playable build, let's add a custom icon, company logo, and a cursor. You can download these in the resources section below, and once you get them working, you can replace them with your custom ones if you want. I drag and drop cursor, icon, and logo into Assets Art. With cursor selected, we have to go here to Texture Type and set it to Cursor. Like this. I click Apply. With icon selected, I set sprite mode to single and click Apply. With logo selected, sprite mode single and click Apply. I go to Edit, Project Settings, Player. Let's start by adding some company name here. We have this default icon here, so I drag and drop the tower icon in. This will work for all the game builds. We already created a Windows build, so if you patch it with these changes, your Windows app will now have a nice tower icon. In a moment, when we build an APK file for mobile, your phone will also have a playable version of the game saved on it with this tower icon. You will see. Default cursor field. I drag and drop my custom cursor in. The cursor will not be visible on mobile devices, but from now on, in regular game preview in Unity, and when you play on your Windows build, you will have this custom cursor. If I keep cursor hotspot at 0, 0, Unity will treat the top left corner of this image as the click point, which is ideal for this arrow shape. You can see Unity also automatically resizes the icon we gave it. This is fine. The splash image section controls the screen that appears when your game first launches, before your first scene loads. If I click preview here, it's this thing that by default says made with Unity when you run your game. We can add our custom things here if we want. For example, we can add our custom logo to appear alongside made with Unity, or we can make them appear in sequence by setting draw mode here to all sequential. By default, we have made with Unity appear for a duration of 2 seconds. I will click plus to add my own logo as well, and I drag the logo we prepared into this field. Let's set duration to 4 seconds, just to see how this looks. I can choose background color here. And if I click preview, this is what people will see when they launch their game on a computer or on a phone. There are many more things you can do here, but it's pretty self-explanatory, so you can experiment and customize this however you like. I can see I can even remove the Unity logo completely. I think this was not possible before on a free version. Interesting. What we did here on Windows, Mac, Linux tab will also apply to mobile and web builds. But if we want, we can change that and set them up individually. I have settings for Android here and web settings here. You probably don't see this panel with settings for Android. To see this, you have to have the Android build support module installed in Unity Hub. Now is a good time to do it. I open Unity Hub. I go to Installs tab, and if you have multiple Unity versions installed, choose the one you are using for this tower defense project. Click Manage, Add modules. From the list, select Android Build Support, which also includes required tools like Android SDK, NDK, and OpenJDK. Click Install and wait for the process to complete. Restart Unity and you will be able to go to File, Build Profiles, and Build for Android should be accessible here. We're not going to do this yet. Let's go back to Edit Project Settings Player, and now you have Android settings here. I go under Other Settings, and I put down some package name. This node here tells you that the package name must follow the conventions com.yourcompanyname, .yourproductname. So I will put down something like com, Code Laboratory, Tower Defender. Also, when we build for a mobile device, we might get a warning message because of this field. Active input handling in Unity decides which input system your project uses to read player input. Currently, we have it set to both, which includes the old and the new input system. To keep this more future-proof, we use only the new input system. So I select Input System Package New here. I click Apply, which will restart Unity. When I reload, I'm back in Unity, and I make sure I have active input handling set to new input system package. I go to the Android tab. I go to Resolution and Presentation block. Under Orientation, I set default orientation to Auto Rotation. Auto Rotation behavior, user value here will make sure the game rotates only if the user has rotation enabled in their phone settings. Sensor value means Unity rotates the screen based on how the player physically tilts the device, regardless of system or user settings. Normally I use sensor. I will try user just to test it. We can always change it later. And this game will only work in landscape mode, so we will let it flip between landscape right and landscape left. We will untick portrait. Portrait mode is not allowed for this game. Okay, let's save all of that, and I open main menu scene. I click here to make the simulator full screen. I make sure I have fit the screen selected here, and I play. I can click UI buttons with the mouse, so we know this will already work on a touch screen. But what if I try to click the platforms? Nothing happens. We need to adjust our code so that platforms register touch events. How to add touch controls with Unity's new input system? As usual, it's super easy. Let's take it step by step. I open platform script. If you remember, here inside the update method, we wrote some logic that will use the new input system to check if left mouse button was pressed. It will convert that mouse position to a world point. It will use raycast to allow us to filter only platform colliders and ignore colliders on other game objects. And when mouse click on a platform is detected, we invoke onPlatformClicked event that opens the tower panel and so on. So I have to make a small change here to make sure this code reacts to mouse clicks and also to touch events. Keep in mind that we are inside the update method, which runs over and over. I will create a bool here. I call it mouse pressed. This will be true only if a mouse device is connected and if the left mouse button was pressed during the current frame. Only if both of these conditions are true, mouse pressed is true. Otherwise, it will be false. We will have another bool called touch pressed. Initially, I set it to false. I will create a vector2 variable I call screen position, and initially it will be vector2 0. We will write some logic here that will decide if mouse or touch was pressed. And based on that, we will set a screen position value. If mouse or touch was pressed this frame, we know we have some screen position from the mouse click or touch. We convert it to a position in the game world, like this. Now, how do we check if touch was pressed? Let's create another else if block here. If mouse pressed is true, we set screen position to the current position of the mouse. Else, if a touch screen device is connected, we take the current touch screen and we access the collection of all touch points currently detected on the screen. We loop over all of them with a for each loop. We loop over all touches because on modern devices, a player can use more than one finger at the same time. This is called multi-touch. So we expect the possibility that there are multiple touches registered at the same time. I say if a touch was detected, we set touch pressed from line 17 to true, and we set screen position to the touch position of the touch. Once we find one active touch, we stop looking, so break here. Okay, so we are detecting if the left mouse button or a touch was pressed. If we detect any from this frame, we save the position of that mouse click or that touch as screen position, and we pass that screen position value along to world point. The rest stays as it was. Our code from before will invoke on-platform clicked event and so on. This is the simplest way we can detect touch input with Unity's new input system. I save that and I play. In Simulator, I'm able to click platforms now. This is simulating touch controls, so we know our game is now fully playable on touch devices. There is more we can do here with optimizing the UI layout, positioning, camera view, and so on. This is a pretty solid base for a simple mobile game. I tested it fully in the Unity simulator, so now is a good time to plug in my actual phone and send a playable build to my phone to play it there natively on an Android device. I go to File, Build Profiles. We learned how to create a playable Windows build earlier. It's currently active here, so I can simply click Build and Run to push all the changes we did since then to update that Windows build, and I can play it on my computer. We also installed Android build tools, so I can choose Android build here. I can click Switch Platform to set Android as my active build profile. It might take a while. I currently don't own an iPhone, so I can't test it, but I imagine you can do something very similar if you have an iPhone in your hand. You can install iOS build tools, go here, and go from there. I'm building Android now because I'm holding a Samsung phone in my hand. But how do I send the game from Unity to my phone? Once I have Android set as an active build profile, I go down here and I have this Run Device field. I can do it by connecting my Android phone to my computer with a USB cable. Before I do that, I take my phone and go to Settings, About Phone, Software Information. This can be slightly different depending on your phone brand, but you can easily look it up. What you need is to enable developer settings on your phone. Usually, you do it by tapping build number 7 times until you see you are now a developer. Now we can go back to Settings and we will find Developer Options. Inside Developer Options, I scroll down until I find USB debugging and I enable it. USB debugging allows you to copy data between your computer and your device. Then you can connect your device via USB. Use a good USB cable that supports data transfer. On your phone, allow USB debugging permission when prompted. Make sure the phone is unlocked and connected. And now you can go to Unity again, under Build Profiles, Android, and the Run Device field. I click Refresh, and I can see my phone in the drop-down. So I select it. If we enable Development Build here, we can also use these Build to Device options, but for now, with my phone connected via USB cable and selected here, I select Build and Run. I will select a local folder on my computer where I want to create the build files. It should be in a separate folder, not inside your Unity project folders. I give it some name, for example, Tower Defenders, and I make sure we are saving it as an APK file. I save that, and Unity will create the necessary files on my computer, and it will also send them to my phone via the connected USB cable. This process can take quite a while, depending on your device, but when it's done, if you unlock your phone, the game should start playing automatically. If it doesn't, the game is installed in your applications, so you can find an app with the tower icon and open it like that. There is much more to mobile game development, but this is a pretty good start. Well done. Let me know if you managed to get this far. Do you also want me to show you how to turn our project into a web game and publish it on one of the free online platforms, so you can send your friends a link and they can play your game in a browser? It's also very easy in Unity. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. As I play on my phone, I notice that occasionally when I select a platform to place a tower and I choose one of the 3 available towers, the tower is placed, but the panel doesn't close. It could be because of how touch events are registered. It seems that sometimes it fires multiple touch events in a row. Or maybe the same touch event that selects the tower card also leaks through to our 2D raycast and selects a platform again, reopening the panel. I will prevent this bug by going here inside the platform script and adding one more condition to make sure if we tap on a UI element, like the tower card, it will skip the raycast entirely. If any of these conditions is true, we return, preventing the rest of this code from running. If tower panel is open, we prevent platform clicks. If the game is paused, we prevent platform clicks. And this line filters out UI tabs and clicks before our platform raycast even runs. IsPointerOverGameObject by default only detects UI clicks, so basically I'm saying if any UI element was clicked this frame, don't run the rest of this code. Don't do the raycast, don't register interactions with platforms. If I wasn't entirely sure what this bug was about, I would set up a series of debug logs and try to figure it out that way. I would log the sequence of actions that happened in the console, but I'm pretty sure that touches are leaking through UI and triggering our 2D raycast on the platform. If not, and we still get this bug, I will come back to this. Save that, back in Unity, and I will do a quick series of small fixes. Let's clean up this code base. I go to Assets Prefabs, and I select the platform prefab. Down here, inside its sprite renderer, let's set its sorting layer to towers, order in layer 0. This way, when we add a background image in a moment, platforms will not be hidden behind it. I go to Edit Project Settings Player. On the Android Settings tab, in Orientation Settings, we have Auto Rotation here, and I set Auto Rotation Behavior to Sensor. This will make sure the screen flips between landscape left and landscape right automatically, even if the phone doesn't have screen rotation turned on. It will make sure the game always automatically checks device position so we don't play upside down. Also, I notice as I play, if I don't press anything for a while, my phone screen eventually enters sleep mode, even if the game is running. I open Game Manager script, and down here inside Awake, I set Screen Sleep Timeout to Sleep Timeout Never Sleep. By default, this is set to Sleep Timeout system setting, so it follows the device's screen timeout. Setting it to Never Sleep forces the screen to stay on. I open Audio Manager and I reduce music volume to 0.2 here. Save and back in Unity. Inside UI Canvas, we have Objective Text Game Object. You can see its size here, and if I play, if there are any platforms behind Objective Text, we can't click them. I can only click these platforms down here after Objective Text disappears. So how do I mark an element to be ignored by our raycast so that the raycast can pass through it and interact with the platform behind it? It's very simple. With Objective Text selected, I go down here to Extra Settings and I uncheck Raycast Target. This makes the element invisible to clicks and touches, so it won't block interactions behind it. I want to add a custom font, but at this point we have so many text elements all over the place. Changing fonts manually on each text object would take a while, so let's write a simple line of code that will swap font on all text objects at once. This gives us an opportunity to play with different fonts and easily swap them until we find a font that fits well in our game. Inside Assets, I create a folder I call Fonts. I go online and I find a font that I like. If you want to use the same as me, I will leave a link down below. I download it and I use the TTF file, TrueType font format. You can also use OTF format, OpenType font. It will work as well. I right-click the font file and go Create, TextMeshPro, Font Asset, SDF. This generates a TMP font asset, which is required because TextMeshPro doesn't use TTF files directly. Now I have this font asset. If I wanted to add it individually to each text element, I select some text element, for example this title, and I find its TextMeshPro component, and I drag this into the font asset field. Nice. But I take it back because I want to show you how to automatically apply this font to all text objects with code. Mainly under UI Canvas, we have so many panels, button groups, and text fields. If you want, you can assign the font asset to each one manually, because maybe you want to use multiple fonts. But if you want just one font everywhere, let me show you how to do that. I can create a separate script for this, but it's more convenient for me to add this functionality to Game Manager. We will be handling fonts here, so we need the TMPro namespace. We create a new serialized field private TMP font asset I call global font. Save that, and with Game Manager selected, I see that new global font field here. So I drag my font asset inside. Now that we told Game Manager which font we want to use for all objects, let's find all text objects and apply it. I create a private method I call applyGlobalFont. Inside, we create a for each loop that will find all objects by type. The type we are looking for is TextMeshPro UGUI. TextMeshPro UGUI objects are UI text components provided by TextMeshPro. They live under a canvas, so I'm saying find all text objects in the scene. Include even inactive ones, for example objective text that is hidden at first, it's inactive. And sort mode none means do not sort them, which will save some performance. Once you find all UI text objects, set their font field to global font we defined earlier. If I have some text elements that are not part of UI and do not live under a canvas, they exist directly in the scene, we might also need this line, which looks for TextMeshPro type. This would be useful if we had floating nameplates above characters or damage numbers in the game world. UGUI is managed by Canvas. TMP is a freestanding mesh-rendered text in the scene. Currently, we don't have any text like this, so I can remove this part. I just mentioned it in case you need it in the future. Now, let's call applyGlobalFont from this block inside awake. We are calling it once here when the game loads, which is fine. Don't call this repeatedly in update, that would affect our game's performance. One thing to mention, applyGlobalFont will run once when we enter play mode. It will be applied to all UI text elements under main menu canvas and UI canvas. UI canvas is persistent. It will travel between scenes, which is fine. Main menu canvas is scene specific. It will get destroyed when we leave the main menu scene, and it will be recreated when we go back to the main menu, which means we will lose the font. Let me show you how that works. I enter play mode. We get our fonts automatically. Font was applied to everything except for these values on tower cards. We will explain why that happened in a minute. I need to also fix my buttons. Either make the buttons wider or put less text inside. Now, if I return to the main menu, we lost the fonts in main menu scene. Okay, so we can use this method to apply custom font to all persistent text objects, but not to scene-specific ones that get destroyed and recreated when we jump from scene to scene. I can either apply global font on scene loaded. Every time we load a new scene, we reapply the font. But in our case, this non-persistent main menu canvas has only 3 text objects, so it's easy enough to manually select the title and set the font asset. New game button, and its text object, and I give it the font asset manually, and I do the same for quit game button. I enable pause panel. Inside its button group, I find restart level button and its text object, and I change the text from restart level to only restart to make sure the text fits inside the button with this new chunkier font. Title selected, anchor presets, I hold down Shift and Alt, and I set it to stretch top. Vertical position -40. OK, I disable pause panel. I enable game over panel, restart level button, will be only restart here. Title, Alt plus Shift, stretch top, vertical position -100. I hide it. I enable Mission Complete panel. Endless mode button. The text will say only endless, so it fits in. And here, the text will say restart. Title selected. Anchor preset is stretch top. -100. I hide the panel. I also need tower panel. I select the title, Shift-Alt, stretch top, -40 here. If you remember, the tower cards that appear on this panel didn't have the font applied. We said apply the font even to inactive elements, but these cards are not inactive. We are actually dynamically creating them from a prefab when we open the panel in-game. So if I want tower cards to have a special font, I hide tower panel and I go to Prefabs UI. I select tower card prefab, double-click to open it like this. Here I see its cost text object and its font asset field. From assets fonts, I drag the custom font asset in. So with this non-persistent canvas, we assigned the font asset manually. For all elements under UI canvas, including wave text, live text, and resources text, it will be applied automatically. Because UI canvas is persistent and jumps from scene to scene, the fonts will stay and don't need to be reapplied here. If I play, we will have a custom font everywhere now, even on tower cards. Pause menu. Not enough resources text message. And mission complete screen. If I go to the next level and load level 2 scene, we still have the new custom font everywhere. I exit play mode. I save changes to main menu scene, and I open level 1 scene. Here we have a spawner, and it holds these object pools under it, and it has these serialized fields that hold references to waves and to the object pools. Inside level 2 scene, we have an identical copy of this spawner. And in level 3 scene as well. If I add 20 enemy types, this would become a bit complicated to manage. Rather than holding separate spawners in each scene, I want to have one persistent spawner that travels from scene to scene. So inside level 3 scene, I select the spawner and I delete it. Save that. Inside level 2 scene, I also delete the spawner. I save that and I open level 1 scene. We will keep this spawner and make it persistent across all scenes. We already know how to do that. So I open spawner script, and down here inside awake, I use don't destroy on load like this. I save that. Now we have only one spawner game object. It sits inside level 1 scene and it's persistent. As you might expect, this will create a few issues because we built our code base with spawners that exist one per scene. They get destroyed when we load a new scene. So let's go to main menu, enter play mode, and trigger these errors one by one to address them. We have a don't destroy on load block here, and when I start a new game and level 1 scene loads, the spawner is added here. So far everything is working fine. But when we get mission complete and I click next level, which seems like we are not resetting spawner variables to their default values when we go from scene to scene. So after all this chaos, let's go inside spawner, and whenever we load a new scene, we will reset values like wave counter back to 0. We will need scene management namespace for this. Inside OnEnable, we subscribe to scene manager scene loaded. We did this before. And we also remember to unsubscribe here. Down here, I create onSceneLoaded method, which needs these parameters for it to work. We also know that from before. And every time a scene loads, I want to reset all the important spawner fields to their default values. So let's create resetWaveState method, where we set current wave index back to 0, wave counter back to 0, spawn counter to 0, enemies removed to 0, spawn timer to 0f, and is between waves will be set to false. Spawner is persistent, it will travel between scenes. Whenever a new scene is loaded, we reset wave state like this. I play, I complete level 1 scene. I get mission complete screen, and let's open console. Next level actually works, but as you can see, enemies lost the path. They are not following it anymore, which was expected. I exit play mode. If I didn't know what was the issue, I could open the error here, and it takes me from file to file as the issue happened. I can then track it this way. At a glance, I can see the issue is related to the path script anyway, so let's fix it. We have path1 game object here. If I open level 2 scene, we have path1 here as well. It's a different scene-specific path. And there's another separate path here for level 3 scene. I open level 1 scene, and before we fix the path issue, notice that Spawner has these object pools where we pre-instantiate 5 reusable enemy objects. I need to make sure that when I enter a new scene, I deactivate all currently active enemies and return them back to their object pools. This was not an issue before when the spawner was level specific. It was all destroyed when we loaded a new scene. But now, when spawner is persistent, these object pools are spawner's children, so they also persist. So we have to manage them. I create a public method I call resetPool. Inside, for each game object inside the pool, I take that game object and I set active to false. When we load a new scene, all enemies will start as inactive. We will not be transferring active enemies between scenes. Inside Spawner, we have references to the object pools here, and we have this pool dictionary, which pairs enemy type from the enum with a specific object pool that contains that enemy type. So whenever we load a new scene and reset wave state runs, I will cycle over each pool inside pool dictionary values, like this. And if we find a pool and it's not null, we call its resetPool method that we defined here inside Object Pooler. It will deactivate all enemies in case there are some active ones. Save that. Main menu scene. And when I play, I get an error with the code I just wrote. I have an issue with this resetPool method. I exit play mode. When we write code for our game, we have to be aware in what order things happen. The error comes as soon as the code loads, because onSceneLoaded is calling reset wave state, which needs these pools to already be there in the pool dictionary, so that we can cycle over them and reset them. Inside Object Pooler, I'm creating the pools inside Start, which seems to be a bit too late. We already need them to be created at this point. To avoid that error, because this pool list is iterated over immediately as the scene loads and resetPool is called, I create pools inside Awake instead, which runs before Start. Doing that will make sure pools are ready in time. And if I play, everything will work nicely. No error. At least in level 1 scene, because if I enter level 2 scene, enemies lose the path, as we said before. I have the path script here. I actually don't need to do anything here directly. I exit play mode. Let's go from simulator back to the standard game view. What was the resolution? I think 1920 times 1080 landscape. By the way, if we play in this view, we will get the cursor we created earlier. Anyway, I exit play mode and I go inside enemy script. Enemies lose reference to current path when a new scene loads. It's because they only search for the path when they are first created here. Let's rework this a little bit. Instead of giving each enemy the responsibility to find a path to follow, we will make Spawner find the path once every time we load a new scene, and when Spawner initializes an enemy, it will pass that path. That way, we don't have to find the path so often. I delete this line. Also, I want these two lines to run only after we are sure we have the current path, so not here inside OnEnable. I will cut these two lines of code, and I paste them here inside initialize. This initialize method will also expect path for the enemy to follow as a parameter, like this. And inside, we set current path field to the path that was passed here. Then, once we have the path, we set enemy to the beginning of the path and set its target position as the current waypoint along the path. Okay, so enemy is not looking for the path game object anymore. It will receive that information from the outside through this initialize method. Spawner is calling initialize here inside spawn enemy. So let's go up here and find path inside Spawner. Like this. Private path, I call current path. Spawner is responsible for locating the path now and storing it in the current path variable. Whenever we load a new scene, we know there is a new path game object there. So we need to find it using this line of code. And whenever we spawn a new enemy, we know initialize now expects the path as the first parameter, so I pass it here like this. Spawner found the path on scene load, and whenever it spawns an enemy, it's given that enemy a reference to the path it should follow. Enemy will then handle the rest of the logic. Instead of each enemy calling find method to locate the path, Spawner does it once per scene load, and then gives that information to enemies as it spawns them. This is slightly better for performance as well, because we are not calling find as often. Save that, and from main menu scene, I enter play mode. I play. We have this persistent spawner here. I go to next level and spawner persists. As you can see, enemies correctly found the new path inside level 2 scene, and they are following it. There is one more thing we have to consider now that we made the spawner persistent. If I go back to main menu, I will get an error because spawner is persistent and it is here in the scene and it's still trying to do its thing. But there is no path here in main menu scene to be found. You can probably guess that a simple way to fix this is to make sure spawner logic doesn't run inside non-gameplay scenes like main menu. I exit play mode, and inside spawner I create a private bool I call isGameplayScene. Initially I set it to false. On scene loaded, whenever we load a new scene, we will check if it's a gameplay scene or a menu scene. IsGameplayScene can be true or false. If the name of the current scene is not main menu, IsGameplayScene is true. If the scene name is main menu, IsGameplayScene is false. We are directly evaluating the expression and assigning a resulting true or false to this variable. I have to make sure that I spell main menu exactly as the scene name, like this, if I want to use the name here. This has to exactly match the name of the scene. I make sure I call reset wave state on every scene load unconditionally, so it will have to go next. After that, if we are not in a gameplay scene, meaning we are in main menu, we return and we don't look for the path, because inside main menu there is no path. I copy this line, and up here we will also make sure none of this code inside update runs if we are in a menu. It will only run inside gameplay scenes like level 1, level 2 and level 3. I save that. I go inside level 1 scene and I copy the spawner game object. I open main menu scene and I paste it here. I will have all my persistent objects here starting from main menu. I save changes, go back to level 1 scene, and delete spawner from here. So now there is no spawner inside level 1, level 2, or level 3. Spawner is only in main menu scene. I play, and I get wave 1 spawning sound. That's not supposed to happen. So I exit play mode. Inside spawner, I cut this line from start method, and I paste it here inside onSceneLoaded, but only after we checked if we are in a gameplay scene. This will make sure that wave spawn clip for the first wave will play only when it should. Save that and play. All is good here, new game, and I can play. Spawner is working, correct sounds are playing. Notice that enemies spawn from the location of the spawner. Right now it's here. Next level. I move the spawner around and enemies will spawn from that point. Now that spawner is persistent, it will always sit at one position, but maybe we need enemies to spawn from different positions for each level. We will define spawn coordinates for each level, and every time we load a new scene, we will move spawner to that position. Spawn coordinates will be level specific, so it makes sense I store them inside level data. So I'm inside Assets Scriptable Objects level folder, and I open level data scriptable object. I create a new field, type is vector2, and I call it initial spawn position. Save that. For level 1, I set initial spawn position somewhere like -7 units horizontally, from the middle. You can see 1 unit as 1 cell in this background grid. Vertically, it will be +6 units. Level 2 will be -12, 2. Level 3 is -12, 1. We can always change this later depending on our map layout. So now inside level data, we have initial spawn position. We will use this inside spawner. Whenever we load a new scene, and it's a gameplay scene, we can find level manager instance current level. If it's not null, we move spawner to this position from the data. Transform position of the spawner is equal to level manager instance current level, initial spawn position. When we load a scene, move the spawn game object to the position where we want enemies to spawn from. Save that. Initially in main menu, spawner sits here. In level 1, it should move to -7, 6. Let's play and see if it moves there. It's here. New game. And it's here. Perfect. Now we have a spawner that persists through scenes. This will make our workflow much easier if we want to add many different enemy types. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I notice a small issue. If I select level 1 data asset and I set waves to win to anything more than 1, I set it to 2. I fast forward to the part where I finish level 1. And when I enter the next level, this text shows wave 2. I open spawner script. It has this event called onWaveChanged, and UI controller is subscribed to it, updating that wave text. So inside reset wave state, every time the wave counter is reset to 0, we invoke onWaveChanged and pass it that updated wave counter value so that UI controller knows it should update the text. While we are here, I also have to set isEndlessMode to false, because now, when spawner is persistent, after we enter endless mode once, we would always be in endless mode even if we reset the level. This will fix it. Save that. Spawner is persistent. It travels from scene to scene. Currently, it has this waves array that defines what enemy waves spawn. If we keep it like this, it will be spawning the same sequence of enemy waves in every level, so we probably don't want that. Ideally, we want to define a series of enemy waves independently for each level. We already have everything ready for this setup. It's just a small change. Instead of defining waves array here on the persistent spawner, we will define a separate waves array for each level from these level data files. So let's open level data script first, which is basically the blueprint for all of them, and I will add a public field which will hold wave data, and it will be an array. I will call it waves. Save that. Each level now has a separate waves array here. Inside the waves folder, I can name these anything I want, so I will probably call them based on the enemy type they spawn. For easier workflow, wave 1 data asset is spawning orcs, so I rename it to orc wave. Wave 2 will be dragon wave. I can even create multiple waves with dragons. Maybe an asset called quick dragon wave, where spawn interval is lower, and another asset called large dragon wave, where we spawn 100 of enemies per wave. I can manage my waves like this, and it will be easier to design the levels. Wave 3 is kaiju wave. Now I go to level folder and level 1 data asset. Here we see its waves array. I click plus twice. Let's say I want 2 waves that will repeat if we enter endless mode in this level. With level 1 data still selected, I open waves folder, and I can drag the wave assets in any order I want, however I want to design my level. Maybe in level 1 I want dragons first, and the second wave in level 1 will be orcs. Level folder and level 2 data file, plus plus, and here let's do orc wave first, and dragon wave after. Level 3 will have 3 types of waves: dragons, orcs, and then kaijus. As you can see, doing it this way gives us much more flexibility to customize each level, and by editing these wave data assets, we can customize the waves themselves. I can have multiple assets just for orcs if I want different orc waves. For example, this orc wave will have 20 orcs in total, each one spawning every 0.7 seconds. So how do we make our spawner load wave data from the level data assets instead of this waves array that sits on spawner itself? To do that, we just need to change a single line of code. Inside spawner, I will do something similar to what we did here with current wave. I will turn this serialize field on line 13 into a read-only property with a getter that executes every time we access waves. It doesn't store any data. Instead, it pulls directly from level manager instance current level each time. Also, because this is a private variable now, I added an underscore to keep our conventions consistent. I will also add an underscore in front of waves here on line 16 and down here on line 84. And now, instead of pulling wave data from spawner, we have a separate sequence of enemy waves stored inside the individual level data assets. Much better. We are pulling that data from level manager instance current level, which, if you remember, is defined here. And it will point us to one of these level data files. And we know that inside these data files, which sit here, we defined a waves array with a series of enemy waves. So from spawner, we are now accessing this waves array through level manager instance current level waves. Awesome. Time for a playtest. Level 1 starts with Dragon Wave, as expected. When we destroy all the dragons, we get an Orc Wave. As you can see, there is no waves array directly on spawner anymore. We removed that field and turned it into a getter that takes the waves array from these individual level data files. Next level is level 2, and as we can see here, it should start with an Orc Wave. That works well. And if waves to win here was set to more than 1, we would get Dragon Wave, and then Orcs and Dragons would repeat until we defeat enough waves to complete the level. Next level is level 3, and here we will get Dragons first, then Orc Wave, and then Kaiju Wave. if you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. If you downloaded my source code and Unity project and opened it at this stage, Unity will open this untitled scene. I go to Assets, Scenes, and open the main menu scene. In Game View, I make sure I have Full HD, 1920 x 1080 here. And it's time to add some animated pixel art characters. Inside Assets Art, I create a folder I call Enemy. I'll show you how to use this amazing site to generate your own unique characters. Here are some examples of what I was able to create here, but there are thousands more combinations. All of them export a sprite sheet unified in the same way, so it doesn't matter what customizations you use. They will all be animated in the same way in the next part. Let's jump straight in. I'll Google the name of the tool, click the first link you see here, and show you how quick and easy it is to create a fully animated, completely unique pixel art character from scratch. We start with a blank slate character like this. I can click the animated preview or the sprite sheet area here to make it larger or smaller, so that we clearly see the character we are building. Up here we have a set of animations. For my tower defense game, I will simply need only the walk animation, but there are many more. We can choose from multiple different body types. I usually choose male, female, or muscular. For my games, I will need a shadow under the character's feet. As you can see, the shadow only works for the basic animations, which is fine for my needs. But if you want more advanced animations, like climbing or running, you should be aware of this. The shadow will not render for these. You can use these filters up here to filter only body parts that support specific animations you need. There are so many options and ways to modify our character. Here in the body section, under Special, I can give it a skeleton body like this. Maybe we also want a skeleton head, so under this menu, we select Skeleton Head. As I scroll down, the basic animations are supported, and the skeleton body is not available for the advanced animations. We can also have a headless skeleton like this. I can click Reset All here and Collapse All here, and we can take our character in a completely different direction. Notice the URL here. If I go under Body and Wings, Feathered Wings, for example, and choose one of the colors, notice how the modifications are shown as part of the URL. This makes it easy to share your created characters with others. The only problem here is that when I select no wings, I would prefer that part about wings to be completely removed from the URL, but it will show wings equals none instead. So if I keep going back and forth, adding and removing features from my character, I might end up with a bloated string that doesn't add up too much. If I remove this entire part, the character will still look the same, so that part, saying wings equals none, was completely redundant. We have many kinds of wings up here, also tails and other fun body parts. You can create all kinds of creatures here. Under heads, I can choose, for example, Boarman. Notice that the color of the head will automatically change the color of the body as well, so the whole character matches. We can also have a bipedal pig and apparently also a sheep. For some reason this looks like a lion to me. We have zombie, vampire, Frankenstein. You can make an awesome Halloween game here if you want. Maybe I want to create a few different orc enemies. I select orc male head here. You can also try orc female or goblin here instead if you want. Up here under wings, I can try and give it bat wings. Maybe it's an orc vampire. Lizard wings are a bit smaller. Monarch butterfly wings will look like this. Now we have a fairy orc. Notice how the URL shows the orc head and wings I selected, so I can share my character with others by giving them this link. We can also give it clothes, weapons, and even armor. Let's give it a full set of steel armor. Under Arms, Armor, I choose Steel. Under Torso, Armor, Plate, I also choose Steel. Legs, Armor, Steel here. And Feet, Armor, Steel to finish the set. This is probably a very heavy orc. I'm not sure if it can fly dressed like this. Down here under weapons, I can give it a shield, maybe a Crusader shield like this, but we always have to check our preview. Now I see that the shield and wings are clip-in. They are not compatible when used together, so I can choose one or the other. I go up here and remove the wings. This is my Crusader orc. It's ready to be used for my game. The important part is down here. We must credit all authors. This section changes based on what body parts we used. You can use these sprite sheets for your projects, but always make sure you credit everyone involved. To download my sprite sheet, I simply right-click and select Save Image As. I'll call it Crusader Orc and download it as a PNG file. If you want, you can share your own characters with us by leaving this URL in the comments down below. The automated anti-spam system in the comments might filter out full URLs, so the best way to share is to put only this second part in the comment. We can always add the first part ourselves to see your character. I can't wait to see all the creatures you come up with. Back in Unity, I drag and drop all enemy sprite sheets I created into Art Enemy folder. If the site is not working anymore, because you're watching this in the future, I'll provide some backup enemy art assets to download, so you can still follow along. With all of them selected, I set pixels per unit to 32. These squares in the grid are units, and I'll render all pixel art assets in this project in a way where 32 pixels cover one of these units. The enemy sprites have frames of 64 times 64, so the enemies will span 2 of the units. You'll see in a minute. Max size is the maximum resolution in pixels that Unity will allow the texture to be when it's imported into your project. This setting limits the texture's width and height regardless of the original resolution of the source image. We need to set the max size to be equal or greater than the actual resolution of your original texture to make sure we don't lose quality. I click Apply. We're working with pixel art for this project. I select only the first enemy sprite sheet and open the sprite editor. I go to Slice, Grid by Cell Size. These sprites have frames 64 times 64 pixels. Importantly, I also have to set pivot here to bottom. This will later make sure that enemies, obstacles, and towers are drawn in front or behind each other in a way that makes visual sense for this kind of a game. I'll show you when we get there. Slice and Apply. Notice that as I scroll down in the sprite sheet, some of the features like the wings don't work for the advanced animations. In our case, it's fine. We'll only use the basic animations for now, so this is all good. If I zoom in, you can see the pixel art is not sharp, it's a bit blurry. To fix that, I select all of the sprite sheets again, and for sharp, clean pixel art, we always want to set filter mode to point no filter and compression to none. I click Apply. I select my second enemy sprite sheet and open the sprite editor. If I zoom in, we have nice, clean, and sharp pixel art. This will look great in motion. Again, I go to Slice, Grid by Cell Size, 64 times 64, pivot bottom, slice, and apply. I do the same thing for all my remaining enemy sprite sheets. Open sprite editor, go Slice, Grid by Cell Size, 64 times 64, pivot bottom, slice, and apply. When I've done it for all of them, we are ready for the next step. I can use this little arrow to expand each sprite sheet and see the individual sliced frames. Inside the Prefabs folder, I create a new folder I call Enemy. If you opened my source code and you're coding along that way, you might get this indexing issue. It's not a problem, but I don't like to have any annoying unexplained errors in the console. The way to fix this is to simply go to your project folder, find the library folder inside, and completely delete the folder called Search. To be able to do that, I have to close Unity. This is one of the folders you can delete safely. Unity will simply rebuild it and re-index the project, which will fix this error. I reopen Unity and drag all enemy prefabs into Prefabs enemy folder. I drag Dragon, kaiju, and orc inside. We'll have our enemies here to keep things organized, because now I'm about to show you a nice trick to create multiple enemy types with complex animation rules, but we'll reuse those rules for all of them, instead of setting them up individually for each enemy. I duplicate the orc enemy prefab and rename the copy to enemy. This will be our base enemy prefab. We'll set up directional walk-in animation logic on it, and we'll reuse that logic for all other enemies from here. I double-click the prefab to enter this view. Inside Art Enemy, I choose one of these. It doesn't matter which one. I expand it, and I can choose any frame I want to be the icon of the prefab by dragging it into the Sprite Renderer field on the enemy prefab. Because we set the pivot point on the sprite sheet to bottom, the image looks misplaced like this, but that's actually exactly what we want. It will make the sorting look natural based on where the enemy's feet are in the world. I just have to select the health bar here and adjust its position accordingly. Back on the main enemy object, I find its capsule collider component and adjust the size and offset of the collider to match the enemy sprite as well, like this. I have 5 different enemy sprite sheets here. I want to animate all of them and give them 4 directional walk-in animations to follow the path from waypoint to waypoint. I go to Window, Animation, Animation to open the animation panel. I can dock it anywhere I want. I like it on the right here. I open that new enemy prefab, and I'm inside the prefab like this, with the main enemy game object selected here. Actually, first I go to Assets and I create a new folder I call Animations. Now I go back inside the enemy prefab with this enemy game object selected here, and inside the animation panel, I make sure it says to begin animating enemy. I click Create, navigate to Assets Animations folder, and I want to create an animation clip called Enemy Walk Up. I press Enter or click Save. This warning message in the console can be ignored. Our animations will work fine, and you'll see that in a minute. I go to Art Enemy folder and expand the sprite sheet I want to animate first. The way all these sprite sheets are structured, the first frame in the walk up row is just an idle frame standing facing up. So we'll skip frame 60 and I will left click frame 61, the first frame in the walk up sequence. Then I shift click frame 68. The last frame of the sequence, selecting all the frames in between. I make sure I have the animation panel open and enemy walk up selected here, and I drag and drop all these 8 frames onto the animation timeline. I can play the animations here to see if we got the right frames. It's walking too fast, so I can slow it down here using this samples field. If you don't see samples, you can enable it by clicking here and selecting show sample rate. I set samples to 8 and press Enter. Now if I play, we get a nice slow-paced pixel art animation sequence. I click here and open the drop-down. Then select Create New Clip. I'm inside Assets Animations, and I create a clip I call Enemy Walk Down. I need to navigate in this sprite sheet to find the walk down sequence. This is the idle frame, so I left-click frame 79. Shift-click frame 86 to select all the frames in between, selecting all 8 frames. I make sure I have enemy walk down selected here and drag them onto the timeline. I don't see the keyframes because this is not selected. Now I can see them. It plays too fast. 8 samples. Yes, we have a walk down animation. Now I'll follow the same process to create walk left and walk right animations. Create new clip here, enemy walk left. Left-click frame 70, shift-click frame 77 and drag them here. Set samples to 8 to slow it down. And finally, I click Create New Clip, enemy walk right. Save that. I select frames 88 to 95. Drag them here. Set samples to 8, and that's it. I created 4 walk-in animations for my first base enemy type: down, left, right, and up. If I go to Assets Animations, I can see these animation clips here. I make sure they all have the loop time checkbox checked. It should be checked by default. We also have one more thing here called Enemy. It was named after this anime game object, and it's an animator controller. If I double-click it, it will open the animator window. This panel can also be opened by going to Window, Animation, Animator. In Unity, the animation panel lets you create and edit the actual keyframes of an animation, while the animator panel shows how different animations are connected and controlled, how they transition between each other, and so on. It's a simple state machine. I can right-click any of these and set it as a default animation. But what I want here is some simple logic that will automatically determine if the up, down, left, or right animation should play, based on what keys on the keyboard are being pressed, or in our case, on the direction where the enemy is currently moving, as the enemies will move from waypoint to waypoint following the path. Unity automatically created these 4 animation states representing the 4 clips we created, but in this case we don't want them, so I delete them. Instead, I right-click here and select Create State from New Blend Tree. I double-click that blend tree, which will take me from the base layer 1 level deeper, where we see this blend tree like this. I select it, and inside the inspector, I rename it to Walk. Here, I click Parameters and this little plus button. I want to create a new float parameter I'll call MoveX. And I create one more float I call MoveY. On the Walk blend tree, inside the Blend Type dropdown, I select 2D Simple Directional, which means it will need 2 parameters. So here I select my custom MoveX parameter, and here I select MoveY. Now I click Add Motion Field 4 times. We need 4 motion fields here. From Assets Animations, I drag Enemy Walk Down animation clip here. I drag Enemy Walk Left here, Enemy Walk Right, and Enemy Walk Up like this. You can see that our blend tree is fully formed here. This is the main brain that will process the logic, the values of MoveX and MoveY, and it will automatically decide which of these 4 animations it should play, based on the rules we are about to define. We want to play Enemy Walk Down clip if X is 0 and Y is -1. No horizontal movement and negative vertical movement, which in Unity means down. Left is X equal to -1, Y 0. Right is X equal to +1, Y equal to 0. Up is when X is 0 and Y is +1. When I click this blend tree to have this view here, we should get this little character preview down here. As the values of MoveX and MoveY parameters change, you can see how the blend tree decides automatically which of the 4 animation clips to play, based on the rules we defined here. I think the visual we see here makes that pretty clear what's happening. Now, all we have to do is to connect these MoveX and MoveY parameters to the enemy's current movement direction, and the correct animations will play. Inside Prefabs, I have this enemy prefab. It has 4 animation clips attached to it, and that blend tree that contains the logic deciding which of the 4 animations to play. We can now reuse this to create all of our enemy types. So I duplicate it and rename the duplicate as Fairy Orc. Maybe you created your own different creatures, so you can name this one however you want. Ideally, keep the name simple, using camel case and no spaces. I could just follow the same process we did step by step and create all my enemies this way. But to save ourselves some repetition, we don't actually have to recreate this blend tree again, because all of our enemies will need the same walk down, walk left, walk right, and walk up animations. To create my new enemy, first I want to change this icon here, by changing this sprite I put inside this field on its sprite renderer component. I can choose absolutely any frame I want, because the animations will override it in-game anyway. I take, for example, this one. I have the new enemy prefab selected, and here it has an animator component that exists because we duplicated the other enemy. I remove the animator component here. I double-click the prefab to make sure I have it open here like this. I see it in the scene view with the animation panel open here. My prefab is called FairyOrc, and I make sure it says to begin animating FairyOrc here. I click Create. I'm inside Assets Animations folder, and I create a new animation clip I call FairyOrc_walk_down. Inside Art Enemy folder, with my FairyOrc spreadsheet expanded, I find the walk down animation sequence. I left-click frame 79, shift-click frame 86 to select all the frames in between. I drag and drop all 8 frames onto the animation timeline, set samples to 8 to slow it down, and I play to test it to see if it looks alright. OK, create new clip, FairyOrc walk left. I drag frames 70 to 77, play to test it, 8 samples, create new clip, FairyOrc walk right, frames 88 to 95, drag them here, 8 samples, yes, this looks alright. Create new clip, FairyOrc walk up, frames 61 to 68. Drag it here, select it, play to test it, too fast, 8 samples. This is good. So we have 4 animations here for FairyOrc, our custom enemy type. Inside Assets Animations, we can see the 4 animation clips here. Unity also created another animator controller for FairyOrc, and if I click it, it will open the animator window like this. If you remember from before, we deleted those default states, and instead we created a blend tree with some logic that automatically decides which one of the 4 animation clips will play, depending on the parameters we called moveX and moveY. I could just follow the same process and recreate that blend tree for this enemy type here, but there's a faster way to do it. Let me show you step by step. I basically want to reuse the one from the enemy animator controller for all enemy types we are about to create. I'm inside the FairyOrc prefab here, and on the main object I find a new animator component that was created automatically when we created the new set of animation clips. You can see here it's connected to the FairyOrc controller. I want to connect it to the enemy controller instead, but I want to use these 4 FairyOrc animation clips we just prepared. Inside Assets Animations folder, I right-click and select Create Animation Animator Override Controller. That creates something called an Animator Override Controller. I'll call it, for example, FairyOrc Override, like this. If I select it and open the inspector panel, I drag the main enemy animator controller into this controller field. This controller has the blend tree with the parameters and logic we already created. We just want to override the base animations with custom ones that apply to FairyOrc only to this new enemy type. So as enemy walk down, we use FairyOrc walk down. FairyOrc walk left here, FairyOrc walk right here, and FairyOrc walk up here. Finally, still inside my FairyOrc prefab, I find its animator component, and in the controller field, I drag and drop FairyOrc override. And that's it. Now, FairyOrc has the same blend tree logic that checks the values of moveX and moveY parameters and automatically switches between up, down, left, and right animations. I have a spawner here, so let's create an object pool for this new enemy type. I duplicate one of these, for example the orc pool. and rename it to FerryOrgPool. From Prefabs enemy folder, I drag the FerryOrg prefab inside this prefab field. I open the spawner script. Up here, I create a new field for FerryOrgPool. Inside the dictionary, I associate the FerryOrg enemy type with this new FerryOrgPool. Now I have to go to the enemy type script and add that new enemy type inside the enum. Okay, now it works. All good. Back in Unity, with spawner selected, I see the new field here, so I drag and drop FerryOrgPool inside, like this. Now, inside Scriptable Objects enemy folder, I duplicate one of the enemy data files and rename the duplicate to enemy FerryOrg. 5 lives, 3 damage, min speed 1.2, max speed 1.5, and resource reward 2. In Prefabs enemy folder, with FerryOrg prefab selected, from Scriptable Objects enemy, I drag and drop enemy FerryOrg inside this data field, associating the data with the prefab. Now, inside Scriptable Objects wave folder, I duplicate one of the wave data files. I rename the duplicate to FerryOrg wave. I set its enemy type to FerryOrg here. Spawn interval 1.5, enemies per wave 5, and wave spawn clip. You can put any audio file here that you want, depending on what kind of enemy you created. Simply drag your own audio file here, and from this folder, drag it in here, in this field. Inside Scriptable Objects, level 1, we have this waves list. I put just one here, I press Enter, and I drag FerryOrg wave in here. Level 1 will be spawning this enemy wave over and over until we reach this waves to win value. On Level Manager, I make sure we have level 1 here first so we can play test it. If I press play, we get the new enemy type walking and following the path. And now the last piece of the puzzle, make them turn in the correct direction. I exit play mode. If you remember, here we already created that logic, and based on the parameters we called moveX and moveY, this blend tree will automatically decide if it should play walk down, left, right, or up. So all I have to do is to access these moveX and moveY parameters from my script and set their values to correctly represent the direction of movement. Everything else will be handled automatically here inside the blend tree in the animator override. I could calculate the direction of movement of the enemy on horizontal and vertical axes for every frame by constantly comparing its current position and its position from the previous animation frame. But in the case of a tower defense game like this, we actually only have to check the direction every time the enemy reaches a new waypoint along the path, because only then the direction of movement changes. So let's write that simple small script now. Inside Scripts enemy, I create a new MonoBehavior script I call Animate on Waypoint Change. I open the script and delete the comments. We will use the awake method here. Save that. In Prefabs enemy folder, with FerryOrg prefab selected, and I attach the Animate on Waypoint Change script to it as a component. I select the base enemy prefab, and I attach the script to it as well, like this. In the script, we need a reference to this animator component, so I create a field for it like this. Inside the awake method, I point it towards the animator using getComponentAnimator. I will also say, if there is no animator, return and end this function. Up here, I will need a vector3 field for last target. Inside awake, I set last target to something. I'll comment it out for now. Save that. Back in Unity, I open the enemy script. Enemy has a vector3 field called target position, where we keep the waypoint that the enemy is moving towards. I want to be able to access this target position from other scripts. So I expose it as a public property I call current target position. And it will always show whatever is the current value of target position. Save that. So this FairyOrg prefab has the enemy script component here and the animate on waypoint change script here. We will need a field for this enemy script component. I use getComponentEnemy here again, like this. And here we set last target equals to enemy.currentTargetPosition, the property we just created inside the enemy script on line 14. I create a custom method I call, for example, updateAnimation. It will take one parameter, type is vector3, and I call it target. Inside, we calculate the direction of movement of the enemy so that we can decide which of the 4 animations we need to play. Direction is the difference between the target position and the current position of the enemy. It's a vector3, so it will have x, y, and z components. Then I say, if direction x is more than direction y, mathAbsolute returns the absolute value of a number. It makes negative numbers positive while leaving positive numbers unchanged. If this condition passes, I take the animator component and I call the built-in setFloat method, where I set moveX and moveY to certain values. If you remember, moveX and moveY parameters are here, and their values will automatically decide which of these 4 animations to play. Let's write the next bit first. Else, we set moveX and moveY to some other values. I will write this first and we will explain it when we see the whole thing. I will come back to this in a second. As the game runs, for every frame, we will set current target to enemy current target position. So current target is always aware of the position of the waypoint the enemy is moving towards. If current target changed this frame, meaning the enemy reached a waypoint and started moving towards a different waypoint, we call this updateAnimation method, and we pass it the position of the waypoint the enemy is moving towards. This method will decide which value it should set moveX and moveY parameters to, so that the animator knows which of the 4 animations to play. After that, we set last target to current target, so that it's ready for the next upcoming waypoint change. Finally, I open the blend tree here, and we see the conditions for what moveX and moveY should be for each particular animation to play. And I set this and this to 0. So here, we're comparing the target position, that's the waypoint the enemy is moving towards, with the enemy's current position. That gives us a direction vector pointing from the enemy to the target. If the horizontal difference, or x direction, is larger than the vertical one, that means the enemy is moving horizontally. When that happens, we set the vertical movement to 0, because there's no up or down movement. Then we check whether direction x is positive or negative. If direction x is greater than 0, that means the target is to the right, so moveX becomes 1. Otherwise, it's to the left, and moveX becomes -1. This uses something called the ternary operator. It's just a short way to write an if-else statement. You read it like this. If this is true, do this. Otherwise, do that. Question mark for the true case, colon for the false case. Now, if we don't have any horizontal movement, meaning the y direction is stronger, we know the enemy must be moving vertically instead. In that case, we set moveX to 0, and then check whether direction y is positive or negative. If direction y is greater than 0, we're moving up, so move y is 1. Otherwise, it's -1, meaning we're moving down. Save that. And back in Unity, I playtest it. We have enemies walking along the path and animating in the correct direction. Perfect. Notice that they are not layered in any logical way. In a game like this, we want the enemy standing lower to be drawn in front of the enemy standing higher. I want to draw the enemies based on their vertical position. I exit play mode. I built this game using Universal 2D Render Pipeline, so I can go to Assets, Settings, and inside Renderer 2D, up here in the inspector, I set Transparency Sort Mode to Custom Axis. And by having one here, we are drawing based on the vertical position. Now we are drawing the enemies in a way that makes visual sense. This enemy that's lower is drawn in front of the enemy that's higher, that's behind it. Now that we understand how this works, let's create another enemy. I exit play mode. I duplicate my Fairy Orc prefab, and I rename the duplicate to Pixie Zombie. You can name this new enemy type differently, depending on what sprite sheet you created using the tool in the beginning. With my new prefab still selected here, I go to Assets Art, I expand the sprite sheet I want to use, and I drag any of these frames into the sprite renderer. It will just be the small preview for that prefab. We will override this with animations later. I go back to Prefabs, it has the new icon now, and I double-click it to enter the prefab like this. Inside the inspector, the animator component here, it has this one because we created it by duplicating the orc. I will completely remove the animator component. Unity will automatically add it again now as we start making animations. With the main parent game object selected here, inside the animation window, making sure this says to begin animating Pixie Zombie, or whatever the name of your enemy is, I click Create. I navigate to Assets Animation, and the first animation clip will be called Pixie Zombie Walk Down. Save that. From Art Enemy folder, I left-click frame 79, shift-click frame 86, and I drag them here. 8 samples to slow it down. Create new clip, Pixie Zombie Walk Left. I find the frames. I need 8 samples. Create new clip, Pixie Zombie Walk Right. Frames 88 to 95. 8 samples. Create new clip, Pixie Zombie Walk Up. Frames 61 to 68. 8 samples. So we have all 4 clips for the new enemy type. Inside Assets Animations, I can see the animation clips here, and it also created the Pixie Zombie Animator controller. I right-click in the empty space and go Create, Animation, Animator Override Controller. I will call it Pixie Zombie Override. I select it, and in the inspector, as a controller, I drag and drop the base enemy controller in here. Then I drag Pixie Zombie Walk Down here, Pixie Zombie Walk Left here, then Walk Right, and Walk Up. We have the override controller ready, so I can go to Prefabs Enemy folder, select my Pixie Zombie prefab, and instead of this animator controller that Unity auto-generated, I will replace it with Pixie Zombie Override we just set up, like this. We have a new enemy prefab ready. Inside the spawner, I duplicate one of the pools and rename the duplicate to Pixie Zombie Pool. I drag the Pixie Zombie prefab here. I open the spawner script. I create a field for Pixie Zombie Pool. And down here, I associate enemy type with the pool, like this. I also have to create an entry for this new type here in my enum. Back in Unity, spawner selected, and I drag Pixie Zombie Pool inside this new field here. I go to Scriptable Objects Enemy. I duplicate one of the enemy data files and rename the duplicate to Enemy Pixie Zombie. I set up some values here. It doesn't matter at this point. We'll balance it later at the end. I select my prefab and drag the enemy data file into this field on the enemy script component, like this. Inside Scriptable Objects Wave folder, I duplicate one of the wave data files and rename the duplicate to Pixie Zombie Wave. I select the enemy type here, set spawn interval to 2.5 seconds, enemies per wave to 5, and I will add some wave spawn audio clip. Use whatever sound you want, depending on what kind of enemy you created. Inside Scriptable Objects Level folder, I have a level data file for each separate level. So in level 1, I open the waves list and add one more element. As the first wave, I drag in my Pixel Zombie wave. I play to test it. Okay. We created that base enemy prefab, which in my case was using animations of an orc mummy. So how do we add that to our game? Inside Prefabs enemy, I duplicate my fairy orc and rename the duplicate to mummy orc. On it, I find the animator component. I'll try to put the base enemy animator controller in this field, because we know this is the one with 4 mummified orc animations. From Art Enemy, I drag one of these frames into the sprite renderer component here to get a preview. With each new enemy type, we'll need an object pool, so as usual, I duplicate one, rename the duplicate to Mummy Orc Pool, and drag the prefab into this field. Inside the spawner script, we create a field for Mummy Orc Pool. Inside the enemy type script, we declare that new enemy type in the enum. And inside the dictionary, we associate that new enemy type with that new object pool. Save that. I drag the new object pool into the field we just created. Inside Scriptable Objects Enemy, I duplicate one of the existing files and rename the duplicate to Enemy Mummy Orc. I give it some unique values here. Go to the prefab and drag the enemy data file into this field. Then I go to Scriptable Objects Wave, duplicate an existing file, rename the duplicate to Mummy Orc Wave, set it up as usual, and then go to Level 1 data file. Inside the waves array, I click plus to add one more wave, and drag Mummy Orc Wave in here. I drag it up for testing to make sure it goes first. I play. And we have orc mummies come in as the first wave. Perfect. So now I'll simply repeat the process we just learned as many times as I want to create more and more enemy types. To quickly recap how to create a new enemy, first I duplicate an existing prefab and rename the duplicate to the name of my new enemy. In my case, I created a sprite sheet for Winged Rabbit. I have it here, so I drag one of the frames into the sprite renderer field. I'm still on the prefab here, and I remove the animator component completely. It will be recreated automatically when I go to the animation panel. With the prefab selected, I create a new animation clip. I navigate to Assets Animations folder and create 4 animation clips. Winged Rabbit Walk Down, frames 79 to 86. 8 samples. Winged Rabbit Walk Left, frames 70 to 77. 8 samples. Winged Rabbit Walk Right, frames 88 to 95. 8 samples. Winged rabbit walk up. Frames 61 to 68. 8 samples. Inside Assets Animations folder, I go Create, Animation, Animator Override Controller, and rename it to Winged Rabbit Override. Controller will be this base enemy asset. Then I drag in new animations we created. Walk left, walk down, walk right, and walk up. In the spawner script, I create Winged Rabbit pool. In enemy type, I add Winged Rabbit. In the dictionary, I associate that new enemy type with its object pool, same as usual. Save that. I create the Winged Rabbit pool and drag the prefab in here. On the spawner, I drag the object pool into this field. Enemy type Scriptable Object. I call it Enemy Winged Rabbit. Values. Wave data file. I call it Winged Rabbit Wave. And I set it up like this. Then I open the level 1 data asset, go to the waves list, and add one more wave. I drag Winged Rabbit Wave in and move it up here so it goes first. Prefab selected. I associate the enemy data file with the prefab here. And on the animator, I drag the new override into this controller field. Play to test it. Now, if I want, I can repeat this process to create as many different enemy types as I need. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. I created another enemy type called Vampire, following the same process. If I play, and go back to the main menu, I can still press the escape key to toggle the pause screen on and off. I don't want the pause panel to be visible in the main menu like this. The pause panel should work only in gameplay scenes. To do that, I go to the UI controller script. This sits on UI canvas, which is a persistent object that doesn't get destroyed as we travel from scene to scene. Down here, inside the update method, we are simply checking if the escape key was pressed to show or hide the pause screen. I'll add another condition here, like this. Only if we press the escape key and the name of the active scene is not main menu, only then show and hide the pause panel. Save that, and if I play, there's one more small bug. This little text that says choose a tower is blocking part of the close button, preventing it from being clicked. The same goes for the title text on the pause panel. To make sure the close button is never blocked by the title text, I exit play mode, and inside pause panel title text, I uncheck Raycast Target. This makes sure the element is ignored by click and touch events. I do the same for title text on the tower panel, and just to be sure, I also uncheck Raycast Target on wave text, lives text, and resources text. We already know how to add a custom font, so let's change this to a nice pixel art font that better fits our game's art style. You can use any font you want. I'll use this free pixel art font, link in the resources down below. I download it and drag and drop the TTF font file inside Assets Fonts. I right-click the asset, then go Create, TextMeshPro, Font Asset SDF to create a font asset version that Unity can use. On the Game Manager, I drag the SDF font asset to the global font field here, which will set the new font for most of our game. The only few places I have to add the font manually are here in the main menu scene on main menu canvas, on its title text like this, and also on the text fields of both New Game and Quit Game buttons. Finally, we also need to do it on the tower card prefab, on its cost text. Let's create beautiful pixel art game worlds with tile maps. A tile map is a grid-based system used to build 2D levels quickly and efficiently. Think of a tile map like a digital sheet of graph paper. Each square of the grid is called a tile. You can paint these tiles with images like grass, stone, or water to create your game world. Unity's tile map system also works together with a grid game object, which keeps everything neatly organized. Let me show you exactly how this works. Let's learn how to paint game worlds with tiles. I'll use this tile map, which matches these pixel art characters really well. Link in the description down below. I download it and drag and drop the terrain PNG file inside Assets Art. I make sure sprite mode is set to multiple. Pixels per unit depends on what tile map you use. This one has each tile at 32 × 32 pixels. To keep the pixel art sharp, set filter mode to point no filter and compression to none. I click Apply, I open the sprite editor, and here I click Slice, Grid by Cell Size, and since this particular tile map uses 32 × 32, I enter those values. I click Slice and Apply. Now that we sliced it, you can see how it neatly divided the image into small tiles we can mix and match together to create world maps. Let's see exactly how that works. I go to Window, 2D Tile Palette. I usually dock this panel here on the right. Inside Assets Art, I create a new folder I call Tiles. With the tile palette window open, I drag my tile map image in here, like this. When Unity asks for a save location, I navigate to the new tiles folder I just created, and I select it. Unity will now create a special tile asset for each tile. Now we can use them to paint our game world. You can use tile assets like brushes inside the tile palette. Each one represents a small piece of your map, like a bit of ground, grass, wall, water, or decoration. I'll show you how exactly this works. I open the level 1 scene. I'm thinking of doing an animated magic mushroom forest here. Let's see what we can do. With pixel art, maybe I want to zoom out a bit and make the game area larger. On the main camera, we can normally zoom in and out by changing the value in the size field here. I'll go back to size 5. Because this is a pixel art game, we have another option to do this. Still on the main camera game object, I add component Pixel Perfect Camera. Our game will be 32 pixels per unit, and we set the reference resolution to match the pixel dimensions of our game's intended screen or camera view. I set it to 960 × 540 to keep the aspect ratio at 16:9. This gives us a nice crisp layout, big enough to show a lot of map area, and small enough to keep pixel detail clear. Down here, I can view this in a device simulator, rotate it horizontally, and choose one of the common phones, like Samsung Galaxy S10. This gives me a better idea how wide the visible area will be on mobile, which is not 16:9 anymore. I want to make sure I draw the game world far enough in each direction so it looks right on any device. Here I right-click, 2D object, tile map, rectangular, and I rename it to background. We will build the world from multiple layers of tile maps. This will be the layer all the way in the back. In this case, the background will be these dirt tiles. In this area, I can choose which tile I want to paint. And here we have a selection of drawing tools we can use. As you can see, Unity automatically selected the standard paintbrush, which will simply draw the tile I selected, like this. I also have an eraser here. I can delete tiles with it. With this one, we can paint a filled box with the active brush. I have this tile selected, so I can click and drag. It draws it like this. I make sure I draw my world well outside the visible game area. Maybe even more. We have the background layer. You can see Unity created this parent grid object, and it will hold all our tile maps. So I right-click Grid again, 2D object, tile map rectangular. I'll call the next layer Dirt. Here we'll draw some more details. I right-click Grid again and add one more tile map. I'll call it Grass. For the mushroom forest, I'll draw this dark night grass we have here. I have to make sure I always have the right tile map selected. I select the one I want to draw on. It can happen that Unity will draw the grass behind the background tile map, so we want to specify the draw order for each tile map. Background tile map selected. In the inspector window, sort in layer will be background. Order in layer is 0. Dirt tile map, background sort in layer, order in layer 1 in front of it. And grass, background layer, and order in layer is 2 in front of the two tile maps. Now I can finish drawing the grass blocks. I'm using the filled box tool, and I want to basically cover it like this. Eraser tool now. The start of the path will be from here, so I delete some grass tiles, which reveals the background layer underneath. Now I'll draw the grass to create a path through the level. I think I'll keep the path 3 units wide for now. I will go down and up like this. Then to the right, down, left, down, and right. Maybe I'll add more grass here. And with the eraser tool, I remove some grass here. Feel free to design your level however you like. I think I'll do this. And this. Make the path wider down here, and cut through the grass here, where enemies exit the level. I know I have my path and my waypoints, and they don't match the new path at all. We will deal with that in a minute. Now we have side and corner pieces. Tile maps are carefully designed in a way where we can mix and match any of these pieces, and they will always seamlessly connect to create any shape we might need. I take this bit, the right grass edge, and I'll draw it here. It's a bit easier with the filled box tool, like this. We also need the right grass edge here, here, and here. Now the left edge, which will go here. Eraser tool to clean this up. The left edge will also go all the way up here. Now we have these corner pieces, so I paint them like this. Top edge and inner corners are here. They work like this. Left edge here. Corner. Top edge. Corner. Another corner. And some bottom edge grass tiles. Inner corner will connect it like this. I'll continue this for a little bit longer to create seamless edges around the grass tiles. There's a way to do this in a more automatic way with so-called rule tiles. It's worth using it if you're doing many levels that are quite generic. In our game, each level will be completely unique, using different textures and environmental assets. Rule tiles are more suitable if you need to create many more generic levels. Let's do it in a more detailed, handcrafted way. Let me show you how I like to do it. When I'm happy with my grass and all the edges, we'll use this tile map I called Dirt to add more details that are in front of the background texture but under the grass. I make sure I have the tile map I want to draw on selected here, and I can also select multiple tiles at the same time. They'll be drawn like this. I'll put another dirt patch here. I make sure it looks good in the game view. I can also give more detail to this corner. Now bottom dirt tile edge selected, filled box tool, and I'll drag it all the way here, under the grass edge. I'll draw the top dirt edge here, like this, in a corner like this, and I'll do something here. I make sure the visible parts connect seamlessly. I select the lighter dirt patch now and draw it here, maybe like this. More can come here under this corner. I select them like this and drag all the way up here. I'll draw some more on the dirt layer, creating some nice handcrafted details. Feel free to draw it completely differently, use your creativity. This particular tile map also has some details for this central dirt tile. We use it to draw the entire background layer, so if I want some more diversity, not just a single repeating tile, I select the background tile map and I'll sprinkle these details around the visible area. We can also flip the tiles horizontally or vertically using these tools if we want to break the pattern even more. When I'm happy with that, let's select the grass layer and look at these small separated pieces of grass. We can also sprinkle them in. Maybe the small one can go here and here. The bigger one could be in the corner here. I can flip it and put one in this corner too. I'm just working with my tile map layers and adding more details to make the world feel more interesting. For now, I'll disable the path to hide it, and I'll also hide the platforms. Keep in mind we have to enable them before entering play mode, otherwise the game will throw an error saying it can't find them. With the grass layer selected, we have these 3 tiles with some grassy details. So again, I can sprinkle them around to break the pattern. Now I want another layer. It will be objects that just lie around on top of the grass. I right-click Grid, 2D Object, Tile Map, Rectangular, and I'll call it Ground Objects. It will be on the background sorting layer. Order in layer is 3. On this layer, I can only draw things that have a transparent background, like these straws of grass. I can even draw them on the boundaries between the different tile layers like this to kind of merge it all together. These are all small details, but in the end, it adds up. This is how handcrafted levels are made. We care about little details. I can even put these pieces of grass on the ground objects layer. And here they can partially or fully overlay with the grass layer, for example, like this. I put more here. Again, I can flip the tiles horizontally or vertically if I want. We have a lot of loose objects here in the corner as well. Maybe I'll draw some of these. I make sure they match and fit well with our current tiles. I place some stones. I'm still on the ground objects tile map. This looks alright, I'm happy with it. We'll add more objects, stones, plants and mushrooms, but those will be done differently. Tile maps are basically just the flat ground that enemies will walk on. Now that I have a proper path for level 1, I can enable Path 1 game object again. I expand it, select the first waypoint, use the Move tool, and I move and align the waypoints one by one to follow the path. We need one waypoint in each corner. The enemies will go from waypoint to waypoint, from corner to corner, following the path. Let's see what it looks like in the simulator. I need to make sure the last waypoint is outside the visible area, even on white landscape device screens. I have a few extra waypoints I don't need, so I delete them one by one. And on the Path 1 game object, in the waypoints array, it created these empty slots, so I have to change this number and press Enter to match the number of waypoints we actually have. To make sure I align the waypoints well, I can even manually set their X and Y positions here if I want to be extra precise. Now we also want to distribute the platforms where the player can place towers all around the new, bigger path. Main wrapper platform game object selected, And I reset transform, so its position is 0, 0. I select the first platform, Move tool, and I put it somewhere here. I can go back to the normal game view down here. Keep in mind we'll have relatively tall towers on each platform, so I make sure I give them enough space. I can distribute them randomly, or I can align them perfectly in relation to each other by setting their position values manually here. Before I finish this, let's actually give the platform some art instead of this yellow square. I have another sprite sheet with pixel art towers. You can download it in the resources section down below. I drag it into my art folder, pixels per unit 32, filter mode set to point no filter, compression to none, and click apply. I open the sprite editor, and you can see we have a lot of different towers we can use, but also this platform image, which I need now. I go to Slice, Grid by Cell Size. Pivot will be bottom. We need this so that the towers align in front of or behind other objects in a way that makes visual sense. I'll show you that a bit later. I click Slice. Actually, the pixel size here is 96 times 96. Slice that and apply. Now I can expand it, and I have each tower sliced into its own frame. Perfect. On the platform prefab, I drag this frame into the sprite field, and our platforms look much better. Now each platform is a flat stone block that we can build a tower on. Now that we can see the actual art we'll use for the platforms, it's a bit easier for me to place the rest. I just select them one by one, and using the Move tool, I place them all around the map, in places where I want the player to be able to place towers. And now I select them one by one and start placing along this line. I want the placement to be a little bit organic. I'm placing them in a slightly misaligned way on purpose. Maybe some here on the right. And I place the rest of them down here. Yes, this looks fine. Feel free to place your platforms however you want, but keep in mind there could be a relatively tall tower placed on each one, so space them out accordingly. I move this one a bit down, away from the top edge of the map. I tweak these positions, save changes to the scene, open the main menu scene, and enter play mode to test it. Enemies are spawning from the old position. I exit play mode, open the level 1 data asset, and here in the initial spawner position, I put some values that account for the larger, expanded visible game area. Let's try these values. Yeah, this will work for now. Enemies are spawning, animating, and walking along the path. If I place towers, we can see this is still using the old placeholder art, but we'll fix that soon. First, I exit play mode. And inside Assets Art, I create a new folder I call Environment. I'll take this asset pack, link in the resources down below, and I drag and drop these 4 sprite sheets from it. With all 4 of them selected, I set compression to none, filter mode to point no filter, and pixels per unit to 32. If I expand it, I can see Unity auto-sliced it, which is fine for us. I open the level 1 scene. With the giant fungi sprite sheet selected, I open the sprite editor. I'll keep the type of slice on automatic, but I need to set pivot to bottom for correct layering. Slice that. Yes, pivot is at the bottom, at the foot of each mushroom. I click apply, close that. Next, giant plants sprite sheet. I open sprite editor, slice automatic, with pivot set to bottom. Slice and apply. I do the same thing for the giant trees sprite sheet. And for the viney trees sprite sheet as well. The auto-slice boxes are a bit off on this one. I'll show you how to fix that later when we need these. From the expanded sprite sheet called Giant Fungi, I drag some of these into the scene. Unity is creating a game object for each one, which is exactly what we want. I drag these 4 into the scene, select all of them here, and under sorting layer, actually, let's add a new sorting layer by clicking the plus icon here. I'll call it Sorted Objects. On this layer, I'll put everything that needs to be sorted based on its vertical position. This will make sure that the mushrooms and also the enemies layer correctly in front and behind each other in a way that makes visual sense for a game like this. I'll place the Sorted Objects layer just behind UI, like this. So with all 4 giant fungi selected, I set Sorting Layer to Sorted Objects. I select all of them and copy and paste to duplicate them. I want more mushrooms. I can move them like this, and I can also flip them horizontally by ticking this checkbox, which makes them look slightly different from the first set. Now I'll take them one by one, and using the Move tool, I redistribute them all around the game map. Place them wherever you want. You can always move them around later. Now I select all 8 of them, and I can tint them to better fit the environment by clicking this color field. I use the eyedropper tool, choose the dark grass color, and then drag it slightly toward white to get just a little tint, making the mushrooms and tile maps blend better together. So this is my Night Forest mushroom map. It's starting to look pretty great. If you want, you can also place some of these other smaller mushrooms. I'll go to the other sprite sheet called Giant Plants, and I drag plants that I like into the scene, same as we did with the mushrooms. This is a really nice sprite sheet, top quality pixel art right here. I select all of the giant plants and put them on the Sorted Objects sorting layer. Now I select all giant fungi and all giant plants, and on all of them I set sprite sort point to pivot. When we sliced the sprite sheets, we placed their pivot points to bottom center, so that point will be used when Unity decides what is drawn in front and what is drawn behind. This makes sure the layering looks right. Now I take the giant plants one by one, and using the Move tool, I place them all around the map. Again, we can move them around later as well if we want, so it doesn't really matter where exactly we place them right now. I place them all around the map. The goal is for the mushrooms, plants, enemies, and towers to all layer in front and behind each other in a way that looks right. That's why we did everything around the pivot points. I select all giant plants and tint them, same as we did with the mushrooms earlier. In the hierarchy, I create a new game object called Environment. I'll put all mushrooms and plants under it, just to keep the hierarchy clean. Save changes to the scene, open the main menu scene, and let's play to test it. This is how I like to create a proper handcrafted level. We placed everything by hand, all the tile map layers, we chose world objects, and we made it all blend together to create a perfect pixel art mix. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. Inside Assets Art, I drag and drop an image I'll use for tower projectiles. You can download all art assets in the description down below. Pixels per unit is 32. Filter mode is point no filter. Compression is none. I click Apply. I find my projectile prefab, and it has this sprite field here inside its sprite renderer component. From the art folder, I drag and drop the new projectile image in here. If it's black like this, it's because of the tint we applied earlier. If we want to see the original image, I set this color field to white, which means no tint. I save and play. And now the towers are shooting these new, more detailed projectiles. The sizing might be a bit off. I exit play mode, and on the projectile art asset, I set pixels per unit to 64 to make it smaller, fitting more pixels into a single unit in the game grid. I click apply and play again. New game. Let's place some towers. Yeah, now the size of the projectiles is what I actually want it to be. Given a different value to the pixels per unit field on the image asset is one of multiple ways we can scale things up and down in our game. Ideally, you want to have art that's the right size and compatible with the other art assets, but we can always work around it like we just did. If I go to Prefabs, Platform Prefab, you can see the box collider down here. Only in this area the platform detects clicks. We need to reposition it to align better with the image. I do it here on the box collider component by adjusting the values of these fields. I can resize it using the size fields and move the collider around relative to the platform using the offset fields. Something like this seems much better. We can always change the clickable area on the platform later by coming back here and tweaking these values. I go back to the main menu scene, Burst Tower Prefab selected, and from the art folder, here in the towers sprite sheet, I choose one of the towers I want to use. Actually, we have to fix the pivot, so I select the art asset and open Sprite Editor. Slice, grid by cell size, 96 times 96, pivot bottom, slice, and apply. Back to Prefabs, Burst Tower Prefab, and from the art folder, I choose one of the towers. Burst Tower shoots many projectiles fast, so I'll choose this tower with many windows. I drag that sliced frame into the sprite field on its sprite renderer component, as usual. Prefabs folder and Fast Tower Prefab selected. From the art folder, I drag any tower that I like into the sprite field on the prefab. I'll use this one. Back to the Prefabs folder. Strong Tower Prefab selected, and from the art folder, I'll use one of the big cannon towers, because this tower shoots large projectiles slowly. Okay, so our tower prefabs now have visuals here in the folder, and if I play, and if I place them, they'll also use those sprites in the game, like this. You can see that the layering isn't ideal yet. I exit play mode. On Burst Tower Prefab, Sprite Renderer component, I set Sprite Sort Point to Pivot. I do the same thing on Fast Tower, Platform, and also on a Strong Tower. I play again, and it doesn't work yet. I exit play mode again. I have to do one more thing. On Burst Tower, I set its sorting layer to Sorted Objects. Plants and fungi in the game also have their pivot set to bottom, their sprite sort point set to pivot, and they're on the Sorted Objects layer. So now it will work. I also put Fast Tower on the Sorted Objects layer, Platform. And I do the same for the Strong Tower. So all objects that I want to be sorted correctly should be on the Sorted Objects layer. I play to test it. Let's place the towers all around the map and see if they appear behind and in front of each other, and the other plants and mushrooms in a way that makes visual sense. We got it. Notice that the platform itself sometimes stays behind the tower, sometimes Unity decides to draw it in front of the tower we placed. Ideally, I want to completely hide the platform sprite once a tower has been placed on that platform. I exit play mode, find my platform script, and I open it. Basically, I want to disable this entire sprite renderer component as soon as a tower has been placed on this platform, which will hide the platform image. Also keep in mind that when a tower is placed on a platform, in the Unity hierarchy, the tower is a child object of the platform. The tower is nested under the platform. This makes this check very easy. Up top here, I'll need a field for the sprite renderer component, so we can disable it later. Inside the awake method, I use getComponent as usual. Down here, we have this placeTower method. It instantiates a tower prefab, whichever tower we decided to place on that platform, and it sets this platform as the parent of that new tower prefab. That's what this transform parameter means. It's a bit weird, but this transform means set this game object that this script is attached to as the parent of the prefab you're instantiating. Once we place a tower, I can simply take the sprite renderer component, access its sprite field here, and set it to null. This will hide the platform image. I save and play to test it. I place towers, and platform images are being hidden. All the towers, mushrooms, plants, and empty platforms appear correctly in front of and behind each other as they should. This is good. I also want one more feature. When I hover over an empty platform, I want the shadow of a tower to appear as a visual indication to the player that the platform is interactive. I want to dynamically swap between the original sprite, which is the flat stone platform, and the tower placeholder sprite, this ghost tower. I create fields for both. This one will be a serialized field, so that I can set up which sprite I want to use inside the Unity inspector. Save that. I'm on the platform prefab. Here I see the serialized field I called tower placeholder sprite. So from the art folder, I drag this frame in, the semi-transparent ghost tower. Back in my script, inside the awake method, the original sprite will be set to the sprite the platform prefab has initially, this flat rock base. Now, my goal is that if we hover over empty platforms with the mouse, it will swap the original sprite with the ghost tower sprite to indicate visually that the platform is interactable. We know that a tower is placed as a child object of the platform, so a platform without a tower has no child objects. If transform child count is equal to 0, we know this platform has no tower on it. So I check where the mouse cursor currently is. Mouse world position is equal to camera main screen to world position, which means convert the mouse screen position to world coordinates. And I pass it mouse current position read value, like this. Then we'll use raycast hit 2D to raycast from that mouse position to check if there's a platform underneath it. So this line casts a 2D ray at mouse position in world with 0 direction, only checking against object on the platform layer. It casts a ray from that position into the scene to detect what the mouse is over. If the ray hit something, and that thing is this object, we change this object's sprite to the tower placeholder sprite. Otherwise, we restore the original sprite. Save that, and let's play to test it. Now, when I hover over platforms, the sprite changes to indicate to the player it's interactable. When we move the mouse outside the platform area, the original sprite is restored. Implementing this helps by giving players clear visual feedback when they hover over a valid placement area, making interactions more intuitive and improving the overall gameplay experience. The projectiles are coming from the bases of the towers. Maybe I want to move that point from which the towers shoot a bit up. Maybe by 1 unit to keep it simple. Inside the tower script, here, inside the shoot method, where we set the position of the projectile, its position will be the position of the tower plus vector 3 up, which is a shorthand for the vector 0, 1, 0. It represents a direction pointing upward along the y-axis. Save that, and now the towers are producing projectiles from 1 unit above their base. We can get back to this later. For example, if we want each tower to produce projectiles from a different point, depending on its sprite sheet. That would also be quite easy to implement. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. We can click a platform, we get a Choose a Tower pop-up. I want that window to display previews of the actual towers. It's being pulled from the Scriptable Objects we hold here in the Towers folder. So I select the burst tower data file, and I need to put some image I want displayed on the card into this sprite field. From the art folder, I drag this frame in. If you used different sprites, then use those to make sure this sprite matches what your tower prefab actually looks like. I drag it into the sprite field. Fast tower data asset selected. And I drag this frame here. And finally, the strong tower data asset. And I drag this frame in. I will leave Projectile on the tower's sorting layer, behind the actual towers, which are all on the sorted objects layer. I enter play mode. And when I click a platform to select which tower I want to place, each card now has an image representing its tower. Let's use a more suitable mouse cursor. I drag and drop cursor hand file into the art folder. You can use your own cursor or download and use mine. I'm using a small cursor image, 32 × 32 pixels, because if we want to create a playable web build, the cursor will render in the browser at its actual size, so we need to use a small image here. I select it and I set texture type to cursor, filter mode, point no filter, compression none, and I apply. Now I go edit project settings, and I drag the new cursor into this field. Close that, save and play. Okay, the new cursor is working well. I save changes to the main menu scene, and I open level 2 scene. And I see all my platforms are black. There is something wrong here. I take one of the tower prefabs, which I know is on the same sorting layer as the platforms. It's also black, like this, so it's pretty clear there is an issue with our scene light. If there is no light hitting this layer, we will just get black shapes like this. So I go to find my global light 2D game object, which is scene specific. Each scene has a separate one. And here, in target sorting layers, I can see sorted objects layer is not checked, which explains why platforms and towers are black. I just make sure I select everything here, and now the global light illuminates all sorting layers, and platforms and towers render correctly with colors. Let's do the same thing we did in level 1 scene, create a custom handcrafted pixel art level. We will follow the exact same steps. I delete the background image. I give the main camera a new component called Pixel Perfect Camera. Pixels per unit set to 32 and reference resolution 960 × 540. I click 2D object tilemap rectangular. I will call the first tilemap background, and Unity also created the grid object. I open Device Simulator just to see how far I have to go to the sides to make sure the tiles cover even wide landscape devices. I open my tile palette window. You can open it by going to Window, 2D, Tile Palette. This will be a volcanic lava level. I want dry trees, ash, and smoke. So the background layer will be this black ash-covered ground. Using the Fillbox tool, I drag a rectangle, and I make sure it's larger than the visible game area. I right-click the grid, game object, 2D object, tilemap, rectangular. And I call this tilemap paths. I want to create a rocky path the enemies will walk along. For now, I will disable Path 1 game object and platforms, just to keep my drawing board clear. Let's get creative and have fun drawing pixel art game worlds. I encourage you to experiment here and create your own map. I will use this dark dirt texture to draw a path. I make sure I have the path style map selected here. I select all 3 tiles vertically like this, and I selected the brush tool here. Now I can draw the path going to the right like this. Inspector window, background tile map will be on the background sorting layer, order in layer 0. Paths tile map will be on the background sorting layer as well, order in layer 1. I draw the path further to the right, and here it will bend down. So I use the corner tiles. If you use this for a while, it becomes very easy to know which tiles to use to get the seamless shapes you want. I can also select 3 tiles horizontally now, like this, to draw the path going down. I make sure I'm in the game view here, so I know where the visible game area ends for the most common 16:9 ratio screens. I will put the most important elements inside this area. Again, I have a corner here, and I will drag the path all the way to the right. I see the game area here, and I made sure all the main game action will be visible within this area. I have some extra tiles here to break the pattern of the central dirt tile. I just sprinkle them around the middle of the path to introduce some diversity and break the pattern. I can flip the tiles horizontally or vertically here to change it up if I want. Okay, so level 2 is a dark dirt path going over scorched lava land. I right-click, Grid, 2D Object, Tile Map, Rectangular. We will need some smoke in lava lakes. I take the central lava tile, Fill Box tool here, Lava Tile Map selected, and one lava lake will be here. Sorting layer is background, order in layer is 2. I make sure I'm still on the lava tile map, and I draw another lava lake here. Make this one go all the way to the end, and I draw the edges and corners. Also for the other lake. We have some extra tiles for the lava here. I guess these indicate extra hot spots, so I sprinkle them in. Later I can make smoke rising from these particular places using particle systems. We also have these little puddles of lava. I put some here, a larger one here, flip it, and put it here. Okay, this looks good. I right-click, Grid, 2D Object, Tile Map, Rectangular. I will call this tile map Ground Objects. Sorting layer is background, order in layer is 3. I make sure it's selected here, and I place some of these loose lava stones all around. I can even put them on the boundary between the ash and the path to blend the layers together. Smaller stones here as well. I can flip them horizontally if I want. I can also take some of these grey stones and scatter them around the map. I want some trees. Maybe this nice pixel art baobab pack is quite unique and interesting. Link in the resources down below as usual. I will use these 2 sprites from this pack, and I drag baobab full and baobab trunk into my art environment folder. Both of them selected, pixels per unit 32, filter mode point no filter, compression none. I select the first one, open sprite editor, slice automatic, pivot is bottom, that's important, slice, and I click apply. As you can see, the automatic slice didn't do a great job, so I move the box here to cut out just this one tree. If I grab this small anchor point, I'm dragging only one box. I need to make sure I'm resizing both of these boxes. I also resize this box. I can also always draw a new box like this. I make sure it crops exactly what I need. Then I click apply. Notice this pivot point is at the bottom, but this one is in the center, so I have to set it to bottom center. I crop this one as well. I need to zoom in because they are so close together. Bottom center pivot, apply. This will be enough of the leafy ones. There will be a small area of the map where trees have leaves, but most of the trees will be dry, leafless trunks. I expand the sprite sheet and I drag the trees I want into the scene. I select Platforms object and enable it. I kind of need to place the platforms first, so I know where they are before I decide where to place the trees. So I take platforms one by one, and I use the Move tool to place them along the path. Feel free to place your platforms wherever you want. This should be enough. I will delete some of the platforms. I don't need so many here. This looks pretty good. I enable Path 1 game object, and I move the individual waypoints to match the path I drew. 4 waypoints I have here work well for me, but if needed I can add more or remove some. I'm editing their X and Y position values manually for extra precision. Using the simulator, I make sure the first and the last waypoints are outside the visible landscape wide mobile screen area. Back in my game view, in my art folder, I have this one sprite sheet called Baobab Trunk, leafless baobab trees. I open Sprite Editor and slice, automatic, pivot is bottom. I can resize this box and click Apply. Now I drag some of these leafless trees into the scene. I select all of these trees in the scene and set sorting layer to sorted objects. Now I select them one by one, and using the Move tool, I place them all around the map. I select all trees again, and for correct layering, I set sprite sort point on all of them to pivot. Now the bottom of the tree is the point that gets compared to other objects' pivot points to decide which one is drawn in front of the other. The corner here will be leafy green area. I put all of the leafy trees here. I select all the leafless trees and duplicate them. The duplicate set can be flipped horizontally so they look different. I take them one by one and place them all around my map. The lava is producing scorching heat, so the trees too close to the lava pool will have no leaves. I have a level that looks like this. I create an empty game object, I call it environment, and I nest all the trees under it to keep it organized. I save the changes to the scene. I open main menu scene and I make sure in level manager, inside all levels array, level 2 comes first for testing. Scriptable Objects, level 2 data asset, and I set waves to win to 3. Here we have the waves array, which determines what enemy waves will spawn in level 2. So from Scriptable Objects wave folder, I drag 3 enemy waves into the waves array here. I also have to move spawner coordinates to -26 and 4. I save and play. My vampires are coming, following the path. We have ash, we have lava, and we have a bunch of dry trees with no leaves. All the sprites seem to be layering correctly in front and behind as they should. Except for enemies. I exit play mode. I select all my new pixel art enemy prefabs, and on all of them I set sprite sort point to pivot and sorting layer to sorted objects. I also have to do this for health bars. I double-click the enemy prefab to get into prefab view, select the health bar, and I set its sorting layer to sorted objects. Order in layer is 1. I enter the next enemy prefab, select its health bar, and set its sorting layer to sorted objects. Order in layer to 1. I do this for all my enemy prefabs. We now have a mushroom forest level and a hot lava level. The challenge for you is to come up with a unique level and design level 3 yourself. I will turn mine into a foggy, thick rainforest level. I open level 3 scene. I can see my Global Light 2D is not illuminating one of the layers, so here in Global Light 2D, I set target sorting layer to everything. I delete the background image. On main camera, I add Pixel Perfect Camera component, pixels per unit 32, reference resolution is 960 x 540. I disable Path 1 and Platforms to temporarily hide them. I right-click, 2D object, tilemap rectangular. I will call it background. Let's try these tiles for a change. I will need the filled box tool, and I make sure it goes far enough outside the visible area while I'm in the white landscape mobile phone simulator. I right-click Grid and create another tile map. I call it Grass. On that tile map, let's choose this nice green grass. We are building a rainforest level. I draw a rectangle of grass. Background tile map will be on the background sorting layer. Order in layer is 0. Grass tile map on the same background layer. Order in layer 1. I make sure I'm on the grass tile map and finish drawing my grass. Using the eraser tool, I cut a path through the grass. I make sure I'm in the game view. This turn needs to be visible on the screens with 16:9 aspect ratio. I give my grass some edges all around, as usual. I want to end up with something like this. On the background tile map, I use all these tiles to create more irregular, natural-looking patterns. I will play with it for a while. Now I can use these extra grass details on the grass tile map. I right-click Grid again, create a new tile map, and I call it Ground Objects. On the grass layer, I can also add this lake. It has grass tiles already around it, so it can be on the grass layer. I add a few blue water puddles. Ground Objects tile map. I choose something from here, tiles that have a transparent background. This tile map will be on background sorting layer. Order in layer is 2. I add some stones. Maybe a few more details on the grass tile map. I find my Viney Trees spreadsheet. We download it and import it earlier, and I open Sprite Editor. I go Slice Automatic, Pivot Bottom, then click Apply. This box is clearly wrong, so I resize it, Apply, then Close. The person who made this spreadsheet didn't put enough space between individual trees, and that's why Unity is struggling here with automatic slice. I drag and drop all the rainforest trees I want into the scene. I create an empty game object. I call it Environment, and I nest all the trees under it. I reset its transform. Again, I will need to enable path first and position the waypoints properly before I clutter my scene with extra objects. I delete the extra waypoints and also remove them from the waypoints array here. Otherwise, I would get an error if I leave empty slots. I enable platforms and I drag them one by one to position them along the path, in all places where I want the player to be able to place towers. Now that I see exactly where the platforms are, I can place the trees. I select all the trees and put them on Sorted Objects sorting layer. I set Sprite Sort Point to Pivot on all of them. I will need more trees, so I duplicate them. I select the duplicate set and flip it, so they look different. I take the trees one by one and position them around the visible game area. I want to create a thick rainforest, but I make sure all platforms are at least partially visible, and none of them are completely hidden by the trees. If I need more trees, I simply duplicate the existing ones. I check what it looks like on a landscape mobile screen. This is all right. I save changes to the scene. I open main menu scene. On Level Manager, I make sure Level 3 goes first, just for testing. I open Level 3 data asset and move its spawner to a position outside the visible game area, somewhere that makes sense based on how we drew the path that leads through the level. I make sure I have some of my new enemy types in the waves array. And I play the test state. I check if all the platforms are interactable and at least partially visible. I want this level to be a thick rainforest, to have some unique, interesting spaces in our game, but it still needs to be playable. We will also add some animated particle effects here to fully bring the rainforest to life. I exit play mode. We can also decorate our main menu scene. Main camera, game object. I add pixel perfect camera, 32 pixels per unit, 960 x 540. I right click, 2D object, tile map rectangular. Yes, we can also create tile maps in main menu. I call it background, and the entire background will be this ground texture. I make sure I'm in the mobile phone simulator to see how wide I have to draw it. Main menu canvas will be on UI sorting layer. I create another tile map, make sure it's nested under the grid, and I call it rocks. I choose this black volcanic rock and draw it in the corner. Again, I place all the tile maps on background sorting layer and give them order in layer 1 and 2. I draw the edges of this layer. Another tile map I call grass. Put it on background sorting layer, order in layer 2. And draw the grass edges. One more tile map for our mushroom level. I call night grass. Here I draw the darker grass and leave some dirt visible between the layers like this. I draw the edges. One more tile map for ground objects. And one more tile map for water. They will go in this order. Water, background sorting layer, order in layer 4. Ground objects, background sorting layer, order in layer 5. Water tile map will have these water tiles, and I draw the grass edges. Another puddle here and here. Still on the water layer, I put a lava lake in this corner and paint the edges. Background layer selected. I put this tile all over and draw some details using this set of tiles. I make sure the details are seamless and that the edges connect. Rocks tile map, I add some details to break up the repeating pattern. Water tile map on the lava, I add these hotspots. On the water puddles, I can add some of these details as well. Grass tile map, I can use some of these details. Night grass tile map has these tiles for extra details. Ground objects tile map, on top of all other tile maps, I add these tiles with transparent background. Dark grass bits here. Light grass pieces there. Some lava rocks around this area. When I'm happy with all my tile maps and detailing, I go to Art Environment folder, drag some trees, duplicate them, flip 2 of them, and I put all 4 on Sorted Objects layer. I create an empty game object I call Environment to put all of these under. For my rainforest corner, I drag viney trees from this sprite sheet, sprite sort point pivot, all go on Sorted Objects layer, all go under Environment object, and I spread them around. I create some duplicates again if I need more trees. I will need some mushrooms for my night forest corner here. Sprite sort point pivot, Sorted Objects layer. I duplicate them if I need more, and I flip the duplicates. I also add some giant plants and repeat the process. We know how to do this by now. I'm in white landscape mobile view. In the standard 16:9 game view, the area is not as wide, so I adjust some of these. We have a really cool handcrafted main menu. And there is one thing that would really bring this scene to life. Let's add different types of animated particles. With Unity, it's so easy. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. There is a lot going on in this scene, so let's create a new blank scene so we can work on our particles in a clean workspace. I'm inside Assets Scenes. I right-click, Create Scene, and I'll leave the name as New Scene. That's fine. I open the new scene, and to create a particle system, I simply right-click, Effects, Particle System. Unity creates a base particle system like this. I rename it to Fog, and I will reset transform, which also changes its rotation, so the particles are now shooting in all directions. Here we have a particle system component where we can do absolutely anything you can imagine and more. Let's get familiar with it by actually using it. My Unity project is using the universal 2D render pipeline, but when it comes to particle systems, the pipeline doesn't change how they fundamentally work. Unity's particle systems behave the same in both 2D and 3D projects. I keep duration at 5 seconds and make sure looping is checked. I set start lifetime to random between two constants, between 10 and 20 seconds maybe. We can scale the particle shapes using start size, but in this case I want to stretch them horizontally, so I want to scale X and Y separately. To do that, I check the 3D start size checkbox and again use random between two constants. X is 5 to 10, Y is 0.5 to 2. Max particles is set to 200. Inside the emission module, rate over time will be random between two constants. Let's try 2 to 5. We can also create bursts, but I will use that later for the mushroom spore particles. I turn on the velocity over lifetime module, random between two constants, and I want the fog clouds to drift to the left. X is minus 0.15 to minus 0.4, Y minus 0.02 to plus 0.02. This didn't give us any visible effect because start speed was too strong. So I set start speed to random between two constants, minus 0.2 to minus 0.5. I also set start lifetime to 3 to 5, so we don't have too many active particles at once, just for now. The shape module controls where and how new particles are spawned. I set it to box, and you can see that small box here in the middle. I want the fog particles to cover a larger area, so I scale the X and Y fields. You can see how it resizes the box from which the particles spawn. We will tweak these values later to exactly match the area in our game scene. So this shape module defines the emission area. If we want to change the shape of the actual individual particles, we go down to the renderer component and do that in the material field. You can use your own sprite if you want the particles to look very specific. For example, like this. But for our needs, we can use one of the default materials that come with Unity. I will use default particle or maybe default particle system. They look very similar. Now we notice that the particles pop in and out of existence, so we want to animate their opacity. I activate the color over lifetime module to do that. The bottom breakpoints define the color the particle starts and ends with, and the top of this bar represents opacity, alpha, how transparent they are. When the particles spawn, I want them to be invisible, so alpha will be 0. I click somewhere here to create another breakpoint, and here alpha is 255, fully visible. Another breakpoint here is also full alpha, or maybe I don't want full alpha. Maybe 200 might be fine on these two breakpoints to keep the fog semi-transparent at all times. The end breakpoint, just before the particles are removed, will animate to fully invisible, alpha 0. I activate the size over lifetime module, click the size curve, and down here I can try different predefined curves to see how it looks. I'll go with this one. I can stretch them even wider horizontally here. Feel free to tweak these values to get any effect you want. I make each particle cloud last longer, between 5 to 20 seconds. I can also adjust color over lifetime again to make them more transparent by adjusting alpha on these breakpoints. If you want, you can keep tweaking this effect to create something unique. How do I actually use it in my game? Inside the Prefabs folder, I create a folder called Particles. I drag the fog particle system into it to turn it into a reusable asset. I save changes and open my rainforest level scene. I drag the fog prefab into the hierarchy. It's drawn behind the pixel art, so I set sort in layer to UI. Order in layer is -1, so the particles will be drawn on top of everything, but behind the game's UI. Here I can also adjust the shape, the area from which particles spawn. I reset transform to center it. If I want to adjust horizontal and vertical stretching of the particles, I do that here. I can also add that particle system to my main menu scene if I want. I delete this and create a new particle system. I right-click, Effects, Particle System. I rename it to Smoke. Notice the rotation is -90 degrees by default, but if I reset the transform, particles now move in all directions. Start lifetime will be random between two constants, 2 to 3 seconds. Start speed will be between 0.1 and 0.25 units per second. Start size is a random value between 0.3 and 0.6 units. Max particles 200. Down here in the renderer module, I choose a material. This determines what the individual particles look like. I'll choose default particle or default particle system. Emission will be random between 8 and 15. The shape from which particles are emitted will be circle. Since this is a 2D game, the radius of that circle will be 0.1 because I want the source of particles to be a small concentrated area. Velocity over lifetime set to random between two constants, horizontally 0.05 to 0.15. Vertically, we want the smoke to drift upwards, so 0.3 to 0.6 units per second. We can add noise for extra chaos, play with strength, frequency, and scroll speed to get something you like. It will look like wind is playing with the smoke and pushing it around if you tune it right. Unity uses something called Berlin noise, a smooth, organic random pattern to generate the disturbances. It's one of the most powerful and easy to use features here. I turn on the color over lifetime module and click here to open the gradient editor. Alpha breakpoints are up at the top. I click here and here to add 2 more breakpoints. I want particles to start invisible. Alpha is 0. These 2 breakpoints will be alpha 200, semi-transparent, and the end of the particle's life cycle will also fade out at alpha 0. The bottom breakpoints represent color over lifetime, so I want the particle to start orange or yellow, glowing hot, and end completely black. I can move these along the bar to tweak it and get the effect exactly as I like it. I tweak velocity over lifetime values. I turn on size over lifetime, click the size curve, and choose one of the predefined curves down here. Maybe this one. Start small and grow. I adjust start size 0.2 to 1. Emission rate over time will be 2 to 10. And I reduce the noise strength here. Start lifetime 4 to 5 seconds. Start speed 0.05 to 0.25. Feel free to keep tweaking any of these values to get exactly the effect you want. I created a lava level, so let's add this directly to my game scene. I drag the smoke particle system into Prefabs particles, turning it into a reusable asset. I open the lava scene, and drag the smoke into the scene. I want it to rise from these small hot lava pools. It's been drawn behind the tiles, so inside the renderer, sorting layer is set to my topmost UI layer, order in layer is -1 behind the UI. Back in the color over lifetime module, I want the yellow color to match the lava more closely, so I click this breakpoint, select the eyedropper tool, and I sample the lava color. Now it fits into my game world even better. I duplicate this adjusted smoke effect in the scene, use the move tool, and place it over the other lava puddle here. Another duplicate, and I move this one over this hot lava puddle. Another duplicate can be coming from this big lava field itself. I duplicate again, and put one into this other lava lake. We put those darker spots inside the lava fields, so I make the smoke rise from these. I duplicate again, and place one more over this lava puddle behind the tree. I create an empty game object called particles and nest them all under it to keep things organized. I open main menu scene, level manager, and I make sure level 2, my lava level, goes first for testing. I can also drag the smoke effect into the main menu scene if I want. I drag the prefab out, set its sorting layer, color over lifetime, sample the lava color again, duplicate it, and place the second one somewhere here. I play to test it. This looks great. I test my lava level. And yes, we have smoke rising from the lava pools, enhancing the atmosphere. You can tweak the intensity of the effect yourself. I'm here just to show you how things work. I'll leave the individual design decisions to you. I go to the new scene and delete the smoke effect because I have it saved as a prefab. And I right-click and go Effects, Particle System. Unity creates a new particle system and I rename it to Spores. In the inspector, I reset the transform. I go down to the renderer module, and inside the material field, this determines what the individual particles look like. I can choose one of the existing materials. I'll go with default particle. I set the sorting layer here. Start lifetime will be random between two constants, 2 to 4 seconds. Start speed will be very slow, between 0.01 to 0.05 units per second. Start size is random between 0.05 and 0.1. I want tiny mushroom spores. Max particles 500. The shape from which the particles spawn will be a circle, since this is a 2D game. In the emission module, rate over time will be random between 10 and 20. The burst module allows you to emit a sudden batch of particles at specific times. Each burst has several parameters. Time, when the burst occurs in seconds after the particle system starts playing. Count, how many particles the burst emits at that time. Cycles, how many times the burst repeats within each loop. Interval, the spacing in seconds between each burst inside a cycle sequence. And probability, the chance that the burst will occur each time it's scheduled. I enable the noise module, which gives the particles chaotic movement. I like this because it looks like wind is playing with the light particles. Strength will be random between 0.1 and 0.4, and scroll speed is 0.1. This makes the turbulence look like it's flowing rather than staying static. In color over lifetime, I select the start color here. I set the start opacity to 0, fully transparent. I click here to create a new breakpoint with alpha 255, fully visible. The end breakpoint will be alpha 0, and I add another fully visible breakpoint right before it. Particles will start and end invisible, and they will go from light yellow to white over their lifetime. The shape from which they are emitted can also be a box. To better match the mushroom images I'll have later, I switch to a box and adjust the size and position. Maybe a rectangle, like this, is good. In size over lifetime, I click the size graph and choose one of the predefined curves. I can also move the handles around to create my own custom size curve. Particles start small, grow and shrink again. I'm happy with this, but feel free to keep tweaking and make the effect your own. Let's try putting them in a game. I go to Prefabs Particles folder and I drag my spores particles in here, turning it into a reusable asset. I open the level 1 scene. With the particles folder open, I identify the game object associated with the mushroom I want to give spores to. I drag it over like this to nest it under the mushroom. I reset transform on the particle effect, switch to the move tool, and I move it higher to align it with the top of the mushroom. That should look like it's producing the spores. Let's add another one to this mushroom. I drag it over, reset transform, and I move it up. I can repeat this and add more particle effects into the scene. When I add a few more and I'm happy with it, I can go to the main menu scene. We have some mushrooms here as well, so I give them animated spores. In Level Manager, I make sure level 1 goes first, so I drag it up to the top. I press play, and now I have nice animated spores in the main menu. And when I click New Game, several mushrooms are producing subtle particle effects. And this is one of the ways you can add an extra polishing touch to your scenes. If you downloaded the source code pack, right now we are here. If you unzip this folder and open it in Unity Hub, you'll have the project at the same stage as we are right now. Check the earlier lesson called How to Use Source Code if you need help opening it locally. We already created a playable Windows and Android mobile build. Let's learn how to export and publish our game online as a web game that can be played in a browser, and how to publish it on itch.io, where anyone can play it, leave comments, and if you make something really special, you can even sell your game on there. I delete this new scene. In Level Manager, I make sure levels go in this order: 1, 2, 3. On Persistent UI Canvas, we have this canvas scaler component set up like this. I need to do the same on main menu canvas. I set UI scale mode to scale with screen size, and reference resolution is 1920 x 1080. I go to project settings, and I make sure my custom cursor is using a small image. I recommend 32 x 32 pixels because a web game will render the cursor at the actual image size. So if you are using a large resolution image here, the cursor will render huge. Under resolution and presentation, I have to set the default canvas width and height to the same values I gave to my pixel perfect camera, in my case 960 x 540. Now I have to balance my game. I will play with these values for a while. For example, we zoomed out earlier and increased the visible game area, so I want the range of my towers to be slightly more. So I should probably also increase projectile duration accordingly. These are not my final numbers. I will publish my game, playtest it, and I will come back here a few times, tweaking it until I'm happy. The areas we tweak when we balance our game are tower data assets, where I set up properties of my 3 tower types, enemy folder, where I set lives, damage, speed, and resource reward for each enemy type, wave data, where we define individual enemy waves, how often they spawn, and what sound will play when the wave starts. Keep in mind that I can also create multiple wave data assets for the same enemy type. Maybe I want a small wave of fairy orcs, spawn 5 in total, 1 every 1.5 seconds, and another wave where I spawn 100 in total, 1 every 0.5 seconds. This wave will be a late game swarm of enemies where the player should have more towers to deal with them. You can create multiple wave files per enemy to define different patterns. When balancing my game, I also go to these level data files. I define which waves spawn and in what order. I set how many waves must be defeated to win, starting resources, player lives, and enemy spawner coordinates, depending on how we drew the roads that enemies follow through the level. I will first create a playable build, but later I will come back here to tweak these values, customize my levels, enemies, towers, and waves to create the player experience that I want. To build a playable version, I go to File, Build Profiles. If I select Web, I must install Web Build Support module. I click Install with Unity Hub. Alternatively, you can also open Unity Hub, go to Installs, find the editor version you are using for this game, click Manage and Add Modules. Unity tends to move this around sometimes with new updates, but you should be able to find it somewhere in this area. In the next window, I find Web Build Support and I click Install. This will take a while. When it finishes, I close and reopen Unity, and now Web option will be available. I click Switch Platforms. Again, this might take a while. And when it's marked active, we are ready to build a web release. I click Build and Run and choose a folder for the playable web build. It should be separate from the Unity project folder. I have one called Builds, and I select it. Unity will take a while to compile everything. Eventually, we get these files in our build folder. I package them into a zip file. I call it build zip. Now we can publish anywhere. The quickest is Unity Play. Log into your Unity account, create a new project there, and drop the zip file. It instantly becomes browser playable. Each I/O offers the same, plus a lot more. You have to register your account. I already created a nice homepage for mine with a banner, but that's optional. Upload new project. Here I upload a cover image. Recommended size is shown here. I can add screenshots here. I give my game a title. We get a project URL where people can access it. I add some short fun tagline here. Project type is HTML. Upload zip, playable in browser. Here we can even sell the game if we think it's worth money. For now, I set it to 0 or donate, so people can play it for free, but donate if they want. I click Upload Files. I navigate to Builds folder. I select the zip file we just created. I check this file will be played in the browser. Embed options. I try Auto Detect Size. Works for Unity HTML. We have mobile touch controls, so I select Mobile Friendly, Landscape Only. This part might actually be better if we do embed in page and we manually set size to 960 x 540, which are the values we gave to Pixel Perfect Camera. You can try both and see how the game renders for you. I will leave this full screen button unchecked because I think Unity will add one anyway. We will test and see. I put some description for my game here. Genre will be strategy because right now they don't have tower defense option here. I add some tags to make our game easier to be discovered on the platform. No AI was used. Here we can allow comments or even have a discussion board for our game. And I will leave it as a draft, only I can see it for now. Don't forget to release it before you start sharing URL with your friends. I save and view page, and our game is loading for the first time. I can see the URL here. I can edit the theme of the page where I can add a top banner, background image, and embed BG, which is usually a screenshot from the game showing behind this Run Game button area. I will style my page later. If I run my game, you can see that the full screen button is already here, even though I didn't add it. I think this is being added by Unity. I get my splash screens, and we are in main menu. This is the URL you can give to your friends if you want them to play your game, but don't forget to release it. We only have it as a draft for now. Full screen button is working, and when I play, I have a web version of my game fully playable in browser. I will go back to Unity, tweak all the data values to balance my enemies, waves, towers, and level stats, and I will export it again as a playable zip. I can do that as many times as I want, and I can simply update my project like that. I will also style the homepage for my game, and I will leave a playable link for this game I just created in the description down below, in case you want to see how I balanced it and structured the 3-level experience. And this is how you share your game with the world. Quick and easy.